now your video is available, sir. It's your visible. Right. So Dr. Malkhan Singh Gurjar, he has also joined as a reporter. I also welcome him to this session. And Dr. Atul Kumar, I don't know whether he has joined or not.
He is not visible actually.
But Malkhan
Good morning, Dr. Mehta.
Good morning,
we are
sir.
actually never in
Morning, sir.
We have never met actually.
Yes, sir. I am audible, sir.
You are audible.
Good morning, sir. Good morning to all.
Good morning, sir.
So, Dr. Atul.
Dr. Atul, I think, has not yet joined, sir.
Must be joining.
Sir, good morning, sir.
Yeah, good morning, ma'am. Good morning, ma'am.
Sir, shall we wait until completion of plenary session, sir? Or
actually, I was just talking to Dr. Dinesh Singh. He asked that if you all are available, you can start the session.
Okay.
Because it's a separate link for this session, so we can start. But still, we have to wait Dr. Atul Kumar, who is a reporter for this session, because he has proceeding. So we must wait him. He must be joining in 2 minutes.
Okay, sir. We will wait.
Yeah. For a few minutes, we can wait.
Good morning, sir. I am Dr. Shabir from ICR NRC Grapes. Dr. Hamad
Good morning,
Shabir.
sir. Welcome, sir. Welcome to this session.
Yeah, sir. Thank you.
Dr. Atul, sir, also joined, sir.
Good morning, everyone.
Dr. Atul, good morning. Good morning.
Actually, I was thinking that the plenary is going on. So then Malkhan told that okay, you joined for this. Then I left that session.
Yeah, I inquired from Dr. Dinesh Singh. He asked that if everybody is available, then
only we can finish in time also.
Yeah. So, Madam
Yes, sir.
Jayashri,
Yes, sir.
Madam Jayashri,
Yes, sir.
yeah, you
Yes,
can
sir.
start.
Can start, sir. Okay, sir. Good morning, all. A warm welcome to the technical session 2B of this conference, that is pre-harvest practices for quality and post-harvest diseases management. The session will be chaired by Dr. J. Kumar, Dean, College of Agriculture, GB Pant University.
Please, Madam. Actually, Dr. J. Kumar and Dr. Shrikant Kulkarni, they are not available. So now the chairpersons for this session are Dr. D.S. Singh and Dr. Mehta, Naresh Mehta.
Yeah. Okay, sir.
So please make change.
Sorry, sir. Sorry for inconvenience. So just changes is for chairman of this session is Dr.
D.S. Singh.
S. Singh. Okay, sir. And Dr. Mehta. And convener of the session is Dr. S.K. Sharma, Joint Director of Research, Dr. Y.S. Parmar, University of Horticulture and Forestry, Solan. And rapporteur are the Dr. Atul Kumar and Dr. Malkhan Singh Gurjar. So now I request convener to take over the session. Thank you.
Thank you, madam. Thank you for the brief introduction. So I welcome all the participants for this very, very important session on pre-harvest practices for quality and post-harvest disease management. The session is to be chaired by our very eminent and experienced chairpersons, Dr. D.S. Singh and Dr. Naresh Mehta. So I would like to introduce the chairpersons of the session. First, Dr. D.S. Singh, who has retired as principal scientist from ICR Central Potato Research Institute, Shimla. He had his education, BSc, MSc, and PhD from BHU Varanasi. Then he joined College of Agriculture, Rajasthan, Then after that, he joined regular service as junior plant pathologist in 1972 at Central Potato Research Station, Ooty, which he later headed from 1977 till 1981. Then he was promoted as senior scientist S2 and then senior scientist and thereafter principal scientist from 1982. Dr. Singh has made several contributions, scientific contribution in the field of potato and other vegetables, especially in the field of disease control. Dr. Singh is a life member of IPS since 1965, to which he became fellow in 1975. He has been associated with several other national and international journals and has more than 150 research papers to his credit. The majority of them are in the international journals published from abroad. He had got an opportunity to work with Dr. H.D. Howard, who was guide of Dr. M.S. Swaminathan, ex-DGR ICR, and Dr. Singh. Dr. Howard had been a visiting scientist to Ooty since during 1977 to 1979, and while he was working in Ooty along with Dr. Howard, he evolved one variety known as Kufri Swarna, which is resistant to cyst nematode. And this variety must be very, very useful because the cyst nematode has become a very serious problem in India for the last 2-3 years. So this variety must be very, very important during this time. And his main field of research was in mycology and plant pathology. So I welcome you, Dr. Singh, for this important session.
Thank you, Dr. Thank you, Dr. Sarmani.
Another chairperson for this session is Dr. Naresh Mehta. He hardly needs any introduction. He is well-known scientist, retired from HAU, Hisar, and he's known for his work on rapeseed and mustard. He worked for a long time on this on these crops. He has written so many books, especially 4 books he has mentioned. He has written 4 books. So he retired as a associate dean, College of Agriculture, and professor of plant pathology. And currently he is working as consultant faculty in the Department of Plant Pathology of CECS HAU Hisar. As I already told, he has worked on rapeseed and mustard, and he is currently integrated disease management in rapeseed and mustard. He is one of the authors of 4 books published by international publishers, and I have published more than 100 research papers in national and international journals of repute. He is editor-in-chief of Indian Journal of Mycology and Plant Pathology and in the editorial board of Indian Phytopathological Society, New Delhi, and Indian Society of Plant Pathologists, Ludhiana. So, Dr. Naresh Mehta, I welcome you for this important session on post-harvest disease management.
Thank you very much. Thank you very much.
So, for this session, there is one lead paper by Dr. Gururaj Sukan, Associate Director of Research, and 7 invited papers. And under the oral papers, 8 papers are listed. So I don't know how many of them are. And over to Dr. D.S. Singh for the lead paper to be presented by Guru Rasukan. And the paper is on management of post-harvest diseases of horticulture crops under protected conditions as influenced by changing climate scenario. So, Dr. D.S. Singh, please.
Rachu Center, please keep your mic muted. Rachu Center.
Thank you, sir. Now I think you can start the session by the lead paper to be presented first.
Sir, I would like to say something. It's my
Yes.
pleasure to have Dr. D.S. Singh is
Yes, please.
is with me, and I am lucky that today I am having the blessing of Dr. D.S. Singh, very senior person, and I hope you might be knowing Dr. D.S. Singh, might be knowing Dr. G.S. Aram.
Oh, yes.
Yes.
Very well.
हाँ, वो मेरे गुरुजी हैं सर.
I know most of them right from actually Dr. Chan and others.
Yeah. So I feel and Dr.
Actually, in
Aram,
fact, I tell you, in 1965, I was appointed at SIU. But
Okay.
I did not join because
Okay.
I had a better post than that one.
Okay then. So I feel you're like my Guruji, and your blessing will help me to
Please.
complete my what assignments I received. That is, so it's my pleasure today. I have you, and with you that I will be, you can say, blessed with all kind of your blessings.
Yes,
Thank you very much. It's my pleasure.
Sir, Chairman, sir, do you have the biodata of Dr. Gururaj Sukand,
Yeah.
or should I read it?
You can go ahead as you feel proper.
Yes, sir. So, Dr. Sukand, please, before you start, I would like to place your biodata before the audience. So, Dr. Gururaj Sukand is currently Associate Director of Research and Professor and Head, Department of Plant Pathology, University of Agriculture Sciences, Raichur, Karnataka. He is a he has obtained his MSc degree in plant pathology from University of Agriculture Sciences, Dharwad, then postdoctorate fellow at Washington State University, Pullman, USA, through joint support from US and Raichur and USAID IPM CSRP project. He has visited several countries, and he was a delegate to Bangkok, Thailand for working group meeting on groundnut, bacteria built and stem rot. He has presented several papers in national and international conferences. His expertise is in mycology and plant pathology, molecular plant pathology, PGPR and biocontrol, host plant resistance and IDM. He is actively engaged in teaching and research and guided more than 20 students for MSc and PhD degrees, and many of his students they have got many awards such as DST Inspire, Rajiv Gandhi Fellowship and University Gold Medals, and presently serving in various government and private organizations. He has more than 100 research publications to his credit in national and international peer-reviewed journals. He is associated with the release of 6 groundnut varieties and registration of 8 multiple disease-resistant ground genotypes, and at NVPGR, 35 disease management technologies to the university package of practices, mass multiplication and popularization of bioagents such as trichoderma and pseudomonas. He has got various awards. Few of them I would like to mention: that University Best Teacher Award, Distinguished Scientist Award, then Scroll of Honor of IPS, Honorary Life Membership of Asian PGPR Society, USA, for Best Oral Presentations to his credit. Then Shri Rameshwar Swamy Kachpur Memorial Award, and so many other awards. So he is a fellow of Indian Society of Oilseed Research, Indian Phytopathological Society, and Society for Biological Advancement, Indian Society of Mycology and Plant Pathology. So I request Dr. Gururaj Sankat to please present his lead paper on management of post-harvest diseases of horticulture crops under protected conditions as influenced by changing climatic scenario. Dr. Gururaj, please.
Good morning, sir. Thank you. Thank you for having given the opportunity to present the lead paper. Today, I am really luckiest to, first of all, Good morning to the chairman, the co-chairman, and all the delegates of this meeting. And also, I am lucky that my guide, he's a chairperson, Dr. Srikant Kulkarni sir. He's a chairperson of today's the session, and also the Jay Kumar. He's also chairman, and conveners and all the rapporteurs. So first of all, this is the topic of my lead lecture, that is management of post-harvest diseases of horticulture crops under protected cultivation as influenced by changing climatic scenario. So this is just to show you what is the extent of the population in developing countries and then developed countries. Just this slide is just to show that in the population is more in the developing countries like India and other countries, and the population is very less in the developed countries. So in other words, they have more sources for the management of diseases, like for sources like they can afford to afford for chemicals and other fungicides for management of plant diseases. And this is about the importance of plant diseases because as we know, the loss caused by plant diseases is almost 14.1% as compared to weeds and insecticides, put together 36.5% loss. And the worrying thing is malnutrition in developing countries. And we know the story of late rate of potato way back in 1845, and this has actually opened the eyes of all the scientists to work on the plant diseases. And this is about the diversity of plant pathogens. If you see fungi, they dominate the plant pathogens. More than 80,000 species of fungi have been reported so far. And the estimate is given by Hawksworth. And the thing that the most important worrying thing, that is the climate change, what we are experiencing nowadays. So the IPCC, it has actually reported the climate change and what is the impact of climate change on agriculture, particularly on yield of croplands. And this is not only on agriculture, even on other the sectors also, the climate change has an impact. And this is the climatic change scenario in the globe. And already the temperature has been increased by 1 degree, and it is likely that it is going to increase by 5.8 degrees by 2050. And this is the total impact of the climate change. And as a result of this, we are experiencing so many adverse effects. The sowings are delayed, and higher pest and disease incidences, the frequent and persistent droughts, then less water in tanks, particularly dams and canals. And many people are shifting towards other activities and they are migrating to the cities. And these are the factors responsible for climate change. And so as far as diseases are concerned, particularly the in many crops, minor diseases have become a major diseases. And evolution of new races, as we have seen in many diseases, particularly UG99 race, it has evolved. And of course, it has not yet entered India. And increased severity of diseases in Karnataka, particularly sunflower crop, it is totally, earlier there was no disease at all. Nowadays, we are observing the severity of the powdery mildew, the sunflower necrosis, then leaf curl virus, and these are all and the most another important thing is effect on our biocontrol agents. And these are the impact of climate change as noticed in different parts of the country. And particularly in Karnataka and Maharashtra and other states, wherever the pomegranate is grown, because of climate change, the bacterial leaf blight. So it has actually caused a havoc, and totally the loss has been occurred. And another disease is pomegranate wilt. This is caused by Cytocystis fimbriata, and now it has become a nationally important disease. And papaya ring spot. There are many post-harvest diseases as a result of climate change, and this is about pesticide consumption in the country, and this is also another factors. And the damping off is one disease, which is a juvenile disease, which is responsible for in certain crops, then downy mildews, then powdery mildews, then leaf spots, then anthracnosis, then wilts, then rust, then bacterial leaf spots. Then other disease, post-harvest diseases are also, they have an impact on climate change. And these are the list of diseases as a result of climate change we are experiencing. Pardon me, sir, there is some disturbance in the internet. Hello, sir. Hello, sir, Chairman.
Yes, sir.
Hello.
Now it is okay, sir. Sir, please you put on the presentation mode, sir.
Sir, audible, sir, but again slides are not visible.
Just now it has gone away, sir. I think it is taking up, sir.
Yeah, it is internet issue. It will come. No problem.
It's getting uploaded, sir.
Yes, it has come.
It has come, sir.
Yeah, it has come.
It is visible, sir.
Visible, sir.
Okay, sir.
Yes,
Okay,
visible and audible.
Okay, sir. These are some of the diseases which we generally notice and in the under different climatic change scenario. And in case of tomato, if the temperature and humidity conditions are different, and we are going to observe several diseases. Shantapa. Slides are visible, sir.
Yeah, visible.
Yes, sir, it's going well, sir. Sir, please you continue, sir.
Just continue.
ಯಾಕೋ ಸ್ವಲ್ಪ ಇದು ಇಂಟರ್ನೆಟ್ ಕನೆಕ್ಟಿವಿಟಿ ಬಗ್ಗೆ ಸ್ಲೈಡ್ಸ್ ವಿಸಿಬಲ್ ಆಗ್ತಾ ಇಲ್ಲ ಆಗಿದೆ ಈಗ ಆಗಿದೆಯಾ ಆಗಿದೆಯಾ ಹಲೋ
Sir, you please continue, sir. We are seeing the slides.
Okay, madam. The slides are visible. Okay. So these are some of the climatic impact on the diseases, and several new diseases have actually occurred. One of the example is sunflower, and other crops are also in Karnataka, sunflower, pomegranate. Then in paddy also, earlier we used to notice only blast of rice and maybe bacterial leaf blight. And recently, false smut caused by utilizinated virus, it is becoming severe. And so also the stem rot is coming up, and grain discoloration is another problem. So likewise in other crops also, there are so many the post-harvest diseases as well as the other diseases. And for management of these diseases, we have to go for the environmentally sustainable slides, slides, slides. For the interruption, chairman, co-chairman, and others. Am I audible, sir? Sir?
Yes, sir, you are audible, sir. And
But somehow there is some internet, the connectivity problem is there.
Sir,
Yes, sir, continue.
Problem here, sir.
your voice is audible, sir. You please continue.
Sir, I am unable to share the slides actually, and maybe
you can go extempore also, no problem. You can go extempore because
okay, sir.
Okay, already covered. Yeah.
Okay, sir. These are some of the problems that we are facing as a result of climate change in different crops like pomegranate. Then in groundnut also, in the new crop, the stem rot and other diseases are coming up. Sunflower, paddy, then horticulture crops, and several problems are there, sir. So because of this, nowadays the strategy is to go for the environmentally sustainable management of these post-harvest diseases as well as newly emerged diseases. And for this, there are several the measures we can recommend to the farmers, particularly for post-harvest diseases. The treatment of the seeds with the new fungicide molecules. Nowadays, many fungicide molecules they are available. Like earlier, we had only carbendazim and thyram, Capton, and other fungicides. And now we have so many new molecules. Sprint is one such molecule, which is a combination of carbendazim plus mancozeb. It is very effective against many the post-harvest diseases, particularly in case of groundnut. We are facing a problem of aflatoxin. Aflatoxins, that is the post-harvest problem in case of groundnut caused by Aspergillus flavus. And for such problems, such seed treatment chemicals can be used. And in case of chickpea is another crop. Maximum area is under chickpea in parts of northern Karnataka. And in chickpea also there are certain post-harvest diseases. We have recommended, we have tested a chemical called as available as Gelaro, which is also very effective. We can go for seed treatment of such chemicals. And apart from this, in case of fruit crops, so many post-harvest diseases occurs in food crops as well as vegetables. In such crops, the dipping of either fruits or the vegetables in the fungicidal solution containing carbendazim. And also nowadays, a lot of importance is given for the bioagents. So we have we are mass multiplying bioagents, and we have Organic Farming Research Center here. Every year, for plant growth promoting microorganisms such as the trichoderma as well as pseudomonas, they are multiplied on large scale, and we can exploit such microorganisms for the management of these post-harvest diseases, either by treatment of seeds or or dipping of the materials in the bioagent solution. And apart from this, we can also recommend some other practices for management of these post-harvest diseases as well as newly emerged diseases. This is all about the presentation. Sorry, sir, because of internet connectivity, and we could not put the slides properly. If there are any questions, please let me know, sir.
Dr. Mehta, we can have 1 or 2 questions quickly.
Yeah.
Yes,
Yes, anyone among the audience who can ask any questions, please?
If none, then
Yes, sir, you unmute yourself, sir. Yes, sir, unmute yourself. Chairman, sir, unmute.
Dr. Guru Raj, I may
yes.
ask one question.
Please, sir.
Please go ahead.
You have working with this different crops. What
Yes, sir.
about the different nematode management, particularly in protected cultivation?
Okay, sir. For management of nematodes right now in protected conditions, the resistant varieties, of course, on nematode management, the carbofuran is one chemical, and also the neem seed kernel powders, neem seed kernel powder. So that can also be used for management of nematodes. But the host plant resistance, as you were teaching during MSc, the host plant resistance should be given top priority, sir, because in nematodes also nowadays the races and also the biotypes are actually evolving. So resistance is one best option for the nematodes, because as we see, nematodes, they are called as unseen enemies. Of course, they do not cause that much loss when we compare to the fungi, bacteria, and viruses and other diseases. But still, host plant resistance is the best way to manage the nematodes, sir.
Actually, what happened? This nematodes have very, very wide host range.
Yes, sir.
So in these protected cultivation of polyhouses, etc., normally we go for one crop or another crop, then subsequently crops, and we do not find any time to go for any cultural practices or to due to high temperature or due to some other means or to apply the carbofuran, etc. That becomes difficult.
Yes, sir.
So, and once nematode enter in protected cultivation of polyhouses, it is very difficult to eradicate.
Yes,
Since we are working on this one, that's why I thought that I may ask this question.
Yes, sir. You are right, sir. Correct, sir.
Yeah.
So, Dr. Mehta, then we can move to the invited papers, invited lectures.
Yeah, you can move.
Let us move to the invited lectures. Now there are 7 invited lectures listed for presentation. And for the speakers, I would like to request the time allowed is 15 minutes for the invited papers. So please be within the time limit while you are presenting. So with the permission of the chair, I would like to invite the first.
Dr. Dhiman.
Yeah, senior scientist at IRI Regional Research Station, Katrai. Is available. Is he available? Dr. M.R. Dhiman.
We can take later on. Now you may call next one.
Yeah, then we can move to the next speaker, Dr. Ahmed Shabir. He's
Yes, sir.
available.
Yes, I'm here, sir.
Yeah, so Dr. Mehta or Dr. Singh, if you have the biodata of Dr. Shabir, you can.
I think, sir, there is no biodata for invited lectures. I think.
No, it's there. It's there for invited lectures. It's there.
It is here.
Yeah, yeah.
So,
So,
Dr. Sharma, I may have small
Yeah.
one with me, though their list is there, long list is there about the Dr. Shabi. He is working as senior scientist in agriculture chemistry and in the NRC grapes, very important center for looking after the grapes, etc. Since very valuable crop, horticultural crops for export and other things. And he has done very good job in doing this ICR, agriculture chemicals, and in charge of some other things. I may brief it. One of the brilliant scientists working on this NRC. So I don't want to go in detail. That's one page is there. So it will, I think, if you excuse me, it will, you can say we will go across our time. Keeping in the time limitations, I can say he has done very good job. He has also advanced analytic methods, analysis, etc. He has done US FDA fellowship, etc. APIDA also, and so many other assignments and the other recognized. He has more awards and 5 MSc and 1 PhD student he has guided. And I think one of the bubbling scientists with us. You may ask, please carry on. Start your lecture, please.
Is the slide is visible, sir?
Yeah, yeah.
Okay, thank you so much, sir, this introduction. And I am very much honored to present a topic which is not very known to the pathologists, I say. And I am presenting in front of the pathologist of plant protection scientists. And I am sure this presentation will be very useful for all the plant protection scientists to manage pesticide residues in horticultural crops. So the title of the topic is the pesticide residues in horticultural crops, a post-harvest problem to be tackled at pre-harvest. The strategies and perspectives of these pesticide residues I will be briefly giving in this presentation. So we all know India is one of the largest producer of fruits and vegetables. And India export fruits and vegetables worth around 10 crores of fruits and vegetables getting exported from our country, and almost 21,000 crores of spices worth exported from our country. So this horticulture sector itself is a huge earning in terms of foreign exchange for our country. But if you see the total international trade, our contribution in international market is less than 2%. So why this international trade contribution as far as the globally is concerned, it is very less. So there are some gap our nation need to be addressed. So in entire my presentation, these strategies to be followed to fulfill this gap I will be dealing with. So the main issue associated with trade is global food safety challenge, which need to be addressed in the international trade. The one of the important thing, growing concern over the food safety in everywhere, as the consciousness among the consumers is increasing as far as the food safety is concerned. So the every country will be having their own food safety regulations, and overall internationally there is a regulation of codex also. But as an exporter, it is the responsibility of the exporter to comply with the regulation of the importing country. So every country is having different regulations. So that makes one concern of the exporter to meet this regulatory requirement. And the importing countries issue some of the alerts because of the exceedance of the pesticide residues or any contaminants above the prescribed limit in that particular commodity. And in order to comply with this regulation, there is sophisticated testing and certification requirement is there. That is many times it is unable to attain by the exporter, and harmonization of this requirement is already an unattainable goal everywhere because every country is developing their own quality standards. So what we really lacking is we lack a strategic approach to manage the pesticide residues in horticultural crops. So first of all, we have to be very clear what is the issue associated with this pesticide residues. There are two issues we have to be concerned. One is a trade issue, another is a safety issue. I always feel that as a agriculture scientist, many of us has mistaken the issue of pesticide residue. We consider it as a safety issue. But safety issue is generally addressed when a pesticide is getting registered in a country. But as an agriculturist, we have to be more concerned with the trade issue, where the economic implication of the residue comes. Generally, the regulatory requirements regarding the particular pesticide, for MRL complaints, the label claim requirements, the traceability. There should be a surveillance system with the traceability to manage the pesticide residue. But in our country, the trade issue it is basically managed by APEDA, and domestic safety issue, which is managed by FSSI. The tricky thing is the MRL of a particular pesticide is set by FSSI, but it is being applied for trade. So there should be a good complementary interaction between these two organizations and these two stakeholders in order to address the real issue of pesticide residue in the horticulture commodities trade, both domestically also, internationally also. So now I would like to explain each one issues because unless until we don't understand the real issue, we won't be able to address the issue. So what is the real issue? First one is ever-changing import-export regulations. And if you see the regulations, different MRLs for same pesticide in different countries, say carbon dioxide. If you want to export one of your commodity to Europe, carbon dioxide having one limit at Europe. If the same commodity, if you want to export to Russia, Russia is having another limit. So how these limits are being attained? How do we address these issues? This limit for an export commodity, we have to be very clear. Then change in MRL from time to time. The same commodity, today it will be one MRL in European Union. Tomorrow, the European Union changes its MRL based on some of the toxicological studies or some other scientific databases. So that also become a hurdle. So every strategy which you adopted till now has to be changed to not address the change in regulatory limit. And there is some system in every country. If this toxicological data is not available, if the label claim requirement is not available, so scientific basis MRL is not established, there is a default MRL. Default MRL means minimum level of that particular pesticide in that commodity. That is most of the time become unachievable task for an exporter or grower to meet that requirement. So different MRL for same pesticide in different crops. That is also is there. So these all issues make the attaining the changing exporter import requirement very unattainable goal. So we have to be very clear why the different countries have different MRL. Many times in many forums, I also seen why this MRL is different is there. So we have to understand very clearly here that MRL is set based on the good agriculture practice. So good agriculture practice as a pathologist or a plant protection scientist, you people decide good agriculture practice based on the pest or disease infestation strategy in a particular crop. So this infestation of pest or diseases will be different for different countries based on their climatic condition. So the gap recommendation of a particular pesticide changes with the country to country. Accordingly, their residue level approved in gap also changes. According to the MRL also will changes. That is the main reason why the MRL is different in different countries. So we cannot challenge any country. Your MRL is very low compared to our country because their gap will be different. Our gap will be different. Now, another issue in our country is limitation in availability of label claim pesticides. I am sure all the plant protection scientists will be recommending pesticides for the control of many pesticide diseases. But is it legally permitted to recommend a pesticide which is not really having label claim in particular crop? If you see the list of CIB registered pesticides, more than 250 pesticides have been registered. But if you see the horticulture crops, brinjal, grape, pomegranate, cardamom, in spices, very limited pesticides having label claim. So what farmers will do? Farmers is forced to apply the pesticide which is available in the market because they have no other option other than to use chemicals for control of pesticide because crop is more important rather than the legal issues. So the farmer is forced to apply some of the pesticide which is not recommended legally for that particular crop. use of such pesticide, even though MRL is compliant, presence of that pesticide residue in the final produce is a violation of good agriculture practice. As a plant protection scientist, we have to be very clear, this is a violation of good agriculture practice, because every exporting country will ask the gap recommendation from our end in order to facilitate the trade. So presence of such chemical in the final produce, even though it is within the limit, is a violation of the gap. Another thing, in the name of organic agriculture, farmers use lot of biopesticide in the name of plant extracts. This is mainly it is uses in the later stages of the crop, because later stages pesticide is applied, they are afraid that it contains residue, the final produce may have residue. So they rely more upon the biopesticide. This is one of the major hurdle in our export, because biopesticide, when we develop, from huge quantity, it is been extracted to very small level. So if any small amount of pesticide with the contamination also present in the source material, that will become a big residue in the final biopesticide which is generated. So ultimately the harvested produce got some of the residue at the very low level, but the pesticide is not recommended, or very low MRL requirement might be there. So that become a issue. And another thing, in the biopesticide plant extracted, there are some chemical which is intentionally added in order to protect the extract. So this extract is itself is a biological origin, so there is a chance of infestation of any fungus or bacteria within the extract. In order to prevent that, they add some of the chemical. That chemical is not having registration anywhere, so they have a very limited, very low MRL level of 0.01. So that also creates issues in our export scenario. Another thing, lack of traceability system. In every importer demand, there should be a surveillance mechanism in your country if any issue comes in the importer side. So what is the mechanism you are having? So we really lack such a system in our horticulture system. So what are the important components of such system? There should be a surveillance system. If any issue comes, there will be a surveillance mechanism in the system. And what to be tested? What is to be tested in that system? If any non-compliance is there, it can be identified only on testing. So what is to be tested? If you send something to European Union, they have around 600, 700 pesticides in their list. Can we able to test all these things? And in our country also, it is registered at 250 plus pesticide. Can we test all these things in a commodity? It's not possible. So what strategy we have to adopt to test all these things? It has to be very clear. And in order to test that one, what sort of analytical methods we are having? If you see the entire range of pesticides, minimum around 6 methods you have to test in order to comply all the pesticides. Whether we have a capacity to analyze all these things, whether we have the manpower, technical manpower in order to handle this type of advanced analytical instrument or advanced extraction protocols, that is also a issue in our country. But even though this all issue, as we all know, without pesticide usage, without pesticide formulation, it is very difficult to go for a commercial horticulture. Our Nobel laureate Norman Borlaug, it is clearly mentioned, agrochemicals have been contributed to increase production of food and non-food crops by reducing pre and post-harvest losses. Complete ban on pesticide use in agriculture might result in 50% reduction in global food production and 4 to 5 times increase in food prices. So can we afford this ban of pesticide? Exactly, we cannot afford the ban of pesticide. So what is the option? We have to live with pesticide. So with this pesticide, we have to control the residues. So what sort of strategies we can adopt to control the residues in the final produce after the usage of pesticide? So I already told the pesticide residue is a post-harvest issue. Once after test, we came to know that there is a residue, there is no option to control. So testing will identify only the problem. Where you can control before the testing, that is at the field level. So what of the strategies we can try at field level to control it? So here I give the example of my crop, that is the grape, how we control the pesticide residues in grape with the very close coordination with the APEDA, Ministry of Commerce, and different stakeholders. So it is a completely internet-based traceability system that is called GrapeNet. This is a very ideal system. It is a system which is very widely referred across the globe for a pesticide residue management. So I will brief it in coming slides. In the background, how this system has been established. In 2003 and 4, when Indian grapes exported to European Union, there was some non-compliance raised by the European Union because of the experience of carbendazim and methyl above the prescribed their MRL level. And they issued a notification to Indian government that your grape is having residues above the limit which is prescribed by us. Unless until you establish a system in your country to control this, we will not take any grape further from India. It is not the case of grape. Once the grape is getting affected, it will be affect all other horticultural commodities. So it was a major threat for Indian export of horticultural products. So India government forced to establish a system in our country for management of pesticide residues in grape. And it was started in 2003 for identifying a National Research Center for Grape as the national referral laboratory for control of pesticide residues in export. So system is having few unique features. That is adequate monitoring, because every consignment which is going from our country is being tested. It is 100% testing has been incorporated. Then there is a surveillance system. Surveillance system in the sense, if any issue comes, there is a mechanism within the system to address that one, issuing some internal alert generation. And there is a preventive and corrective action also. If any residue detected, what is the corrective action we can take? That system has been incorporated in this. So this is the unique traceability system which was established. So it is our 10-digit number will be there in each consignment. This is the 10-digit number. This number, even if 1 kg grape you purchase in the exporter market, European Union market, this digit will be there with that grape. This will identify from which stage, from which taluk, from which village, which farmer, and which plot this grape is being developed. So we have all the data of that plot, what they have sprayed, what cultivation practices they followed, whether they are using an illegal chemical or not, what sort of irrigation they have followed, what sort of soil contamination is there. All the data, it is already there in the database. So this is the unique traceability system which follow with every grape which is exported from other country. So what we have firstly done, a major role of our laboratory was to see once a pesticide is applied in a crop, it will be having a residue level at the time of application. So once this applied, it will be slowly degrading naturally in crop, and it will be finally coming to zero. So we clearly identify what is this pattern of degradation. So how long it will take a pesticide once after application in order to reduce the residue level below the prescribed MRL level. Here it is very important to note that this MRL is which you have to consider here is not the MRL of the domestic MRL. This FSSAI set MRL is not the MRL. We have to consider the MRL which is the target market MRL. If you are exporting to USA, you have to consider the USA MRL. If you are exporting to EU, you have to consider European Union MRL. So how long it will take to achieve the residue level below that MRL level? So we prescribe based on that a pre-harvest interval that indicates if a pesticide is applied before harvest, we have to wait minimum that period, that is 20 days or 30 days, PHA 30 days, you have to wait minimum 30 days so that your residue will be below the MRL level. So what we have done, whatever pesticide it is being used in this crop, grape, we have done the field trial for this one and identified what is the PHA level of that pesticide in order to achieve the European Union MRL level. So accordingly, here is that value pre-harvest interval, which is recommended to growers, and this is being disseminated 100% to the growers so that they can follow the pesticide. In the grape, there is no pesticide application schedule. There is a lot of pesticide. For example, downy mildew. There are too many pesticides will be available for the control of downy mildew. From this, everyone will be equally effective also. From this list, which pesticide a grower will select, that will be based on the pre-harvest interval and the time of the infestation. So that the final harvest produce, he will be knowing what is the harvest time. So harvest produce will be having residue less than the prescribed MRL level. So that is the first thing which you are done. Then second thing, what is to be monitored? Only 50 pesticide is being recommended in grape. But only this 40-50 pesticide monitoring will help us? No. Importing requirement is pesticide, whatever possible has to be monitored. So what we have considered, we have considered all the possible risk, all sort of sources of further pesticide residue can come in grape. So all the possible application of the recommendation in the nearby crops, all the possible recommendation in the common diseases. So every pesticide which is being included in our list of monitoring. So now we are monitoring around 268 pesticides in every consignment. Okay. Then what sort of analytical protocol we have to use for this one? So this analysis protocol, our in the laboratory was not knowing how to test this pesticide. So our laboratory generated the protocol for this one. So now we are having a method which can analyze more than 300 pesticides in a 20 minutes time. So this method has been transferred to all the commercial food testing laboratories, which is recognized by APEDA. And now in India, all the commercial food testing laboratory which is involved in export testing is mandatorily using the analytical protocols which is developed by our laboratory. So this is the impact of the system. So initially it was started in 2003-4. There are 20% of the consignment was rejecting internally because of the experience of residues. Now it is reduced to less than 5%. Not only less than 5%, in this season, it was only 2% of the grape was being rejected internally for the complaints. And there was no external complaints problem. From European Union, there was even single complaint was not there as far as grape is concerned. But one important thing is whether this only MRL complaint is required, market requirement? No. The current market requirement is the pesticide residues has to be as minimum as possible. Not only the MRL complaint, it has to be as zero. If it is zero, then it is best market. So such products, minimum residue products, you will be having 20 to 30% price realization in the importing market. There are some specialized markets where only this type of commodities are allowed. There will be very costly market. Lot of price realization will be there for the growers and exporters. For in order to achieve this current market requirement, what sort of strategies we can follow? Here, what we have done, initially our objective was to reduce the residue below MRL level. That we have revisited at the field level. That means we have given the pre-harvest interval considering the residue level 0. So if this is the MRL level and this is the BLQ level, means no residue. So we have extended the pre-harvest interval from here 15 days to 60 days. So that if any grower follow the 60 days PHI before harvest, his residue, his commodity will be having no residues of this particular pesticide. Accordingly, we revisited all our PHI values and we recommended a PHI for MRL also. We also recommended a PHI for zero residue also. So based on the infestation time, the growers can select which pesticide has to be applied so that MRL is complete, which pesticide has to be applied so that no residue will be there. So accordingly, we have revisited all this one. And based on this, we given some strategies for growers to apply in the field level so that their harvested produce will be having minimum number of residues or many times zero residue. So what are the strategies? First means available labelliculum chemicals. So it is mandatory that only the label.
Excuse me, time limit with chairman, sir. Please kindly restrict the time.
Yeah.
Sir, it's only 2 minutes.
Please conclude.
Yeah. So these are the strategies. Only labelliculum chemical has to be used. The dissipation pattern of the pesticide to be considered. Targeted MRL to be considered. Analytical method to be considered. The strategy, for example, 1, mealybug infestation. The crop has to be harvested 50 days. Time is there. So these are the pesticides available. So which pesticide to be selected? Here the pesticide C is the best option because pesticide C is having MRL of 0.01. If this is complete, there is no residue will be present in his products. And second strategy is here is that there are downy mildew, 60 days time is there to harvest. So 3 pesticides are available. The pesticide C will be the best option because it is having minimum MRL so that if complete, the residue will be minimum. And strategies at a given point of disease infestation, use the class of pesticide which are analyzed as common derivatives products. So dithiocarbamate. There are many pesticides in the dithiocarbamate. If you see the analysis of dithiocarbamate, if 5 pesticides also we applied, you will be having only 1 residue in your test report because dithagomid is analyzed as a common product of CS2. So that is the analysis we have considered. And avoid use of pesticide whose residue definition include its metabolites. So the metabolites residue pesticides, the number of residue detection will be there. Such type of chemicals you have to be avoided. And finally, you have to use very low risk fungicide because many fungicide will be having resistant development. And if resistant development, if farmers is forced to use many times, so more residue will be then such chemicals to be avoided. Then alternate chemicals, there are sulfur, potassium bicarbonate, chitosan, this type of chemical, which is not regulated. So that there is no MRL is there, so there is no testing is there. So such chemical, if used also, there will not be any issue. Then avoid use of organic formulation before testing it. But identify the purity of the organic formulation for any pesticide, and then after the testing, you use that pesticide. So finally, all we are implemented in grape, and we have a certification procedure of 0 residue grape protection has been started. And last year we have around 20 field has been certified as 0 residue, and they got very high price for in the domestic market also. And finally, all this is possible only if all the stakeholders involved in this chain is been integrated, say the academicians, the growers, exporters, regulators, APEDA, Ministry of Commerce, then FSSI, everything has to be integrated together, and the information has to be finally inseminated to the growers. Then only we can achieve all these things so that we can produce residue-free, pesticide residue-free commodities, and we can facilitate our export. So in conclusion, we can tell, use only the lab-equivalent chemicals and apply the MRL of the target market, not only the domestic market, and follow the scientific based strategies of pesticide formulation, which will ensure only MRL compliance grade, but also 0 residue commodity and ensure better price relation for the farmers. Thank you. If you have any questions, I am always welcome. Thank you, sir.
So thank you very much for your nice presentation, Dr. Singh. You can have 1 or 2
nothing.
questions if you're.
He has given a very relative detail about this. I have no question. Thank you. Thank you very much.
I have one question, please.
Yes, sir.
Dr. Sudhir, you have presented very well, no doubt. But I feel that in case of MRL, the problem lies with the administrators, means the government of India.
Yeah.
I remember when I was student during, you can say 70s, 80s, we raised the problem, demand rather, I will say, that this pesticide shop should be given to the agricultural graduates. Actually, vendors, they are selling their pesticide with the objective to earning the money.
Yeah.
And these chemicals are being sprayed frequently with the 1 day interval. You have mentioned that there should be 60 days gap instead of 15 days, then there will be no residual limit. But we are facing it day by day since farmers are using these chemicals to earn more and more. Number 2, the maximum residue limits or the problems we are facing with the insecticide. Normally fungicides get decomposed, or you can say other activities within a week or so, but the pesticides are being stay there, or they are residues there for long period. Then how to manage all these things?
Sir, you have raised the very good the key points. One is the implementation of this enforcement of these laws lies with the State Department, not with the Central Department. This shop, all these things.
Whether it is
the main issue
is the government. Is the main basic is the government.
Yes, the main issue here is our domestic food safety laws. Domestic food safety law is not that much implemented in our country compared to export testing regulation. You don't see any market in our country, they allow the product only after the pesticide residue testing. So, but if you're seeing in any European countries, if you go, they won't allow any product in their market before testing. Okay, that is so we have to, as a government of India, we have to ensure the laws which are established our own government has to be enforced at the field level. So that is one point which we are lacking. Second thing which you are raising is most of the residue is associated with insecticide. Okay. So the reason behind is mainly the insect pest, which is generally comes when the condition of the crop is favorable for the sector. And most of the time it is because it is when the fruit become mature, because then sugar get developed, so that many of the insects get attracted. So that infestation comes. So that is coming in the later stage, very close to the harvest of the produce. So that time, if you apply the pesticide, the residue will come. And what I'll tell, we cannot generalize this thing. There are many insecticides. They have very high MRL set at the important country, even in our country also. Even is apply 1 or 2 days before its harvest. Your residue will be there, but residue will be below MRL level. There are many insecticides like. So we have to be very well aware of what sort of degradation is there for each chemical. Then only we can suggest this you have to use at this time. This cannot use even though your disease is 60 days before harvest. That time also there are many pesticides cannot use, because there are some pesticides they remain on crop even 90 days also. Even in grape, I remember one chemical cyantraniliprole. This is the insecticide basically. That residue remains in crop even up to 70 days, 80 days. And one entire season of grape export has affected because of that chemical.
One small query with Satish sir.
Yes, sir.
Satish sir.
Yes, sir.
Do we have some questions and answer session in the invited lecture also, lead lecture also? This is just a query. Means
we can ask 1 or 2
it's
questions.
depend upon the chairman. If chairman allows, then we can have 1 or 2 quick questions. Otherwise, not.
Yeah, sure, sir. Because sir, already in oral presentation we have question answer all these things.
Yeah.
Unless it is very essential.
Only 1 or 2 questions we can have in the invited or lead.
It was just a query, sir. As you suggest, no problem. No.
Yeah. But I request all the speakers to limit to the time.
Yes.
Please stick to the time, because I think we have already taken half an hour for this presentation. So I request the other speakers that they should limit their talk to the allotted time limit only. So if Dr. Mehta, please, we can move ahead. So we can have the next talk by Dr. Pooja Singh. Dr. Pooja Singh, she's there, because I'm not finding her in the list of participants.
You may ask Dr. SS Veena.
Then Dr. SS Veena.
Yes, sir. I'm there.
Yeah. So welcome, ma'am. So Dr. SS Veena, she will be presenting on an insight into the post-harvest diseases of tropical tuber crops and their management. So I request Dr. DS Singh, if you have the biodata, please, or Dr. Mehta, you have the biodata of Dr. Veena.
Unmute, sir.
Unmute, sir, yeah.
Mehta, sir, unmute, sir.
Dr. Mehta, please unmute. It's not audible, sir. Your voice is not. Dr. Mehta, please.
Yeah.
Please, sir.
So my submission is there. We can skip this biodata of the speaker to save the time.
Okay, sir. Okay, so then it's all right.
That's what I also wanted to say, sir.
Instead of this one, we can ask.
Dr. Veena, you unmute yourself.
Yeah.
Sir, I am unable to share the screen. I don't know what is happening.
From
You
whose
reopen the file, then reshare. Actually, close the file, reopen it, and then again share it.
I did it, but the desktop I'm not getting, sir.
Dr. Jayashree? From host, actually, they are organizing this, so that's why I'm asking Dr. Jayashree.
Yes, sir. Yes, sir. Sir,
You enabled sharing the PPT?
but I first she has to send to me, sir.
Then only she can share. Ma'am, you see,
Madam, can you
your
see me?
screen must have been minimized. Please see the icon at the base.
Yes, sir. I just opened only, sir.
Open, then you click on that icon.
Yes, it's coming now.
Yeah, it's your screen is available there. So you can click on the file and then you can go for sharing.
But I am unable. Sir, once again, I will stop share and once again redo it, sir. 1 second.
Okay.
Okay.
By the time we can ask Dr. Shamrao Jangir, he may have presented, we can have later on, she can be invited.
Yeah, Dr. Shamrao Jangir, Dean.
So good afternoon, sir.
Yeah.
Sir, my name is Priyanka. I'm presenting on behalf of Jagirdar, sir.
Okay. So,
Please go ahead.
yeah, you can go ahead till Dr. Veena is ready with her presentation. So we can request you to share your experiences in post-harvest handling and disease management in fruit crops and overview. That's the
Okay, sir.
topic.
Thank you, sir.
Yeah, thank you.
Very good afternoon to one and all present here. My name is Priyanka K, working as Senior Research Fellow in University of Agricultural Sciences, Dharwad. I'm here on behalf to present on the topic our experience in post-harvest handling and disease management in fruit crops and overview. Presenting on behalf of Dr. Shamrao Jagirdar, Dean, Pandit Jawaharlal Nehru College of Agriculture and Research Institute, Karaikal. So in India, agriculture forms a backbone of all the different sectors where it supplies raw materials as well as employment in various other sectors. So the raw material supplied takes another form in the processing process, and they get higher return economic profits. But agriculture is being performed by a farmer. So what is the average farmer's household per month? According to a NABARD recent report made during 2016-17, it states that the average household income by agriculture for a farmer amounts to rupees 8,931. It also states that this income has been increased by nearly rupees 2,500 per month when compared to the report made by NABARD during the year 2012 to 13. So though there is an increase in the income, still the farmer is facing a situation of indebtedness, and also that he is in a financial instability and facing the instability in financial section. So in order to double his income, he has to face certain challenges, which includes food losses and food waste at the production and post-harvest phases. Apart from that, climate changes, which are again human induced, which results in rise in temperature, which leads to drastic environmental changes such as increase in rainfall patterns, rise in the sea level, and drought condition, giving rise to losses in the agricultural production sector. Apart from this, depletion of the natural resources such as land and water, which are the key essentials for farming, is also one of the major challenges faced by a farmer. In order to focus on high yield patterns in agriculture produce, a farmer tends to intensively apply agrochemicals without having ecological balance in the agro ecosystem. This has led to an incidence of pest emergence or increased sudden outburst of diseases. Lack of knowledge from low value to shift from low value to high value crops. Apart from these, increasing biotic and abiotic stresses, adverse cost risk return structuring of farmer, market volatility and instability in price, inappropriate credit to
Madam Priyanka. Hello, madam.
I think there is internet issue, I think.
Sir.
Priyanka, are you there? Priyanka? I think she's disconnected.
Completely she is out of forum.
She disconnected completely.
So,
So shall I try, sir?
But first she will finish then.
she is to be informed first. Yes, Priyanka, you are available?
Disconnected.
Hello.
Then what is the winner?
I think she's not available, and
Then you can go to the winner. There is no problem.
yeah.
Sir, can I continue, sir?
Priyanka,
Priyanka has
Yes,
come,
sir.
sir.
Yes, sir. Yes, sir.
Priyanka is there.
Yes, sir. I'm here, sir.
Oh, yes. Then you please.
Yes, sir. So some of
But-
the human.
But be quick. Be quick.
Yes, sir. Yes, sir. I'll
Yeah,
be quick. Yes, sir.
Yeah.
So some of the human-induced global changes are the causes and the effect will be dealt in this slide, where it involves land use changes, where the natural landscape is being transformed into economic activities such as urbanization and industrialization, thus leading to habitat destruction due to deforestation, where there is a destruction in the natural living places of several living organisms. Apart from this, there is burning of fossil fuels by the which is also one of the human activities that has resulted in the formation of smog and acid rains, leading to air and water pollution. Apart from air and water pollution, some of the other activities imposed by the human beings are increased in the carbon dioxide levels in the atmosphere. That has led to rise in the temperature, which has led to drastic changes in the climatic conditions, such as the more precipitation, that is excess rainfall, drought situations, rises in the sea level, and forest fires. So all these impact has led to a breakdown in ecosystem that has led to the invasion of the emergence of the invasive species, where this involves the entry of a new pathogen into a new geographical area, where these pests adapt to the existing situation and cause drastic reduction in the yield of the agricultural produce. So once there is drastic reduction in agricultural produce, the amount of these produce reaching the consumer is less. So thus creating a situation of food insecurity. So during 2012, Ban Ki-moon proposed the Zero Hunger Challenge, which involves where it involves to eliminate hunger and to end malnutrition, and by building sustainable agricultural food system, at the same time safeguarding the ecosystem, preserving biodiversity, and promoting the climatic justice, such that even there is sustainable food production is being seen even for the future generations. So agriculture involves a wide variety of sectors, which includes agriculture, forestry, horticulture sectors. So among this, for today's concern, it is the horticulture crops, where these horticulture crops are a group which includes fruit, vegetables, flowers, spices, medicinal, aromatic, and plantation crops. Among these, the most consumed and perishable products are the fruits and vegetables. Due to the succulency and nutritional value, they are more vulnerable to infection by the plant pathogens. The infection may be before harvesting and or after harvesting. Those that prevail after harvest are called as the post-harvest diseases. So these kind of post-harvest diseases, the infection process starts right before the harvesting stage, where the pathogen undergoes a quiescent stage, and after being harvested, due to the prevailing favorable environmental condition, the pathogen becomes active and cause infection even after the harvesting process. So hence, the post-harvest disease losses can occur from the stage of harvesting until it reaches to the consumer. So these losses can range between 50 to 60%. That is, in a year, out of the total horticulture produce, up to 60% of yield loss can be obtained, which depends on the nature of the commodity and as well as the geographical location. So the deterioration is in terms of the quality and as well as the quantity. So causes of the losses may be due to the pest, which might cause where the insect might cause wounds by transmitting several virus, or the wounds may be giving the entry to other primary and secondary infection. The natural ripening process also disposes the products before reaching the consumer, and the inappropriate environmental condition and improper mechanical handling also are some of the causes for post-harvest disease infection that leads to losses. In the recent trend, people are migrating from the rural areas to the urban areas for the employment purpose. And apart from this, there is growing population in the urban areas. So the people mindset has changed for a healthy lifestyle, where they are trying to include a diet which is a balanced nutritional meal. And as recommended by medical practitioners and fitness trainers, they recommend that to include fresh fruits and vegetables. Hence, there is increasing demand for these perishable crops. Apart from this, when the horticulture fruits and vegetables are being infected by post-harvest pathogens, what happens is the disease prevails in them, where the quality standards are reduced and fail and gets rejected when they are being exported. Apart from, and this is also favored by the association of the mycotoxins, which are harmful for human beings. So hence, post-harvest disease management has a significant role to ensure that these perishable produce reaches the consumer as well as qualifies for the export standards. Karnataka state covers an area of 192,000 square kilometers, where it has a diversity in respect to climate, soil, and rainfall patterns. Horticulture crops in Karnataka occupies about 15.21 lakh hectares, where crops grown are ranges from different varieties of mango, grapes, pomegranate, guava, papaya, jamun, jackfruit, tomato, chili, capsicum, cabbage, and other fruits and vegetable crops, apart from spices and other plantation crops. So these are some of the crops which get exposed to post-harvest pathogen, and those which are associated with post-harvest diseases are Coleotrichum, Phomopsis, Rhizopus, Xanthomonas, Pythium, Alternaria. Where these pathogens where fungi and bacterial group take the upper hand in causing the post-harvest diseases. Well, very few are belonging to virus and nematodes. So some of the diseases observed are the anthracnose in banana, chili, mango, Rhizopus fruit rot in jackfruit, citrus cap, Penicillium fruit rot in citrus, bud necrosis virus. So there are many diseases being reported in Karnataka on different fruit and vegetable crops, where these diseases, where the pathogen reduce the shelf life of the produce, make them unfit for consumption, and also are harmful when the disease is being associated with some of the mycotoxins. So hence, management strategies should be incorporated before harvesting as well as after harvesting. Traditional management practices include the chemical treatments and heat and cold treatments, where they have their own advantages and disadvantages. So here, there is a limelight on the use of biocontrol agent, which have antagonistic effect on the post-harvest disease pathogens. So this, the experiences shared by Dr. Shamarao Jagedar mainly focuses on the use of lactic acid bacteria, which have antagonistic effect against certain diseases. So they have mainly worked on anthracnose disease of chili and banana. So in this disease, where they have isolated 41 lactic acid bacteria from different sources like fruit surface, soil, curd, etc. So out of these 41 lactic acid bacteria, 2 isolates, namely lab 75 and lab 82, were selected because of higher zone of inhibition found among the 41 isolates. And this was obtained from the in vitro studies by using the dual culture assay technique. So these two isolates were used in the certain treatment. So each treatment was 1 kg of chili fruits were used for each treatment. So these two isolates, that is a lactic acid bacterial isolate, were used in alone or in combination using different techniques of application. So first, the lactic acid bacteria was inoculated, and 3 days after this inoculation, the pathogen was inoculated into the chili fruits. So from these treatment, it was a T3 where the lactic acid bacteria 75 isolate in the spraying method found to be effective as the disease severity, percent disease index recorded based on the severity was comparatively less among other lactic acid bacterial treatment. So hence, this strain could be a potent biocontrol agent against chili anthracnose. So in another study made on Colletotrichum musae, which causes anthracnose in banana fruit, and causes up to 86% loss in banana crop. So what happened here? 176 isolates of lactic acid bacteria were collected, and out of them, 24 lab isolates exhibited antagonistic activity against the Colletotrichum musae upon co-inoculation using the dual culture technique. So among the 24 lactic acid bacterial isolates, 2 isolated from the soil source, that is LS36 and LS44, exhibited maximum zone of inhibition of about 2.5 centimeter or 25 mm. So these 2 isolates proved to be potent against the Colletotrichum musae. So upon the 16S rDNA sequencing, they were identified as Lactobacillus brevis. So hence, these could act as a biological biocontrol agent and also an alternative strategy to synthetic fungicide. So apart from this, another study was made on the.
Please conclude now.
Okay, sir. This is the last slide, sir.
Okay.
So apart from this, the same LS36 and LS44 isolates were used to study on the mycelial growth of the mycotoxin producing Aspergillus flavus, where they found a reduction in mycelial dry weight of Aspergillus flavus upon up to 15 days, where highest reduction was noticed during the initial days, which got reduced, but still there was 85%, up to 85% reduction in the growth of the pathogenic fungi. So hence, the lactic acid bacteria could be used as a potent biocontrol agents against the studies made on the certain pathogens such as Aspergillus and Colletotrichum in their study. As they produce some of the other metabolites, so these metabolites could be extracted, and which are, as they are considered as generally recognized as safe compounds, they could be commercialized under appropriate guidance and could be used in the field condition if they are proved to be stable under environmental condition. As the lab survival of lactic acid bacteria in post-harvest condition is proven, so these bacteria prevent the post-harvest spoilage even after harvesting. So these are the references that are being included. Thank you everyone.
Thank you, Priyanka. Thank you very much.
Thank you, sir.
Very nice presentation. Very good presentation.
Thank you, sir.
Good. So we can move to the next presentation by Dr. S.S. Veena.
Yeah.
Yes, sir. Yes, sir. Okay, I'll try to share. Yes, now it's coming.
Dr. Veena, your voice is not coming.
Unmute
Madam,
yourself.
you remove your earphone, madam.
Coming now?
Yes, now coming. Again not coming.
Sound, is it coming, sir, now?
Yeah.
It's okay. Yeah,
it's okay.
Respected chairman, co-chairman, senior colleagues and friends, I'll be presenting on post-harvest disease of tropical tuber crops and their management.
The major tuber crops are cassava, sweet potato, yam, elephant foot yam, arrowroot, yam bean, and taro. Root and tubers are the third important food crop of man after cereals and legumes. They constitute either staple or subsidiary food for about 1/5 of the world population. They have higher biological efficiency with yields of 15 to 75 tons per hectare. They are climate resilient and capacity to yield in poor and marginal soils. Apart from the traditional use of tuber crops, it is being used for making starch, adhesives, extruded products, biofilm, sago, bakery products, and bioethanol. The major field diseases of tuber crops are cassava mosaic disease, tuber rot, viral disease in sweet potato, anthracnose and viral disease in yam, taro leaf blight and Dachshund mosaic virus in taro, cowler rot and mosaic virus disease in elephant foot yam. Apart from field diseases caused by viruses and fungi, post-harvest losses due to pathogens lead to heavy financial loss to farmers. Even then, post-harvest losses not received attention as the problem demands. Most of the tuber crops are vegetatively propagated and usage of stored tuber or corm is the usual practice. Many pathogens attack tuber crops in field are capable of causing huge loss in storage also. Considering all these points, mitigation of post-harvest loss warrants urgent attention. The first crop is cassava. Post-harvest physiological deterioration is the most important problem. Here, the cassava tuber deteriorates with foul odor and taste within 2 to 3 days of harvest, making it unfit for consumption, processing, and marketing, and cause 40 to 100% loss if the tubers are not consumed or processed in time. The management practices are retaining the roots below ground for extended period and pruning before harvest. The modified storage techniques involving exclusion of oxygen, proper storage, and conversion to stable intermediate products or flour. Developing PPD tolerant genotype is the best option to overcome the problem. CTCR has developed varieties with tolerance to PPD resistance, and the Sridaksha is one of this variety which has resistance to cassava mosaic disease. That's the major problem in cassava, and PPD tolerance also. Next is the cassava root rot. The cassava root rot affected tubers show dry, wet, or soft rot and infect the produce on farm, or it develops during storage. The main pathogens responsible for these are Lasiodiplodia, Rhizopus, Aspergillus, Penicillium, Fusarium, Diplodia, and Macrophomina. The management strategies are application of chemicals, use of resistant varieties, and curing the tubers. Even though many chemicals are being recommended for the management, farmers are reluctant to follow the recommendation because either they cannot afford or due to the apprehensions regarding the safety of the products. Water and ethanol extracts of many botanical like Tagetes, Piper, Cassia, Oxymum, etc. also found to inhibit the pathogens responsible for the root rot. Coming to the sweet potato, the post-harvest disease in sweet potato is well studied. The diseases are categorized into three categories, that is pre-harvest infection, harvest infection, and post-harvest infection. First one is the pre-harvest infection. This is due to the use of infected plant material to raise the crop or moderately low-level microbial infection at the harvest, but the inoculum get mixed and then spread to healthy roots by contact. Ceratocystis fimbriata forms black rot. Here, the large circular sunken dark brown to black spots forms on the tubers. The infected tubers, if you are using for transplant production, symptoms also will appear on the plants. So in this case, the infected slips develop dark sunken cankers below the soil surface, and severe infections can result in the stunting, wilting, and even death of the sprouts. Coming to the harvest infection, this is because of the microorganisms in soil cause harvest infection. The slightest scratch on the outer skin can act as an entry point for the pathogens and cause infection. Java black rot, it is caused by Lasiodiplodia theobroma. The affected tissue shows yellowish brown color and later changes to black color. On the surface of the affected tubers, dark patches appear after 6 to 8 weeks of storage. The internal tissue turns to yellow in color and slowly changes to black color. Because of the internal rotting, the tubers become shriveled, mummified, and breakable. Fusarium root rot is the most important disease of sweet potato under storage. It's also known as dry rot or end rot. Fusarium solani, pallidorosium, oxysporum, and solani are the prevalent species. However, the Fusarium pallidorosium is reported only from India. The type of decay varies with the pathogen, and wounding is a prerequisite for the infection. In this case, the sunken lesion forms on the outer part of the tuber, which progresses with time and reaches to the periderm of the tuberous root. Coming to post-harvest infection, the major one is soft rot. Irrespective of the region, whether it is temperate or tropical, soft rot is being observed in all sweet potato growing countries. Rhizopus nigricans, Oraceae, stoloniferous, all these species cause soft rot in storage. In this case, soft spongy wet rot is caused by the fungi during transit or storage. The spread from tuber to adjacent tuber is very fast. In storage heap, it forms a nest of decay. The rot spread fast, and due to the nature of rot, typically affected roots decay completely. You can see the luxuriant growth of the fungus on the surface. The factors like infected storage tubers, unhygienic storage boxes, baskets, or tools can aggravate the damage. Charcoal rot is caused by Microphomina fasciolana. In this case, on advancement of the disease, the pathogen travels from the periphery to the central portion of the tuber, which in turn causes severe rotting. Due to the pattern of rotting, two dissimilar zones can be noted in affected tissue. The disease advancing end shows initial reddish brown to brown coloration with wet rotting, whereas the area rotting is initiated will have black color as indicated by the name of the disease. In this case, the pathogen destroys the entire tuber and causes drying of the tuber, which turns to be very hard to fell and mummify. Being a soil-borne pathogen, the propagules persist in soil or in plant parts, enters through wounds caused during harvesting or handling. In this case, the rise in temperature favors the pathogen, thus the disease is more prevalent in storage houses that are overly hot. Sclerotium rot is caused by Sclerotium rotsi. Here, the spots on the storage tubers initially occur in circular shape and starts rotting. The tissue under the water-soaked lesions on the tuber surface turns firm, hard, and stringy. Bacterial rot is caused by Erwinia chrysanthemi. Erwinia makes the tubers to acquire black stripes in the vascular tissue while rotting. As you know, Rhizopus also causes the same cause of rotting, but in that case, you can see the growth of the fungus. Spongy rot, Rhizoptonia rot, Pythium rot, and yeast infection also cause considerable loss to the produce. Coming to the management aspect, the careful handling is very important because the pathogen makes its entry through the wounds. So we have to take extra care while handling the tubers. Curing toughens the outer skin of the tuber and prevent the advancement of injury. Even proper washing of the tubers reduces the inoculum of the pathogens, and covering the freshly harvested tubers with a polythene sheet also can reduce the infection. Dipping tubers at 70 to 90 degrees Celsius for 2 to 10 seconds can delay the incidence of initial rot. And there are varieties which are resistant to Fusarium root rot, Sclerotium rot, Java black rot, Erwinia root rot, and Rhizopus soft rot. But in this, the problem is that post-harvest rots are complex rot and involves many pathogens. So we need to develop varieties with wide-ranging resistance to major pathogens causing post-harvest diseases. In chemical case, there is a problem because as food or feed, sweet potato tubers are straight consumed in many countries. This hampers the application of chemicals to reduce microbial spoilage in tubers. Still, fungicides continue as the key method to surpass the pathogen and reduce post-harvest diseases. Fungicide solution, for the application of fungicide solution can be further improved by increasing the temperature of the fungicide solution to 44 to 54 degrees Celsius. And some of the botanicals like Berilla fruticans, the active ingredient from the Berilla fruticans also have inhibitory action against the Ceratosis fimbriate, that is the major pathogen causing post-harvest disease in sweet potato. And some environmentally friendly antifungal agents like chitosan also can check Ceratosis fimbriata, and many species of trichoderma and Streptomyces lavandulae also can inhibit the pathogen. Coming to the yams, in this case, the major portion of the yam tubers is replaced in the form of tuber. This makes the farmers prefer the option of storing a good portion. Excuse me, sir.
Dr. Gurraj Sunkar, please mute.
Sir, please, sir. The rotting of tubers ranges from 10 to 20% in the initial 3 months of storage and 30 to 60% once the storage period exceeds 6 months. And here the pathogens responsible for the storage deterioration of Aspergillus, Laccidiplodia, Fusarium, Penicillium, Candida, Rhizopus, and Rhizoctonia. In this case, 2 types of rots. The first one is dry rot. The affected tuber turns stiff and dry, and the symptoms of dry rot changes with the pathogen responsible for the damage. If it is caused by Penicillium or Aspergillus species, they cause browning of the tissue with yellowish margin. If it is by Laccidiplodia or Rosalina, here the affected portion changes to gray in color and then to black and cause black rot. The tissue remains dry, the tuber becomes crumbly and breaks into small dry particles. If the rot is because of the Fusarium, it gives the pinkish color of the infected tissue with yellowish border. Fusarium moniliforme, Oxysporum, and Solani are the major pathogens causing deterioration. These are some other type of rot we got it from our field. And coming to the soft rot, Rhizoctonia solanae, Mucor, Rhizopus, and Sclerotium are the pathogens causing soft rot. In this case, the tissues become soft and brown with circular or irregular margins, which clearly demarcate from the healthy portion. If the internal tissue completely rot, tissues disintegrate and converts into watery mess, and even with a small touch, the ooze will come out. For the management, use of healthy planting material, following crop rotation, with non-host destruction of contaminated crop, use of chemicals, bioagents, and botanicals, etc. can inhibit the deterioration. And there are some indigenous practices followed by the farmers, like treating with wood ash or converting harvested produce into different products such as chips or cubes to store them for more than 6 months. And application of cow dung paste on tubers also can delay the incidence. We have developed another resistant variety, Sri Kartika, which can control the infection. Many botanicals like the leaf extracts of Ficus, Syzygium, Jatropha, etc. and biocontrol agents like Bacillus subtilis and Trichoderma also can check the infection. And in elephant foot yam, recently we have studied the post-harvest infection in detail. We see 9 types of symptoms are observed. Out of the 9 types of symptoms, brown lesions turning into powdery mass of tissue in later stages is the most common symptom. So out of the 80 samples examined, 22 samples showed this type of infection, and the extent of damage varied from 5 to 30%. Almost 150 organisms we got it. After removing the duplicates, 33 isolates were selected for the pathogenicity test, and 15 organisms we could prove postulates. All the organisms' morphology were studied, and they all identified with ITS. So the organisms, all the organisms were identified, and we got some new genera like Penicillium, Coltotrichum, Ceratobacterium, and Cunninghamella from the introduction, and some species, Rhizopus oryzae, Fusarium, and Fusarium oxysporum also we got it. And we have in lab, we have tested many bioagents and fungicides and biopesticides like Nanma also we have screened, and based on the results we got it, we have conducted a big study with the tubers also. These are the treated comps, and we stored after the treatment, and loss assessment was done. Here you can see all the tubers were, this is the way we use for planting. All the each individual pieces were tested, we were screened, and these are the treatment we have found: trichoderma in cow dung slurry, trichoderma in dry starch water, cow dung slurry alone, mango syrup, carbendazim, mango syrup, carbendazim, And Nanma, this is the biopesticide developed from CTCRI, Mangosay plus Nanma, then carbendazim plus Nanma, Mangosay plus carbendazim plus Nanma, and this is the control. Here you can see the rotting also more, and the presence of mealybug also you can see here. So based on the result, what we are saying, if the person can afford or if it is for storage, they can go for the combination fungicide Mangosay carbendazim. In case of organic cultivation, they can use either trichoderma in cow dung slurry or Nanma, the biopesticide. These two, they can use it for storage. And because these things, we can use it for the stored product. But what about the produce goes for the consumption? So we wanted to test the efficiency of different biocarbonates of sodium, potassium, and ammonia. And we have found ammonium bicarbonate is giving very good control for this post-harvest pathogens. And botanicals like onion and garlic also we have tested. In garlic, even as an aqueous extract or with its volatiles also is controlling the major pathogen which is causing post-harvest, that is Sclerotium rossi. And coming to the taro, here also is most of the pathogens are common with the elephant foot yam. These are the symptoms shown in taro. So these are the
Madam, please conclude.
Yes, I'm coming to the
time.
last slide, sir. I'm coming to the last slide.
Okay.
So this is the, in nutshell, most of the tuber crops are clonally propagated, and mitigating post-harvest loss can not only increase the quantity of saleable product, but also ensure quality planting material. However, post-harvest loss in tuber crops has not received attention as the problem warrants. An effective and eco-friendly management strategy is essential to ensure safe to eat tubers at affordable price. Development of varieties resistant to post-harvest disease through appropriate approaches can improve the shelf life of tropical root and tuber crops. The disease-free quality planting material ensures better crop stand and spread of pathogen from season to season. Thank you for your patient listening.
Thank you, madam. Over to Dr. Mehta and Dr. Singh, please.
Yes, no question from my side. It is a normal lecture.
I think it is very nice talk and I have no question at all.
So then we can move to the next speaker. Thank you, madam. Thank you, madam. So next speaker is Dr. Pankaj Veswar, Senior Scientist, ICR Research Complex, Umiam, Meghalaya. He will be, he's there. So he will be speaking on post-harvest diseases prevalent in Northeast and their management.
Good afternoon, everyone. Sir, am I audible?
Yes,
Yeah, you are audible.
Respected Chairman, Dr. D.S. Singh, sir, Dr. Naresh Mehta, sir, Convener, Dr. S.K. Sharma, sir, reporters, seniors, and my dear colleagues. I'll be presenting, and the topic of my presentation is post-harvest diseases prevalent in Northeast and their management. Actually, in Northeast, right from March to October, the humidity is very high because the rainfall starts right from March and ends up to October. So because of this, many field diseases are very prominent, and likewise post-harvest diseases are also very common in this area. And according to FAO, 52% losses have been reported in case of fruits and vegetables. And we are losing more than 8,000 crores per year just due to post-harvest diseases. And every year we equivalent to a sum of loss which we are facing. And also according to recommended dietary allowance, the fruits per day which should be taken is 140 grams. But actually the per capita availability of fruits is just 100 grams. And same is the case in vegetables. It is 270 grams which is recommended, and we just have 200 grams per day. Although Northeast is actually self-sufficient in horticultural crops. Even then this is happening just because of post-harvest disease. And few post-harvest losses have been reported from Northeast also, like in case of tomato, 23% loss has been reported by Hazarika. And in case of pineapple, 34% loss has been reported. In case of Khasi mandarin, 14% loss has been reported from Assam. Post-harvest losses can happen at farm level, trader level, wholesale level, and retailer level. But what actually happens is, in most of the cases, the report is from farm level only. They do not report it from trader or wholesale or retailer level. This is the biggest issue with the data which we have. And the losses can be quantitative, qualitative, economic, nutritional, and of course, because of mycotoxins, food safety issues are also there. Here also, most of the data is actually limited to quantitative analysis. When we talk about qualitative losses, we don't have much data. And the methodologies which various workers have adopted for assessment are ad hoc surveys, unstructured questionnaires, open-ended interviews, and focus group discussion. But these methodologies actually do not adopt a systematic approach. That actually results in a lot of statistical error. Although direct measurements are considered to be more accurate, but they are highly time consuming. So now in most of the countries, what they are doing is they have adopted a kind of hybrid approach whereby they are using either ad hoc surveys or unstructured questionnaires along with direct measurements also. And as I have told that most of the reports are based on quantitative losses rather than qualitative losses. And no one has actually, I think in Northeast, no one has actually studied the whole value chain, right from farm level to retailer. No one has studied. Most of the losses are reported at farm level only. And regarding major post-harvest diseases in Northeast, actually maize and rice are major staple crops in Northeast. And in case of maize, cob rot is very much prevalent in this area. And this is because of Aspergillus, Penicillium, Sclerotium ralphsi, Rhizoctonia solani. Pink cob rot is also very common, which is because of Fusarium moniliforme. And grain discoloration is in rice is also a big problem, which is because of Fusarium, Curvularia, Nigrospora, Cladosporium, Penicillium, and Helminthosporium. In case of fruits, soft rot of Momordica cochinchinensis is very common in this area. Actually, this Momordica cochinchinensis is known as Bhat Karela in Northeast. And black rot of pineapple is also very common. Fruitlet core rot is also there, which is because of fungus as well as yeast and mites. These are also associated with that particular disease. In case of guava, stalk end rot is common. And in case of jackfruit, fruit drop because of Rhizopus autocarpi. And just continuing the major post-harvest diseases, citrus is a major horticultural crop in Northeast. This is actually known as Khasi mandarin. I mean, scientifically it is same. Species is same as it is in Nagpur mandarin. It is Citrus reticulata only, but the taste and other characters are very different for Khasi mandarin. And this particular mandarin is actually preferred in Northeast and highly liked by the people. And in case of citrus, Penicillium digitatum, Geotrichum candidum, Colitotrichum gliosporites, Botrytiplodia, Alternaria, Alsonoi, Diporthi, Quignaria, Fusarium of citrus. In case of pome fruits, peach, brown rot due to Monilinia fructicola, plum fruit rot due to Glomerula cingulata are common. In case of vegetables, tomato fruit rot because of Geotrichum candidum, Phomopsis fruit rot in brinjal, and head rot of cabbage due to Rhizoctonia solani, curd rot of cabbage due to Cladosporium, okra fruit rot because of Pythium, and in case of spices, soft rot is very common over here because of Pythium, and dry rot which happens in storage condition because of Fusarium. So regarding post-harvest diseases of citrus, stem end rot is there, which is very common. It is because of Botrytiplodia, Alternaria, Phomopsis, and Colitotrichum. Latent infection actually because it becomes active after harvesting, although this is picked up in the field itself. And stem end rot by Alternaria cetrae is very dominant in cold storage. And sour rot caused by Geotrichum candidum. In this case also, invasion happens normally through wounds, and during harvesting, this disease is very prominent. Penicillium rot and Aspergillus rot also, Conidia in this case also infect the wounds during field, in the field only, but this disease is very common when once the things are stored. And in case of citrus, the storage losses can reach 100%. And for management of post-harvest disease of citrus, orchards should be kept clean, regular sprays of Bordeaux mixture. Actually, here in Northeast, we have worked out a crop calendar also, whereby we have recommended different sprays during different timings. And injuries should be avoided during handling, harvesting, and grading. Fruit should be preferably harvested in dry weather, although this is a big issue in Northeast, because I have told right from March to October, there is rainfall. And harvested fruit should be collected in plastic containers with smooth surface. This is just to avoid the injuries. Transportation should be in well-cushioned containers. Packing house should be properly sanitized. Harvested fruit should be washed with chlorine water. Fruits can also be dipped in any permitted fungicide for 5 minutes. This is capable of controlling the disease up to 3 weeks. Actually, earlier this was done using carbendazim, but now it has been banned. And fungicides can also be mixed with wax. And mixing with wax has an additional advantage that physiological weight loss is not there in this case. And if at all it is there, it is very less. And this wax coating also provides extra shine to fruits. Because of this, farmers can get some extra price for this. Here, one of our students has also tried botanicals for management of penicillium rot of Khasi mandarin. The species responsible for this particular rot is Penicillium brevicampectum. And these were the botanicals which were used as Adiracta indica, Ocimum sanctum, Aloe barbadans, carbendazim, and combinations were also used. So here we have seen that Ocimum sanctum is highly effective in reducing the percentage disease index, and decay loss was very less, even after 21 days. And final sensory scores were very good, which was 7.3 in comparison to control. So here we have found that Ocimum sanctum is highly effective in maintaining the quality of citrus fruits up to 21 days during storage. And banana fruit rot is caused by Bacterodiplodia theobromii. There's seed-borne in species where the seeds are present, and secondary spread is by conidia, produced in Pycnidial conidiomata. And the entry is mostly through wounds, and severity is more in case of fully ripened fruits. And for management, the fruit should be harvested at proper stage, and ripening should be avoided during transit. And during picking and handling, bruising should be prevented, and permitted fungicides can also be used. Similarly, in case of the fruit rot of guava, this is caused by Bacterodiplodia influenced by temperature, humidity, along with inoculum density and microbial load on the fruit surface. And for management of fruit rot of guava, Benomil can be used against Pasteurothiopsis rot. Hot water treatment can be done, and gamma radiation can also be done for elongation of, actually this inhibits the elongation of the germ tubes of conidia. And fruit rot of papaya is caused by Coletrotrichum, Alternaria, Ascochyta, and Rhizopus species. And for the management of fruit rot of papaya, actually proper handling of fruits during harvesting, storage, grading, and transit. This will avoid the mechanical injury. Removal and destruction of rotten fruits. Field sprays of mancozeb can also reduce Rhizopus fruit rot. Dipping of fruits in hot water at 49 degrees centigrade for 20 minutes can help in managing various pathogens. Double dip method in hot water is also used, but actually this affects the fruit quality. So single dip in hot water is preferred. And stem end rot of papaya of pineapple is also very common in this region. This is also known as core rot or black rot, caused by Ceratocystis paradoxa. In this case, small water-soaked spots at the stem end, which gradually enlarge, is present at the surface. Up to 15% losses have been reported. And here also the fungus normally enters through wounds or cuts. And for the management of stem end rot of pineapple, disease plant should be removed immediately after detection. Harvested fruit should be dried in sun for 2 hours, and packing boxes should be sprayed with 3% formalin. Post-harvest dipping of fruits for 5 minutes in thiabendazole and dusting of fruits with benzoic acid coated in kaolin also give a good management. And there is one more issue with post-harvest, that is mycotoxins and mycotoxicosis. We all have heard about St. Anthony's fire, which is caused because of ergot. And here, mostly because these toxins are mostly produced by Fusarium, Penicillium, and Aspergillus. In case of cereals, mostly in case of maize and rice, this is a problem. And in case of legumes, this is a problem in groundnut. And these are the toxins which are produced by Fusarium, zearalenone, trichothecins, and fuminosins. And in case of Penicillium, ochratoxin, citrinin, and citroviridin are produced by Penicillium species. And for management of these aflatoxins, moisture content should be kept low during storage. Temperature during storage should be kept low, and infestation by insect pests and mites should be prevented, because this acts as, the damage caused by these insect pests and mites actually acts as an entry point, and mechanical damage should also be avoided. So the major challenges in mitigating the post-harvest losses. Of course, number one is a lack of availability of post-harvest loss data for most of the crops. most of the crops. As I have told you, in majority, we just have post-harvest loss data for hardly 5 or 6 crops. And even there also, we just have data for farm level loss. We do not have data for the whole value chain. And in most of the studies, details regarding transportation loss in market is missing. Availability of pack houses and proper storage conditions is also a big drawback, because very few pack houses and proper storage conditions are available in this region. And even there is a lot of lack of awareness of maturity indices amongst farmers, because they do not know at what stage they should actually harvest. And lack of sufficient high quality data, which I have already told you. And just to give an example, there is a data by Ningobam from Manipur. Here they have worked out the loss at various levels, at farm level, then at wholesale market level, then during transportation, retail. So that way they have calculated the whole loss. So this is more reliable rather than farm level data. But here also, although they have included most of the things, but qualitative loss assessment has not been presented over here. So the major challenges are effect of climate change on post-harvest losses. Various studies have been done in Northeast, but no one is actually working on effect of climate change on post-harvest losses. And here, because of inadequate rail and air cargo, there is a problem. Number of processing units are also very less in this place, and adequate infrastructure is also not present, or if it is there, it is very meager. And of course, possible solutions are setting up of minimal processing units like screw type juice extractor, canning machines, and tray dryer, because this involves very less cost, and development of food processing industry. And there are certain dogmas also. I mean, there are many tribal communities in Northeast which have who have a feeling that frozen is not actually fresh. So somehow we have to remove this kind of dogma that frozen can also be consumed as fresh. And this is a list of common post-harvest management practices. And I'll talk about one more technology which has been developed by IRI, and this is being used in Northeast at several places. So Devi and Singh have done some work in Manipur and Nagaland. They have studied the shelf life in zero energy cool chamber and also at room temperature. So here they have you can see that there is almost more than double the change. As in case of cabbage, the normal shelf life at room temperature is 4 days. Whereas if you keep it in zero energy cool chamber, it is 10 days. So it is more than double. Similarly, in case of cucumber, it is 13 days at normal room temperature, but 18 at zero energy cool level, zero energy cool chamber. So this particular technology, which is very low cost, can be adopted in most of the states of Northeast. And here you can see in case of French beans, although the shelf life is same, but the weight loss is very less in case of zero energy cool chamber. Whereas although the shelf life is same, but the loss in weight is very high. And I'll be talking about few mycoparasites which we have reported from this region, and they do have a potential that they can be used against post-harvest pathogens also. Like we have reported one hyperparasite, Simplicillium lanosonium. This was actually a hyperparasite on Ascidium elagni latifoliae. This particular pathogen causes rust on Elaginus latifolia. This is a fruit crop which is very common in Meghalaya. This is known as Soshong. So here you can see the rust pustules, and here you can see this particular pustule has not been parasitized, whereas there is a covering on this particular pustule. So this particular covering is of the hyperparasite Simplicillium lanosonium. And here you can see the scanning electron micrograph also, whereby the hyphae of Simplicillium is entering the ichthyospores of Ascidium elagni.
So Dr. Pankaj, be quick, conclude now.
Sir, just 2 minutes.
Yeah.
Just 1 minute, sir.
Okay.
So we have done ITS identification also for this. So for actually this particular fungus is very difficult to identify. So first we use large subunit just to zero on the genus, because there are several genera like Licanicillium, Puchonia, and Haptocillium, which closely resemble Simplicillium. So we have used large subunit just to differentiate the genera, and then we have used ITS for differentiating the species. Verticillium epiphytum on Euromyces mucani. Here also you can see the scanning electron micrograph, whereby the hyphae of Verticillium epiphytum is entering the uridospores of Euromyces. Similarly, we have also reported Ramularia colispora on Coliosporium plumeri. We have also done molecular identification, and this report has been published. This is also a hyperparasite on Nisopsora thwitzi. This is also a rust pathogen. So here also you can see these black spots. These are unparasitized, and these pinkish spots are actually parasitized ones. So you can see this parasitized pustule here. Teleospores are almost absent, whereas this is unparasitized pustule where a lot of teleospores are present. So this has got a lot of potential to reduce the sporulation in rust. So these are the future prospects of use of mycoparasites. We can get mutants with enhanced host range. Ecological engineering can also be done, like nowadays at many places it is recommended that you have, complete cleaning should not be done in the field. There should be a certain area whereby we should leave some space for hyperparasites to multiply. And population dynamics of mycoparasites also need to be studied, which has not been done. And compatibility studies, then development of mycoparasites with enhanced saprophytic ability is also a requirement. And of course, efficient delivery mechanism are also required. And genetic engineering can also enhance the biocontrol potential of these particular mycoparasites. And I would like to thank all those who have been associated with me. And I would also like to thank the organizers for giving me this opportunity. Thanks a lot.
Thank you, Pankaj, for a very nice presentation, very good presentation. Thank you very much. So over to Chairman, Sir, Dr. Singh and Dr. Mehta.
I think there should not be any question.
Yeah.
He has already given we can switch on to some other one.
Yeah. So before I move to the next presentation, there is an announcement from the organizers that whose papers has been listed for the poster presentation during this session, technical session 2B. There are 13 papers which have been listed for poster presentation for this session. So I request all the presenters to join another link for poster presentation and be there for the evaluation of their posters. Thank you very much.
Sir, that's why I have posted in chat also. I have given the link in the chat also, sir. Here
yeah.
Also.
So there is a link given by Dr. Atul in the chat column also. So they can join through that link, or
yes,
even they must have got the link through their mail also.
Yes, sir.
Yeah. So please attend that poster session. So let us quickly move to the next presenter. It is Dr. Vinayak Hegde. So I think he's there. So I request him to present his talk on post-harvest disease of coconut, areca nut, and cocoa, microbes associated with their management. So I request him to be within the time limit. So after
sir,
that,
I have also given you a personal message on your chat, sir. Please see, sir.
Yeah.
Hello.
Shall I start, sir?
Yes, sir. Dr. Vinayak Hegde, namaste. How are you?
Fine, sir. Fine.
So welcome, and be quick and yeah.
Good afternoon, everybody. Respected Chairman, Dr. B.S. Singh, sir. I also started my career from CPRI Shimla. I was there for 5 years. I had heard about you. Probably we have met any time. Nice to see you. Respected Dr. Naresh Mehta ji, Dr. Satish Sharma ji, and all the distinguished delegates. I will just go quickly about the post-harvest problems, mainly diseases in plantation crops. These crops very rarely covered. I think in horticulture, I saw very less abstract must have come on these crops. So this is one of the major crops, plantation crops. Actually, I was to cover. I am covering only coconut, areca nut, and cocoa. Cashew, coffee, I think there are not much papers have come, though there are some problems in the other crops also. So coming to my presentation, mainly coconut. Coconut, as you all know, it is a Kalpavraksha, which is called in Sanskrit, and it is a present grown in more than 99 countries, and with about production of 12.12 million hectares and 59.98 million tons of production. So it is a mainly in Kalpavraksha, and it is every part of this is highly useful, and but it is mainly major states growing in Kerala, Karnataka, Andhra, and Tamil Nadu, though it is there in other states also. So then arecanut is also another cash crop, as you can say. It is this is being increased, and as you all know, the supari is there throughout India as well as in Asia, as we all know, famous for this. So it is a very cash crop, very remunerative crop, and farmers are increasing area everywhere. Then another crop is cocoa, which is a beverage crop or a chocolate crop, you can call, where the beans are being used. It has been an introduced crop in India, as it was introduced as an intercrop in arecanut gardens during 1960s, and it has got a lot of scope as an intercrop for especially in arecanut and coconut and oil palm plantations, to increase the income of the farmers, doubling the income. So it is a good crop. So there are some problems in all these crops post-harvest, but very less attention has been given, what I feel, about the post-harvest problems in the these crops. If we can see that they are highly commercial crops, contribute to national economy by export earnings. So they are less than 2% of area these crops cover, but they generate about more than 36,000 million rupees per annum as a foreign earnings. So cultivated by small and marginal farmers, provide a livelihood security to more than 20 million people. Being perennial, as you know, these are the grown mainly in the highly humid and tropical region. They are having lot of diseases and pest problems commonly in the field, as well as post-harvest also. There are substantial losses are there, but major study has been done only at the field level problems compared to post-harvest microbial problems. Then post-harvest loss, if you take into consideration, there was during ICR 2013, there is from CIFT Ludhiana has conducted the study from all the commodities. In that, they recorded that around 4.7% loss in coconut post-harvest. It is not just a disease alone, total loss due to post-harvest handling at different stages, and 4.91%. And it was estimated monetarily that around 2,500 crores loss in these crops, post-harvest loss. So coming to coconut, I will tell that there are, as I told, it is the Kalpavraksha, there are various value-added products. So value-added products are required for, as you know, to increase the farmer's income, as well as to, we diversify, we can reduce the damage due to post-harvest problems. So this is the one is major inflorescence sap. As you all know, this is inflorescence sap is CPCRI now have come up with a good technology for this, as well as a lot of products have been developed. Still, we are only 6% value addition in these crops in coconut. We don't have, compared to other countries like Philippines, or where around 40% are value-added products from this coconut, whereas we are using mainly 40% are being culinary and religious purpose it is being used, and 35% are copra and dried kernel, and this is being used for oil. Then 17% as a tender coconut. This has increased over now. Tender coconut, as you know, it is coming even to North India, everywhere. Now we are able to get Delhi also, all the tender coconut market is there, and 2% as a seed is being used. Then inflorescence sap, as I told, it is one of the value-added product. Recently, it's a Kalparasa. In commonly market, you must have heard about Nira, but there is a difference. Nira, based on the collective methods. Earlier, it was being collected by the traditionally using a pot, mud pot, by climbing. The climbers used to climb and they collect in the mud pot, which used to get fermented, and that taste was to be different. So CPCRI intervened and has developed a chiller, cocoa sap chiller, which has been developed the last few years back. Now it has been commercialized. Many farmers have come up in Tamil Nadu, Kerala, Andhra, all Karnataka. So they have started taking up. So this is a very fresh, this one, it is rich in sugars, proteins, amino acids, minerals. It has got a very good health benefit also. It has been studied. So post-harvest spoilage, fermentation, otherwise it will get fermented and spoilage will be there. So this is the which I was telling about the cocoa sap chiller, which it has been developed by CPCRI. So it is a multi-jacketed, and all the process, it will be stored till the starting the sap coming. It will be collected in ice type box. Earlier, the mud pots used to be used, and they used to put this lime to avoid the fermentation. So, but still it has to be very unhygienic, and there used to be fermentation. So this is the process which has been developed at CPCRI. So now this is the very good drink, as well as this can be used for many other products. This is the, I am telling, this is the one which can see the traditionally, which we used to get earlier as a drinks or in the sap, which is called Nira. Now the using CPCRI, that cocoa sap chiller, we can see the fresh, it is as fresh as this. The color should be like this. It is not fermented. It is very sweet and has highly good antioxidants and vitamins. So this is the, we can see the CPCRI technique that we have compared all the properties also. It has got a very good properties, even microbiomes of this fermented as well as unfermented kalparasa has been tested. We say that if it is before fermentation, has been this has been done by Dr. Murali Gopal, our microbiologist, and has been published already. You can go through about that. And this is, as we are told, this has got very good fresh, as fresh it will be there, and mainly in high leuconostoc followed by equal properties of gluconobacter. This will be there, bacterial population in this, whereas fresh, when it fermented, it goes down. Whereas in case of Saccharomyces, general yeast are the predominant among microbiome. So fermentation probably driven by symbiotic culture bacteria and yeasts. So kalparasa containing large population of leuconostoc and fructobacillus, and this unfermented plant edible food containing live probiotic type microbiome during its consumption. So it is a one of the intervention which has helped to provide this damage, post-harvest damage in case of coconut. Then second one is major problem is fruit rot or post-harvest stem end rot, where it is caused by Laccidiplodia theobrome. This is the, you can see the this whole this will be damaged inside the kernel also when the fungus gets infected in the, even sometimes mainly in the field also, then it will come to the storage where it has been stored. So it will develop damage the kernel also. So this coconut kernel is being used for different purposes. As you know, young coconut kernels are used for coconut jam, coconut puddings, ice cream, as well as syrup. Whereas mature coconut, it is a desiccated coconut powder. It is available even in the everywhere. Even north, when I was in Shimla, we used to use this only, desiccated coconut powders, coconut milk powder, roasted cocoa paste, coconut chips, ball and copra, coconut yogurt, fresh cocoa gratings. These are different products that have been produced. Then regarding coming to the copra, this is the where the post-harvest problem had been studied. Dried kernel of coconut ball copra. This is the completely not non-breakable, whereas this is the one which has broken one. So this is this has got called ball copra. So direct edible 23%, and cooking, hair, toiletry industries, and this oil will be produced. 77% is going for that. So harvesting, cocoa production 12 to 13 months. Then seasoning, then removal of husk. This is regarding the how the copra produced. This I am listed here. Regarding the coconut dehusking, because everything starts with the, even the husking problem will be there. If it delay, then there will be again fungal will grow up and cause the problems. So timely husking, these machines have become now useful. This is the different types of husk our post-harvest engineers have developed. Then microbial infection in copra, coming to pathological aspect, it is very few studies have been done on this bacterial and fungal attack is common in the copra when microbial attack, seasonal sensorial quality as well microtoxins are the major problem. This will affect the quality as well as this is the healthy one. You can see the infected one. So different microflora associated with copra has been isolated, and we can see the different types of microflora, mainly aspergillus and penicillium, which is going to cause the aflatoxin also. And you can see there are a lot of papers available on internationally also regarding the aflatoxin even in the coconut oil. So branded oil as well as in the oil, the aflatoxin levels has been studied. So this is one of the another major issue in the coconut, this one where there is a not proper drying and moisture content will increase the aspergillus and penicillium growth. So that leads to the different fungal toxins in the oil also. So moisture content critical factor, method of drying very important. Moisture content 5 to 6% should be there. Moisture content can be determined by moisture meter. So CPCRI has intervened and tried to develop the dryers proper for drying, because usually it used to be dried on the open ground with unhygienic where there is a chances of more contamination. So these are the types of dryers for different small users as well as large scale users has been developed by CPCRI, our post-harvest technology division. There is different types of dryers have been developed which can able to reduce the damage at different capacity. So critical factors are disease management in the field. One way to how to reduce in this is because certain fungus starts from the field itself. So it is the maturity at right maturity to be harvested. Moisture content, this is the major factors where it has to be tested. The moisture content should be around 6 to 8%. Then it will be reduced fungal infection. Method of drying, because it should be hygienically drying method. So proper handling and storage, these are the practices. The proper drying and storage, follow recommended practice for crop management in the field affected, because crop, if it is not followed, that leads to again at the preliminary this level. So use of chemical preservatives or preliminary studies have been done, but not much this has been followed. Regarding the arecanut is another major crop. As I told, it is a loss again in the mainly used for chewing purpose, and supari is famous. You can see the different types. As we know that there are a lot of infection in this supari also be available in the market, as well as which is coming from other countries to India. We have seen, we have intervened, it has come to CPCRI, we have tested a lot of microbial load which will damage, and it is being even consumed by many of us when in the market they are mixing the contaminated one also. So this is the major issue. That you can see the storage insect pests and diseases, mainly certain pests will be there, and when they're coming to the market, this will be powdered and used in the supari also. So some of the fungus has been isolated, and the certain beetles, you can see the common fungus which are isolated are aspergillus as well as different species, then penicillium, Acidiplodia, Rhizopus, Mucor, Teleopsis. These are some of the fungus have been isolated, and their infection percent in this sticks have been studied. But diversity of fungal genera, different genera of fungus, we can see has been studied in case of arecanut. This is a problem even in Northeast. As Pankaj was presenting, I was seeing whether arecanut has been not covered by him. There are even Northeast, we see commonly the arecanut, a lot of people chew arecanut in Assam as well as there one. Even in I visited Northeast region, we used to see there are a lot of infested nuts will be there in the market. So
please conclude, please.
Yeah, we will conclude. Microbial load, you can see the different, this one has been studied. We have imported the samples which used to come to CPCRI for testing. So we have intervened and found some of the things are microbial load is high compared to molecular identification has also been done. Then predisposing factors is the method of harvesting as well as infestation, prevailing temperature and humidity, and packaging methods. So manage, we have to do, as I told, all right, treatment of harvested nuts with Blitox and Bordeaux mixture sent on the cement floor will reduce infection. This was done earlier in our center, Nut Center. Avoid storing nut in ordinary gunny bags. So these are some of the things if they take care. In case of cocoa, is another major food crop, beverage crop, as I told, chocolate industries which are used. There are two types of processing: field, farm level, and industrial processing. So industrial processing, there won't be much problem of contamination, whereas farm level processing, farmers face a lot of problem. Some are not aware, and a lot of fungal problems will be there, especially two major fungus, Acidiplodia as well as Phytophthora, which causes in the field this the black pod, one of the major diseases in cocoa, and charcoal pod rot caused by Acidiplodia. These two fungus will cause the damage to the discoloration in the nut, this beans also, beans which are used for chocolate making. So this is the problem, major problem. These are the different types of bean fermentation techniques where there is a contamination will be there if there is no not followed packages. So you can see that the beans contaminated with the infected with the fungus. So this is the type of infection in the cocoa beans we are seeing. So infection during storage is the in the beans, in the cocoa beans also. So these are the different fungus which have been isolated from the cocoa. So these are the different, as I told, different fungus. There are the report about cocoa because a lot of work in other African countries, especially Nigeria, all they have done working on cocoa, where cocoa is a major crop there. So then the frequency of occurrence of fungi also has been reported. Different fungus has been studied. Then management, I told, follow recommended management practice minimizing pod infection, especially in India, mainly this black pod as well as charcoal pod rot are the major problem that has to be minimized at the field level. Then sorting out separation of infected nut, while infected nut should not be mixed, pods should not be mixed. Follow proper fermentation and drying method. Moisture content to be reduced. That is the one of the issues in the beans. Store dried beans properly. Storage. Then conclusion, crops grown in weather condition, which is tropical humid weather, as I told mentioned. So their microbial infection is a common problem. Infection occurs mainly during preliminary stages of post-harvest processing, usually done at farm level. Crop management in field as well as post-harvest handling equally important. Moisture content, drying and storage conditions are critical. So lack of awareness on proper post-harvest handling, trainings and demonstration are required. Lack of suitable specific this one. Then future thrust, what I suggest is development of proper SOP, standard operating procedure on post-harvest handling of this produce is required. Design and development of economic, user-friendly, need-based infrastructure and equipment suitable for small and marginal farmers. Creation of awareness among farmers, field level officers on post-harvest handling procedures. Development of user-friendly kits for detection of microbial and toxins at the field level. Application of metagenomics, of course, this is the further study for elucidate the microbe in the host environment interactions in the further coming years. So this is the, I thank mainly our post-harvest technology division who have worked on the technology for the engineering as well as processing division, and our all pathologists, Dr. Merin Babu, Dr. Chaitra and Tava Prakash Pandian, who are working with us here in CPCRI. So I thank you all and the organizers for giving me an opportunity to present our work on CPCRI. Thank you one and all for your kind attention.
Thank you, Dr. Binayak, for your nice and detailed presentation on 3 important crops. And now it's over to the chairpersons.
Thank you, Dr. Wagde. I think you have given a very nice talk. And now I think we should switch on to the next speaker.
Yes, sir. So
next session rather.
Yeah, 2 speakers were absent, Mastram Dhiman and Dr. Pooja Singh. If they are there, we can give them a chance. If they are not available, then we can move to the oral presentations.
Okay.
Dhiman is there? No.
I think they are not available.
No,
Yes,
Pooja Singh is. No.
Hello.
No. Yeah.
Dr. Dhiman is there.
Yes, sir.
Dr. Dhiman is there, yeah.
Oh, okay. Dr. Dhiman is there. So, Dr. Dhiman, he is senior scientist at IRI Research Station, Regional Station, Katrai. So he will be talking on pre and post harvest practices in disease management of cut flower. So I request Dr. Dhiman to be very quick and finish your talk within 5 to 7 minutes. We are already late and we have still to conduct the oral presentations, and for which we have to do the evaluation also. So be quick and finish your talk within 7 to 8 minutes, please. Dr. Mastram Dhiman, please.
Okay, sir. I want to share my screen. Sir, it's visible?
Not yet, not yet.
Now?
Yeah, it's visible now. Visible.
Okay, sir. Good afternoon,
Go ahead.
sir.
Go ahead.
I want to discuss something about the pre and post harvest management of cut flower crop. But as you know, this is the ornamentals are the living beauty of this floriculture industry. They include many imported plants, cut flower plants, herbaceous perennials, and seeds, and many value-added products. So due to the rapid change in production technology, as well as in the introduction of new crops and innovations, and introduction of hundreds of crops and novelties, there is now challenge for this industry or the management of pests and diseases. And approximately 10 to 30% of the total world cut flower crops destroyed every year. So standard so in order to meet the standard of the quality, so this management is very necessary in order to meet out the yield, but also to meet a high aesthetic standards in the quality standard in the markets. These are the quality we can say in the cut flowers, like appearance, we can see the color, length, volume, freshness, fragrance, as well as base type. And these are free from diseases. The main factors being reason is the flower senescence, deterioration of petals due to micro-caused diseases, loss of turgor, stem leaves to one micro diseases, stalk obstructions, and intolerance of flower to lower temperatures, and poor harvest handling at the farmers' level, or the production level, or the distribution. So these are some, sir, in general, these are the some post-harvest life factors are harvesting factors that affect pre and harvest and post-harvest factors. There are many. We can I don't want to discuss this. I think these are the major is the pest and diseases, the harvest as well as post-harvest. These factors, as we can say, this is the estimate. One of the estimate we can say in India, we needed contest in carnation. We can only in India this routine is the major disease. Root knot nematode, they can lose about 30 to 40 to 60% loss in India due to this pathogens. In Lilium is also this is mostly growing areas of 100% loss in many countries like fire black otitis is major disease in Lilium. Net rose also the gray mold up to 31% during post harvest. So their direct impact sometimes is that this is the essential pest damage as threshold can be seen in the most of the cut flower crops. This means that is challenging because increased demand by public and government agencies to adopt a sustainable approach which minimizes or eliminates the non-targeted pests. And along with other flower production practices, disease management must be equally precise, intensive, and sustainable, sir. The direct effects of pathogen on florist crops are the losses that can occur in their production and post-harvest handling. You can say but their extensive losses caused by flower crops, but estimates in monetary values is rare in floriculture. That is rare. But in the one of the study in USA, there is about 17% loss in this farm gate value for these crops in the ornamental crops. But indirect impact, we can say increasing proliferation. We are introducing many crops for novelties, and there is the dissemination of more pathogens and their vectors on cut flowers and other propagating material also damage unrelated crops. This is one of the Erostonia is a major bacterial pathogen. Many horticulture crops like this 3 biovar or the bacterium causes plants, geranium, potato, and tomato, as well as persist in areas with temperate climates. The movement of pest-resistant pathogen also in the global agriculture trade is also a major problem, major issue. Pathogenic fungus like botrytis area has acquired fungicide resistance. This is also a major problem due to this use of single site mode of actions. fungicide to suppress botrytis blight. Movement of blight is another graft transmissible agents in ornamental has been a long-standing regulatory concern. So these are some diseases, sir. These are not, I would not want to discuss more in the carnation. These are major disease that can occur due to this severity due to dry weather, etc. The acidic soils, there are some symptoms. Major disease. Another disease is the butt rot, Rhizoctonia solani. Another stem rot, root rot, and then gray mold, which are the major disease, pre and post harvest carnations that can affect most of the losses in this carnation as well as in rose and other crops. Can be managed by different methods, by chemical as well as biological agents. MCP is very effective to that disease. Then fairy ring or leaf spot is also a major problem in carnation. This is also just damage, the quality of the post-harvest quality of the cut flowers. Then rust is also one of the major problems. Then bacterial leaf spot of carnation. This is also a major problem in carnation. These lesions are appear the perichromatic leaf spots, stick and stripes. So lesions on older leaves and stems have purple concentric donations. So using copper-based compounds is not feasible because they interfere with stomatal closing. So the application of a styling at less than 7 days intervals can provide the adequate control of field condition. Then alternaria leaf spot, another problem is in the next crop is chrysanthemum. It's also the major problem. So this disease can be minimized with badness duration can be minimized and followed by the proper sanitations. Different compounds can be used like copper sulfate, pentahydrate, and triflumazoles and tritoconazoles can be used to control these field conditions. Then this botrytis, the major problem, the chrysanthemum. So there, this disease, the major loss can be caused by this disease. Major practices how to control this, keep the road, and avoid overhead irrigations. And constantly work to control this disease, other problems include avoidance of plant injury and storage at low temperature 4 degrees centigrade. Some fungicides and biocontrol agents can be used to control this disease. Then another disease, another problem, the rust. You can say this is also the one of the major problem that can be also damage the quality of the cut flowers that can be prevented by regular application of preventive fungicides can be used or they can use disease-free plants as maintain low humidity during and dry foliage, especially the greenhouse when we go over cultivations. Then this is also the bacterial blight, another problem. The vascular discoloration that is comes out of it. And some culture practices can avoid overmisting during propagation. A high rate of nutrition during propagation cuttings can be avoided, maybe avoided the high fertilization rates. And dipping of cutting in streptocycline mycin solution is beneficial to reduce these diseases during propagation stage. Bacterial leaf spot is also a major problem in chrysanthemum. Another is black spot in the rose. The next major crop is the rose cut flower, #1 crop. So this black spot is major problem that can be affected major field conditions. This circular black spots appear with fringe margins on the leaf. Sometimes yellow and defoliation are combinations. This can be managed by using distance cultivars or then can go avoid dense plantings and shaded areas and overhead watering that keeps plant bed for extended periods avoided. Spray of this chemical like baby stains when late and check these problems to some extent. Then botrytis, what is the botrytis areas? Another major problem is pre-harvest and post-harvest problem and this rose. So in this disease can be managed by spray of babystin or mancozeb. Then sanitation practice is very useful. Using then biological trichodermal strain is PDB, CTB is effective in controlling it. And the garlic juice can also be used at the rate of 0.5 to 5% and decrease this field condition. And body mildew also major problem. Then in ileum, this major disease is the botrytis blight. Again, major loss is caused by this disease in the field condition. So this disease can be controlled by borax mixtures at 2%. And fungicides like Aptan serum, and these are many different chemicals. And for this combination of this carbon diphenol has given it strict eradication of disease. And application of biological product like trichoderma BZ, trichoderma had 828-21 and trichoderma 1-5. And this can soil or directly to plant during growing season. Resulted that it is significant higher resistant disease. Very important and recommended for cultivation. Avoid this disease.
Please conclude. Conclude, please.
Okay, sir. Basal rots is another problem. Then rhizocotonia, then southern blights, then critical aspect breeding, that is major aspect. We can say these are automanage, we have to start the research cultivar, then cultural practices also follows sanitation, use of soil substrate and disinfectant with distinct fungicants. The new challenge for growth in several methods can be the recycling of water in order to avoid the fusarium diseases. So use of brassica species as a fumigation, fumigants to control this disease in also in the fields. Some fusarium diseases can be. Then irrigation, fumigation, then rotation of new lands is very important. Suppressing insect vectors of fusarium propagules. Culture indexes is important. Then seed and propagation is infestation with this hypophyte or some other compounds. Then nutrition also play a major role, and their roles in this building block development of this synthesis of certain pathways of and for applications. Calcium, magnesium is also application of stress build of carnage and calcareous soils. There's phosphorus also, then chlorides, then sulfur, forms of iron and manganese, then zinc and copper, boron plays crucial role in plant defense by improving cell wall integrity and enhancing phenol metabolisms. Then silicon is one of the most important compounds that can improve many of the diseases like damping of leaf blight, leaf spots, galls, spot mildews, and fruit rots, and can be mechanically varied through polymerization, and this can significantly reduce the. And organic amendments, then chemicals, different chemical compounds, biological compounds are there, pseudomonas and cousins. Then post-harvest diseases, there are different diseases like caused by Postharvest, infective fungi like bacteria like PK, Bacterium, Xanthomonas, and pseudomonas are most of the diseases. These are most separate in nature. This management, we are going to manipulate the environmental growing conditions is very important. As storage and transportation, dry storage, for example, in those can reduce the botrytis disease. Understand the packaging type and their also packed and their designs is also effective to maintain the disease to some extent in the botrytis disease. Then 1-MCP is very effective. The control of the disease in the rose, carnations, and cyclamens as a post-harvest treatment to some extent at the rate of very effectively. Mostly the ethylene in climatic foods, animal, like fruits, vegetables, and so. The radiation is one of the major treatments that can be used to effectively control the diseases, killing the pests and diseases without causing any damage to plant tissue. The different species, geranium, roses, can be post-harvest can be used to some extent the loss. That one of the study in one they have treated the rose cut flowers buds with at different incubation time like 24 hours, 25 hours, and at 4 consecutive days. But after 6 days, they have found that there is a maximum reduction in this botrytis in the on infection on the media germination on this flower buds.
Sir,
similarly,
come
they
to
also
the
found
concluding
that.
slide. Come to the concluding slide, please.
Okay, sir. Okay.
Yeah.
Then biological agents, then elicitors that are also there. That's alligation with algosmonates, SPMS.
Yes.
Then these are the how to manage this natural defense resistance in the processes in the plants by using this setup. Then antimicrobial, and these are some nanoparticles that can reduce to an extent in roses. Also, chlorine dioxide also there.
Yeah.
So these are the conclusions, sir. This management practice is very important at the field conditions to manage the water irrigation level, temperature, and the growing conditions. Breeding, sanitation, technology, chemistries, and bioantagonists can be used. Nutrition is very important factor that can be influence, decrease and increase disease influence and health of the crop. New tech like flood irrigations, flooded floors and EVAR, and flood irrigation require us to take closer look at how to harden the spread of the disease. Then new formulations of mismatch need evaluation. Then use of this precision nitrogen forward form should be used, and strongly promote improvement DNA-based diagnostic to detect latent Fusarium infection in seed, seedling, bugs, and cutting. And cultivation, cultivation of native species resistance to some diseases. Then we are to follow the integrated disease management practice. And there is a need for valid effort of more detailed research in manipulation of nature disease resistance in real world for cut flowers. Thank you, sir. Thank you very much,
Thank
sir.
you. Thank you. Thank you, Dr. Dhiman, for a very, very elaborative presentations. We are having a portion.
Thank you very much,
Time,
sir.
otherwise, we would have enjoyed your long presentation. So thank
Yes, sir.
you very much.
Thank you, sir. Thank you. Sir.
Over to Chairman, sir.
Unshare your slides, sir.
We can move it to next.
Yeah, so thank you. Thank you. So let us start with the oral presentations. So before we start with the oral presentation, there are 8 presentations listed for the session. And every presentation will be given 5 minutes.
Excuse me, sir.
Yeah.
I think next session will be started from 2 o'clock. I think same link as mentioned in chat box. But Dr. Jayashree will clear whether it is same link or a different link. Otherwise, how we will finish within 15 minutes or 8 presentation?
Sir, we are going to continue with the same link only, sir.
Then how we can conduct all the presentation?
No, sir. We may request, sir. It may extend. No issues.
Because Dr. T.S. Chen, sir, already has joined, sir.
Sir, excuse me, sir. Sir, one of my poster presentation is still pending.
Poster is different link is there.
Sorry, sir.
Separate link is there.
I think we can finish it within. We can give 3 to 4 minutes.
So, sir, kindly restrict 4 to 5 minutes, sir.
Every speaker is requested to finish your talk within 4 minutes and 1 minute for questions. And I request the chairpersons that all these oral presentation will be evaluated, and the judges are both the chairpersons and myself. So I request both the chairpersons that after the session is over, remain linked so that we can draw the conclusion. And you have to evaluate each presenter out of 50 marks. So let us start with the first presentation. It is the first presenter is Dr. M.K. Yadav, and the topic is a response to irradiation and storage temperature on post-harvest disease management of Alfonso mango during storage. Your time starts now, please.
I think it is.
Sir, first see who are there, sir. Then it will
save
time.
Sir.
Yeah.
Dr. Atul may note down the time.
Yeah. You first ask who is there, and then you.
Yeah, M.K. Yadav is there, not? Okay. Then we go to the second presenter, Dr. Akshay.
There.
Yes, sir.
Yeah, you are there. So, Dr. Gurjar, you can note down the time.
Okay, sir. Okay, sir.
Yeah. So, your time starts now, Dr. Akshay.
Good afternoon to all the present here. Myself, Akshay, MSc Fruit Science and Division of Fruit and Horticulture Technology, ICF, IIM, New Delhi.
Akshay, your slides are not yet visible. Akshay, your slides are not yet visible.
For me, it is visible, sir.
But we are not seeing.
For me,
now it's coming. Yeah.
It has come.
Visible.
Okay. My topic is anthracnose in guava, pre-harvest and post-harvest factors governing the incidence of the disease. Guava, that is Psyllium guajava, known as poor man's fruit or apple of is an important fruit of tropical and tropical regions of the world. And being originated in tropical America from Mexico to Peru, it is also well adapted under Indian conditions because of its hardy nature and the similar environment conditions. It is the fifth most important commercial crop for India after mango. India is the world's largest producer of guava with an annual production of 4.34 million metric tons and 0.287 million hectare area. In India, it is the largest by MP and Andhra Pradesh. Traditionally, different parts of fruits like fruits and bars are used for diarrhea, and dysentery. The candle leaves we can use for against the bleeding gums and the bed. The mashed flowers are applied to the painful eyes, and we can fruits can be used against the intestinal worms and amoebas. Regarding the production scenario of guava in the past 15 years, the area has been increased significantly from 176,000 hectare in 2007 to 87,000 hectare in 2020. And the production also increased significantly from 1831,000 metric ton in 2006-7 to 4345,000 metric ton in 2020. And there is also 1.5 time increase in productivity from 10.4 ton per hectare in 2006 to 15.1 in 2020. Nutritional value is an important source of vitamin C, dietary fibers, and being rich in vitamin can reduce the level of
I think disconnected.
Sir, ask him to unmute.
Hello.
Hello. Akshay, unmute.
I am sir.
Hello. Kindly unmute. Akshay.
I have unmuted. Hello.
Akshay, be quick actually. Time is running short actually. Na?
Hello.
Akshay. Now.
Now coming the sound.
Yeah.
And guava is affected by about 177 pathogens, out of which 167 are fungi. And the wilt is the most destructive disease of guava, followed, but anthracnose and canker also cause substantial damage. Anthracnose is caused by Coriarium gliospid spans, is major pre and post-harvest disease throughout the tropical and subtropical regions of the world. In India, it was first reported by Mehta in 1951 from Uttar Pradesh. The annual losses due to anthracnose on resins from 5 to 15%. The disease affects during the flowering, ripening, and flowering stage, ripening stage, and especially during the post-harvest. Two phases of disease have been seen: the attack phase and leaf infection phase. The effect phase of anthracnose was reported from Minto Park, Allahabad in 1952. Regarding the disease cycle, the primary infection is through the infected foliage, fruits, and debris. Symptoms. And secondary infection by airborne gonorrhea or through rain splashes, and the fungus survives in the plant debris that remains in the orchard. The begins to defect from the top of the branches. The greenish color of the growing tip changes to dark brown with later necrotic areas. During the phase, the symptom consists of distinctive sunken colored necrotic lesions covered with pinkish spore masses. During the ripe stage, the affected area on the ripe state becomes rocky and hardy and often develop cracks in case of several infections. Tiny minute black strata in the center, which produce creamy spore masses in moist weather. During the ripe stage, the infection causes the softening of tissues, and the spread of infection is very rapid on fully matured grain fruits as compared to ripe fruits. Necrotic lesions on there is with the tip appearance. Environmental humidity is necessary for the growth of the organism, and the system leaves on appear on 1 week after inoculation. The disease was found to develop between 30 degrees Celsius and more than 9% relative humidity on both ripe and unripe fruits. The disease appears in endemic form from September, and the injured fruit on the fruit peel facilitates the penetration of the fungi. Effect of anthracnose on nutritional composition. And these studies were carrying out during 2001 to 2002 in Ibadan, Nigeria. In this, they know higher in infected ones in the percentage of carbohydrates, crude fiber, as fat, protein, calcium, iron, and potassium. This due to the deterioration by the fungus response some essential nutrition for growth and development. there is a significant increase in the moisture in the infected fruits than the non-infected ones. That may be due to the exposure of damaged tissue to the moisture absorption. Includes a prolonged wet period, more than 90% relative humidity, mild temperature 28 to 30 degrees Celsius, high inoculant and 10 raised to power 6 quantity per ml, and the amounts present on the fruit surface. Post-harvest factors include improper storage conditions and mechanical bruising during the transport and storage. Temperature. These studies were carried out by Pandey et al. In 1997, and three methods were taken: uninjured fruits, and injured and punctured fruits. And the number of lesions were highest at around 28 to 30 degrees Celsius in case of fruit, followed by injured and uninjured. The disease development is slower as it rises to 35 to 40 degrees Celsius, and it is very slow at the temperature between 15 to 20 degrees Celsius.
Akshay, you concluded.
India, the annual losses due to anthracnose alone is 5 to 15. Pre-harvest factors include a prolonged wet period, more than 90% humidity, mild temperature, and high inoculant bouts present on the fruit surface. On the true fruit bagging with PP propylene non-woven bags at Margot stage of fruit development is highly useful for complete control of anthracnose. And besides these cultural practices such as optimal spacing, canopy management, and proper sanitation measures reduce the incidence of anthracnose under field conditions. Post-harvest management of anthracnose includes treatment of fruit with 500 tetracycline 500 ppm for 20 minutes, hot water 47 degrees Celsius for 20 minutes, and storage under controlled atmosphere. Thank you.
So thank you. Chairman persons, please, 1 or 2 questions.
I have no question, but
no question, please.
Okay, then we move
to the second one.
Next speaker, Dr. K.S. Dhami.
Are you there?
Yes, Dhami.
Are you there, Dr. Dhami? Yes, Dhami.
I think he's
not there. He's not there.
Ask third person, sir.
So next is Sweta Kumari. Dr. Sweta Kumari. She's there. Sweta Kumari, Varanasi.
Sweta Kumari, are you there?
No.
Next, sir.
No, she's not there. Then I think Dr. Atul, you?
No, my student is.
Okay. Niranjan Prasad.
Yeah, my student would be there, sir.
Okay. Niranjan Prasad. Is there?
Yes, sir.
Yeah, please.
Yes, sir.
Niranjan, please start your presentation.
Niranjan?
Yes, sir. Yes, sir.
Share your screen. Yeah.
Yeah, your time starts now.
Sir.
Your screen is not visible yet.
Niranjan, you share your screen. Yeah.
Yeah. Now, yes, you start. Your time start now. Yes, please.
Sir, good afternoon, one and all. My name is Niranjan Prasad HP. I am from Seed Science and Technology Division, IARI, New Delhi. Today I am going to present topic deterioration in the seed quality parameters of brinjal due to fruit rot caused by Pomopsis vexans. As we know, brinjal is a very
Niranjan, come to slide mode.
Please put on slide mode.
Slide mode, yeah.
Sir.
Slideshow mode.
Yes, sir. It came, sir. Brinjal is very important solanaceous crops. and it is known to infected by many phytopathogens. Among them, Pomopsis vexans is the most destructible disease in Pomopsis brinjal. We have analyzed 17 different genotypes which are collected from different regions like G181 Pusa Kranti and Panta Samrat Pusa Bindu Pusa Samla and many other varieties and genotypes, and estimated the different seed quality parameters like germination, vigor index 1 by taking the germination percentage and seedling root length and even the dry weight. When we compare the healthy seeds with the infected seeds, we see in the healthy seed the germination percentage is around 78 to 83%, but in the infected seeds it is reduced to 3 to 6%. The germination percentage between the healthy and infected seeds is around, it varies from 14 to 16%. Meanwhile, the vigor index 1 is also reduced to around 16 to centimeter to 646 centimeter compared to healthy seeds, which is around 1471 to 1628 centimeter. Even the electrical conductivity which we have observed between healthy and the infected seeds, the healthy seeds shown reduction in the electrical conductivities, which is around 38 to 35 millisiemens per centimeter, which is high in case of this infected seeds. And after that, I have analyzed the antioxidant activities of both the infected seeds as well as the healthy seeds. In the healthy, the antioxidant activities like SOD, peroxidase, and the catalase activities are high in case of the healthy seeds compared to infected seeds, even though the quantification is varies from seed to seed. After that, I analyzed the dual efficacy of the pathogen.
Niranjan, your slides are not moving, I think.
Yes, I was also thinking that it is not moving for me.
Slides are not moving. Yeah.
Now it is coming.
Yeah, now. Even if not in slide mode also, sir.
Niranjan, you can click on the slide show mode.
Slide show mode,
yeah,
and then.
Sir, for me it is showing slide.
You have to put in slide show mode, na?
At the bottom side, you see there is one option. At right side, you can click on that one.
Otherwise, go with that. No problem. Time is very.
Sir, when we see in the when I analyzed the dual culture technique with the different biocontrol agents like Trichoderma argianum and Pseudomonas fluorescens and the Bacillus subtilis, the efficacy of the biocontrol agent, namely Trichoderma argianum, is high when controlling the plant pathogen Pomopsis vexans, which is around 89% compared to Pseudomonas fluorescens and Bacillus subtilis, which is around 69 to 62%. Based on this, we can say that we can use a Trichoderma as a biocontrol agent and to control the Pomopsis vexans. And I acknowledge my gratitude towards Head Division of Seed Science and Technology and Chairperson Dr. Atul Kumar and the members and Seed Science and Division and IRI New Delhi. Thank you.
Now, Chairman, sir.
Now, let me thank him very short. He has completed his task. Now, I think very nice. He has given the information. So let us go to next.
Unshare your slide, Niranjan. Unshare so that other can share.
SK Sharma, sir.
Yeah. Next is Dr. Lakshmi. Dr. Lakshmi is there?
Yes, sir. I am here, sir.
Yeah. Please share your presentation.
Okay, sir.
So your time start now.
Sir, I am Dr. Lakshmi, working as Principal Scientist in Mango Research Center, Nijuvidu, sir. And very good afternoon to the Chairman and Co-Chairman and members of this forum. I am working on pre-harvest fruit bagging in mango, and it's a useful approach for post-harvest disease management and improvement of fruit quality. Sir, we all know that mango is the king of the fruits, and it is production, and it is playing major role in our earning of the foreign currency through its export, and also it occupies a major area in India, but its production is less day by day due to its affected by biotic and abiotic stress conditions. And it is king of the fruits. Why it is? Due to its high vitamin content and minerals content. This fruit is known as the king of the fruits. And in different areas, different fruits are the different varieties of the mango is grown. But in AP, the most important varieties are Chinnarasam, Pedarasam, and also Banginapilli, which are earning crores of rupees, millions of crores of rupees as a foreign exchange. The fruit was exported to UK, European countries, and South Korea, and North Korea, and other places also, sir. And then the importance of mango, you all know that AP is the leading state in India in mango production and area, and followed by UP and Bihar. All these occupied 54% of the mango production. And this production was influenced by anthracnose and several sucking pests, and also the diseases. We are giving more importance to diseases here. Anthracnose, powdery mildew, malformation, soft rots, and bacterial spots. All these diseases influencing the mango production, and some of them are highly influenced even after harvesting also. Suppose anthracnose disease in mango. And the country is incurring post-harvest losses, and we are incurring nearly 2 lakh crores of rupees in vegetables and fruits. Even though we are having high production rate, but marketing and in post-harvest we are losing 2 crores of rupees, means that is wastage of our resources and wastage of our fertilizers and wastage of our land. And in our country, even if we protect our crop and increase the mango protection, it is essential to protect the fruit from the post-harvest losses. And with this, and it's roughly estimations are there. My previous speakers also said there is not much reports on post-harvest losses in the fruits and vegetables. Exact, there is no data, but it's depending on some process, some post-harvest processing units and other. It is 40 to 50% loss in fruit and 13% loss in the farm itself, and during transportation it is 5 to 7%. At local market is 5 to 10%, and these are the anthracnose spots. And in the market itself, you can observe the anthracnose spots. That is, the farmer is growing different by spraying different nutrients, chemicals, pesticides, and all the things. But ultimately, the fruit comes into the market is in this shape, means we are wasting our resources. And then this is the sooty mold, one of the major problem in coastal area of Andhra Pradesh due to sucking pest and high humid conditions. We are getting this disease, and also soft rots. And one more pest is this one, which causes the mango at the time of ripening. It causes the maximum damage. This time 25 to 30% of the fruit was wasted due to the fruit fly damage. And if we reduce the storage or the losses in the post harvest, that is farm level or at a wholesale market, and these things, that is comes to nearly 34% of reduction in the post harvest, we will earn lots of rupees. And this one is with this object we have started one experiment, bagging of the fruits, and how with this bagging, what are the its influence on the quality parameters and disease and pest. And in this, we have tried brown paper double-layered bags and yellow paper double-layered bags with flip. Why we have kept the flip means the farmers has raised the questions that when we are at the time of harvest, we don't know that the fruits was covered in this cover. If we want to harvest the entire fruit, we have to pluck out and then see. If the immature fruit also there, we have to go with the for the market. For that rectification, we have put a small flip window type thing, and we have tried how it is influencing the quality. And then these are the covers we have used, and then these are the white covers. And this type of flip we have arranged to see the maturity of the fruit from the without removing the entire cover. This is the thing. And then we have control, and then these are the dark brown covers and yellow covers and white covers we have tried in the farm. And then after removing this is the color of the fruit. And when we compare the color of the fruit, dark brown color used mango fruits has given a very good attractive color compared to yellow color, and green will not, it can't affect, it will not affect that the color of the fruit. And also this one flip, then window also affected the color of the fruit. But here, when the window is there now, then it is a green color flap type thing we have seen. And then this is the thing, when the reddish color with the window, without window, and then it's the entire fruit was covered by the cover and there is a window like that. This is the thing, and here it is the cover, entire cover was covered, and here it is a small window as even. And then we come to the pest and disease influence of these covers. And hoppers are 1 point, in bagged fruits we have recorded 1.8%, whereas in the control it is 38%. Bag, that is the hoppers damage is there, and thrips damage is there, and fruit borer and fruit fly infestation was recorded nil in the bagged fruits compared to the control. Whereas anthracnose incidence also, it is 6.8% in bagged fruits, whereas in unbagged fruits are control, it is 28.2%. And also sooty mold also reduced to 2.8%, it is 38% in control, and soft rots also reduced. And then the weight of the fruit also increased in entirely covered fruit weight was recorded more compared to the control. And also TSS, acidity, reducing sugars, total sugars, non-reducing sugars, all these I have recorded, but they are non-significantly. We have recorded more in the covered fruits compared to control, but the data is non-significant. And the physical parameters we have recorded, brown and yellow paper bags recorded more weight, fruit length, fruit diameter, minimum result found in other treatments and control. And there is an increase of 20 to 23% of the quality of the fruit yield was increased in case of bagged gardens. And also brown paper bags changed fruit color into very attractive, and it fetches the more than 4 to 5% market rate in the compared to control fruits. And then shelf life was also increased in bagged fruits. In bagged fruits, chemical parameters, total soluble sugars, ascorbic acid, all are more, but non-significant when compared to the control. And diseases also, we have reduced the disease incidence, and also post-harvest losses also caused by anthracnose and all those things are reduced to 5 to 10%. Whereas in control, it is 60 to 70%. When intermediate rains are there, it was reported more than 90%. That is mainly sooty mold infestation on fruits was recorded. So, concluding that fruit retention was significantly improved in pre-harvest fruit bagging compared to control. And fruits with brown bags has recorded more shelf life compared to others. And market value of bagged fruits were 4 to 5-fold increase. And also it ultimately it increases the cost benefit ratio to the farmers. And then the management of post-harvest losses in mango, we have to practice pre-harvest measures such as bagging and nutrient spraying, which increases the yields to the farmer. Quality yield is the main parameter in this case. And we also increases the transportation, not only the yield in the field, we have to increase the quality of transportation and storage and cold storage and other facilities to the farmers. Then only we will get the more price in the market. Thank you, sir. Thank you for giving this opportunity.
Thank you, madam.
Thank you, sir.
So, any question?
Thank you. No problem.
We can
Thank you. Very nice talk. Very short period you have given.
Thank you, sir. Thank you, sir.
We can move to the next presenter.
Yes.
Please share your slides.
Yes, sir. Yes, sir.
Next presenter is Dr. Sanjeev Kumar. Is he available? Dr. Sanjeev?
I think not, sir.
Not available?
No.
Then next one, Dr. R.K. Ranjan.
Yes, sir, I am available, sir.
So
now
please,
I am sharing slides, sir.
Yeah, please share
Please,
your slides.
So, good
please
afternoon to
try
all
to
of you.
be within time. Yeah, your time starts now.
To all of you, sir. I am Dr. R.K. Ranjan from RPC, Pulsa, Bihar, sir. I am here to present the on the topic of effect of different storage temperature on development
Please,
of
please share your slides.
Yes, sir, I have. Oh.
And your video also not visible. You can turn on your video also.
Sir, now it is visible, sir?
Yeah,
Yeah,
but,
it is visible now.
But come to slide mode.
It is okay, sir?
Yeah, it's okay. Yeah.
Okay, good afternoon.
You proceed.
Good afternoon to all of you, sir. I am Dr. R.K. Ramya from RPC Pusa Bihar, sir. I am here to present the on the topic effect of different storage temperature on development of soft rotted potato caused by Erwinia carotovora, subspecies carotovora, and their molecular detection. So this is our upside. So potato is the third important most important food crop of the world, as well as in India after wheat and rice. And their production and productivity is affected by a number of diseases like fungal, bacterial, and virus. Among all the diseases, soft rot is the third most important disease after late blight and bacterial wilt of potato. And the soft rot of disease is generally caused by Erwinia carotovora, Bacillus species, and Pseudomonas species. Among all the Erwinia carotovora subspecies carotovora is one of the major soft rot causing bacteria in the potato. And these carotovora has a great importance both in field as well as in transit and during storage. It causes heavy economic losses. All the other vegetables also. So this disease represents a serious threat to potato production and post-harvest losses during storage, environment, and bread climate. And this disease causes approximately 15 to 30% losses in the harvested crop. And these Erwinia carotovora remain latent in a potato tuber, and in this way they are disseminating in the field and causing the diseases and losses in transit and storage. And that their management is also limited, dependent on physical, chemical, biological methods. And this is also not able to manage this disease, as the seed tubers are the main source and vector of inoculum of soft rot of bacterial pathogen, and since no chemical control of pathogen exists, and prevention methods are limited to sanitary measures and the use of certified pathogen-free seed tubers. Therefore, the study on the effect of different inoculum level and incubation temperature on the development of soft rot of potato was taken and developed a specific and sensitive PCR for the rapid and accurate detection of Erwinia carotovora, subspecies carotovora in asymptomatic potato plant and tuber, which will be helpful to save time and money, and that will be available to the farmers disease-free seeds. So for this, I have collected the samples from Uttarakhand, from Hill, and Plain from Odisha, and these potato samples were kept at 5 degrees centigrade, 15, 25, and 35 degrees centigrade, and observation were recorded at 20, 40, and 60 days of storage. So this is the photograph of the rotted potato stored at different temperature and recorded the observation from 20, 40, and 60 days of storage. The result presented in the table shows that minimum rotting were observed in the at 5 degrees centigrade in Uttarakhand samples collected from Uttarakhand samples, that is Kufri Jalandhar 5.82%, and Kufri Pokraj from Odisha, it is 7.53%, followed by 15 degrees centigrade, and the maximum rotting was recorded at 35 degrees centigrade in the potato samples collected from Odisha, that is Kufri Pokraj, and potato sample Kufri Jalandhar collected from Uttarakhand, that is 87.37%. So we have also isolated the bacteria and fungi from the rotted potato. The bacteria, that is Rhizostonia, Erwinia, Bacillus species, that is common in both the potato tubers collected from Odisha and Uttarakhand. Fusarium, Oxysporum, Mucor, and Penicillium is also common in both the samples collected from Odisha and Uttarakhand. However, Microfauna Fazulina only observed in the Odisha samples. So further, to know the effect of different population level and incubation temperature on the development of soft rot potato, we have inoculated the artificial inoculation of Erwinia carotovora at different population level and at the different temperature. For this, we have collected the disease-free seed tubers
and then washed in 1% hypochlorite solution, then serially washed with the 3 to 4% sterilized water. Then we have made the hole with the cork borer. Then the different population level from the 48-hour old culture Erwinia keratovora dilution were prepared, and the 10 to the power 8 CFU were maintained at 0 by a spectrophotometer, that is 0.1 OD at 610. By serial dilution, we have made the 10 to the power 2, 10 to the power 6, and 10 to the power 6 dilution. And after inoculation, we have put in the glass jar, and inside the glass jar, we have maintained the humidity by putting the swab, sterilized swab. And then we have put at different temperature, that is 21, 28, and 35 degrees centigrade. And this is the photograph of the rotted potato taken after 72 hours. And the result presented in the table, it shows that the maximum rotting were observed at 35 degrees centigrade, followed by 28 degrees centigrade. Even the 10 to the power 2 CFU ml able to cause or start the rotting even at the 21 degree centigrade of the temperature. Further, we have designed the primer from pectate lysine that detect the Erwinia keratovora and amplified the product at 418 base pair. For this, we have standardized the protocol, that is denaturation step at 95 degrees centigrade for 5 minutes, followed by 35 cycles of denaturation at 95 degrees centigrade for 30 centigrade, and annealing temperature at 54 degrees centigrade for 30 seconds, and extension at 72 degrees centigrade for 45 seconds.
Please conclude. Please conclude.
So further, we have tested the specific. This is the amplified product at 418 base pair. Further, we have tested the specificity set, and this is able to detect up to 1 nanogram of the genomic DNA. At the assay of CFU, it can detect up to 10 to the power 2 CFU ml. Further, we have validated this Erwinia keratovora design primer, and this design able to detect by PCR 15.12% and conventional PCR and CVP media is not able to detect up to this. So this is the photograph of the validation of the design primer. So minimum decay recorded in at 5% and maximum at 35. Rotting also recorded maximum at 83%. And Rhizostonia erwinia bacillus were common in both the potatoes and collected from location. And the design primer able to detect. So therefore developed a specific polymerase chain reaction assay for the rapid and accurate detection of Erwinia keratovora in a symptomatic potato plant sample, which will be helpful in seed certification to make sure that you are free from this deadly pathogen, so that the farmers get free from this pathogen. Thank you, sir.
Please unshare your screen, Dr. Rajesh.
Oh, thank you, Ranjan. Thank you, Ranjan.
Sir, one more Sweta Kumari she joined.
She can be allowed.
Yeah.
Please.
Please share your screen, Sweta.
Okay, sir.
Sir, we are running late. Actually, the next session persons had already joined, sir.
Yeah.
It will take 5 minutes more.
Earlier, actually,
this was not proper sequence.
we finish in 2 minutes time.
Yes, sir. Sir, may I
Let
start,
her
sir?
finish within the allotted time, 5 minutes and 4 minutes for presentation and 1 minute for if any there is any question then. So no problem. I have discussed it with the organizers. They have asked that you continue till the session is over. The next session will start after that.
Okay, sir.
Okay, sir. Okay.
Yeah.
May I start, sir?
Please.
Okay, sir. Thank you, sir. Good afternoon to one and all present here. So I'm going to give my oral presentation on impact of groundnut bud necrosis virus infection on post-harvest seed quality attributes of cowpea. Orthotospovirus. Tospovirus are enveloped RNA virus with tripartite genome comprises of LRNA, mRNA, and sRNA. It is the one of devastating plant virus group infecting wide range of economically important plant.
These are known to be transmitted by Thrips vector in persistent and propagative manner. Larva of first and second instar can only acquire the virus, whereas adult can only transmit the virus after a latent period. So far, 30 species of orthotospovirus were reported at global level, out of which 5 species, that is the peanut bud necrosis virus, watermelon bud necrosis virus, capsicum fluorosis virus, iris yellow spot virus, and peanut yellow spot virus were identified in India, among which PBNB is the most widely occurring and damaging virus. This picture depicts the typical symptom of tospovirus. This first picture shows that the chlorotic lesion on the younger leaves. In case of severe infection, whole lamina will occupy with this chlorotic lesion. Apart from this, here we can see that the necrotic lesion and in some cases that necrosis can be visible along the vein, that is called the venal necrosis. So we collected the sample which is shows typical symptom of tospovirus were collected, and collected sample were subjected to RT-PCR assay by using tospovirus universal primer. An amplicon of 800 base pair in infected sample shows that the sample is positive for the tospovirus. So to further know the species level, so what we have done here, we have same sample we have subjected to the GBNB specific primer, and here the infected sample yielded a 916 base pair, whereas such amplification were absent in the healthy plant. And to know the further resolution, the positive amplicane of representative sample was sequenced and analysis, and sequence analysis shows that the virus which caused chlorotic lesion in cowpea is closely related to the virus with Solanum torvum. Besides that, we have also did mechanical inoculation studies. So here we have we have extracted leaf extract, and this one inoculated mechanically on the local lesion host, that is cowpea. And this infected plant shows the typical symptom of chlorotic lesion after 4 days after inoculation. And this infection further confirmed through the PCR assay. So additionally, we have studied the GBNB impact on the cowpea plant. So here there are different parameters we have studied, like a plant height, number of pods per plant, pod length, number of seed per pod, and seed yield per plant. So infected plant shows that the reduction in plant height, pod length, and the number of seed per pod. But if you look at these two parameters, that is the number of pod per plant and seed yield per plant, so it's drastically getting reduced in infected plant as compared to the healthy plant. We have also studied the impact of GBNB on the seed quality attributes. So here we have studied different parameters like seed weight, speed of germination, abnormal seedling percentage, seedling length, and dry weight. So here result shows that the infected seed having a less seed weight and seedling length and dry weight. But if you look at these two parameters, that is germination percent, so impact of this virus has minuscule impact of the germination percentage. As far as speed of germination are concerned, so no remarkable differences has been observed in the healthy and infected seed. But if you look at the abnormal seedling percentage, so it's nearly double in case of infected plant as compared to the healthy plant. And if you look at the Vigor index, so it's same kind of pattern we have observed in infected plant. But if you observe interestingly electrical conductivity, which is lower in infected plant as compared to the healthy plant. Generally, electrical conductivity of infected plant will be higher as compared to the healthy plant. So the possible reason could be seed undergo imbibitional damage due to the bigger size, and thus leakage of electrolyte from the seed would be higher due to the loss of membrane integrity, and thereby increase the electrical conductance. So this
Madam,
overall,
please conclude.
Sir, last slide, sir. So this picture represents the schematic representation of negative impact of GBNB infection on the cowpea seed quantity. So here we can see that the plant, this virus having impact on both plant and as well as seed. So hence the diminished number of pod per plant and seed number per plant contributed to total yield loss. Thank you.
So thank you, madam. Thank you.
Thank you, Dr. Satakwari. Now it is over. No?
So Now,
I think it was last, no, sir. Satish, sir.
yeah, it was last. So out of 8 presentations, there were 3, 4, 5 presentations only. So now,
sir, before
yeah, please.
As informed by the organizers, sir, before we conclude this session,
yeah,
I would like to play some records from the organizers. Thanks to all both the chairman of the session, Dr. D.S. Singh sir and Dr. Naresh Mehta sir, and for all the participants participating here, I would like to inform that the convener of the session, Dr. Satish Kumar Sharma, he is gold medalist, both MSc and PhD during his plant pathology degree program. And he has published, he has written a very important book, Disease of Fruit Crops, Temperate Horticulture, Current Scenario. And he has also written another book, Fungi and Plant Disease. So all the students are sitting here. That's why I'm giving the information that sir is renowned in the area and he has published so many important books. So it's our pleasure that a person of such repute is a convener to this particular session. Thank you very much, sir, for giving your time and moderating this session and helping us. Thank you very much, sir.
Thank you very much, all the participants. Especially, I thank Dr. Sharma. Very nicely, he has conducted the entire proceeding of the and Dr. Mehta also, he has cooperated very well. Thank you always. Thank you.
Thanks to everyone, sir. Thanks to
so
everyone.
I am highly thankful to the organizers for giving me this opportunity to convene this session, and I'm also thankful to both the chairpersons.
Thank you, Rapporteur Atul Kumar, for a brief introduction of the Dr. S.K. Sharma.
Thank you, madam. So, Dr. Singh, can I have your number, please? Because we have to finalize the oral presenters first, second, third. 98
11
11
55
55
44
44
70.
70. So I have the number of Dr. Mehta. So we will discuss it on the telephone and we will finalize.
Thank you.
And I request both
mail to organizers.
Yeah, that we will send a mail. So I again request both the reporters.
Yeah.
Very nice reporter. They were very much particular about the timings and particularly finishing of this session in time. So it's required. And they were very much attentive. So I thank both the reporters for recording the proceedings of this session, and I request both of them to finalize the proceedings and send it to me by evening if possible, so that we can make the final proceeding, we can finalize it and hand over to the organizers.
Sure, sir, sure. We can make.
Yeah. So thank you very much. Thank you very much. Thank you one and all. So with these remarks, we conclude this session. Thank you very much.
Thank you, one and all. Thank you. हाँ जी डॉक्टर क्या हाल है? हाँ बस मौका लगा नहीं इसलिए दवा नहीं पाया। कुछ तो कोरोना ने कर दिया, कुछ वैसे ही कम।
Gogoi there, please.
Sir, hello, sir.
Is Dr. Gogoi, Robin Gogoi there? We have to start the next session. 3A.
Yes, sir. Convener, sir, KP Singh, sir. Are you there, sir? Convener, KP Singh, sir.
Dr. Jasri, this is a link for 3B is same or 4B?
Yes,
This?
sir. 3B technical session, sir.
This is
Yes.
on which topic? Topic is?
Topic is chemical and non-chemical methods for disease management, sir.
Okay, okay. Somebody asked me, that's why I'm clarifying. Okay.
Yes, Jasri.
Sir, shall we start, sir?
Yes, yes.
Very good afternoon to everybody. Now we are at the technical session 3B, that is chemical and non-chemical methods for disease management. Chairperson for this session is Dr. Eves Singh, Central Institute of Potato, New Delhi. And another one is Dr. S.R. Niranjan, former Vice Chancellor, Gulbarga University, and Professor and Chairman, DOS in Biotechnology, University of Mysuru. Convener for this session is Professor K.P. Singh, Department of Plant Pathology, College of Agriculture, G.P. Pant University of Agriculture and Technology, Pantnagar. Sir is specialized in economical and integrated disease management of apple diseases, and also a certain IDM practices are being given to the off-season vegetables are also. He has published more than 80 research papers, including books and books chapters. And serving as a member of editorial board of several research journals, and awarded with several awards by the university, CSIR institutes, Indian Phytopathological Society. With this brief introduction, I request convener Professor K.P. Singh to take over this session. Thank you, sir.
Okay, thank you, Jasri. Now, in this technical session, now chairman is Dr. U.S. Singh. Dr. U.S. Singh is here. Dr. U.S. Singh and Dr. S.R. Niranjana.
Sir, I'm not finding anywhere their names, sir. S.R. Niranjan.
Jasri, you confirm to organizer whether they have changed some chairman and co-chairman because they are not in here.
Yes, sir. I will call them.
Otherwise,
yes, session is delayed. They might
yeah,
have come and we will
The
call
report
them.
Dr. Sanjeev Kumar and Srikant is here. Dr. Sanjeev Kumar and Srikant. Dr. Sanjeev Kumar and Srikant.
No, sir.
Jasri, you can see the...
Yes, sir. I will call, sir.
Chairperson and reporter, nobody can hear.
Sir, I am calling them, sir.
Okay.
Hello, Dr. Singh. Is it session 3A, please?
Sir, it is 3B, sir.
3B. Oh, how to join session 3A? Because I have clicked on the link for the session 3A.
Okay, sir. I will share that, sir, for 3.
And Dr. Gogoi, what is the link? Which is the link for session 3A? Because I have clicked on one link and they say that it is section 3B. Okay.
Sir, just a minute, sir. I'm sharing here.
No, but the previous session is already over, and now they say they are starting session 3B. Yes, but I have linked on that very link. I clicked on that very link, but they say it is 3B. Which is the link for 3A?
Sir, it's being shared in the chat box, sir. Please kindly refer it, sir.
Excuse me?
3A link.
Dr. Thin,
3A
now
link is being shared in the chat box, sir. Just now.
Hello?
Hello.
Hello.
Yeah, but that is the
For 2A and 3A, the same link which is
but
shared
I
in the
clicked on
chat
that,
box.
but it comes that this is section 3B now. I don't know which is the link. There were 3 links, right? Yes, I have WhatsApp number. Yes, you can send me.
Hello.
Okay. Okay then. Okay. Okay. Okay, then send me the link, please. Send me the link. Okay, thank you. The sessions are running behind you.
Hello. Sir, link for 2A session and 3A session are the same. The 2A session is going on, which got delayed.
Okay.
Join and you can stay there, sir. 3A will start.
Okay. This already some session is going on. Well.
Dr. Thin, what about the name of your session?
This is, I think this is 2 parts. This is chemical and a non-chemical methods for disease control. 3A. Yeah. Chemicals and non-chemical methods for disease control. This is 3A. Then also 3B is also the same, 3B.
Okay.
3B is also the same.
Yeah.
Yeah.
Jayashree.
Sir, KP Singh, sir. Sir, Niranjan, sir, has come, sir. Sir,
Hello.
Dr. Kishan, sir,
Hello, I am audible.
Yes, sir. Yes, sir, you are audible.
Oh, the same session I have to, isn't it same link?
Yes, sir. Welcome, sir. Welcome for
Thank
this
you,
session.
thank you. So now we have to start the session.
Yes, sir.
Dr. U.S. Singh is there?
No, sir. Yet to join, sir. We are
He is
calling
yet to
him. Sir.
join. So convener
Please,
is
you
there.
start the session.
KP Singh is there.
Sir, KP Singh is KP Singh, sir, is there, sir. He is the convener. And Singh has to join, sir. Please, you do start the session,
Okay,
sir.
right.
Thank you,
So
sir.
I welcome you all. Good afternoon. We have to start the session now. Technical session 3B. I would like to thank the organizers for giving me an opportunity to work as a chairman of this particular session.
KP Singh, sir, unmute yourself.
Sorry.
Singh, unmute. You unmute yourself now.
So start.
Yeah. So now
Start.
go for the only one lead paper is there in the session.
Yeah.
That is Dr. Pratibha Sharma.
Dr. Pratibha Sharma, yes.
So I would like to invite her for the lead lecture of this in particular session of technical session 3B on chemical and non-chemical method for disease management. Pratibha Sharma is going to speak on the importance of biocontrol agents and increasing efficacy in post-harvest disease management. So this is the area she's worked from last so many years. Pratibha Sharma, madam, I would like to invite you.
Dr. Pratibha Sharma, please.
Madam is there?
I think she is not. I think now she is not available. Dr. Pratibha Sharma.
Earlier she was there, sir.
Now she is not there. So what I can do? I have to wait or I can go for invited papers.
So I think now already late, so that now going to start the next person's lead invited lectures.
Okay. So sorry, we will wait. If Pratibha Sharma is getting login, and we will give the opportunity for her in the later period. So now we have to start the invited papers. So that is the first speaker is Afroz Alam.
Afroz Alam, yeah.
Afroz Alam, Banasthi
Yes, sir.
University, Jaipur, Rajasthan.
Good afternoon to sir. Good afternoon,
Yeah.
sir.
Yes.
Afroz Alam.
Yeah.
Just a minute. Good
Yeah,
afternoon.
Afroz. Yes,
So I would like to invite you to deliver the lecture on perspectives of bryophytes in the management harvest fungi.
Yeah.
So I would like to introduce for the audience just a very brief. Presently is the Associate Professor, Department of Bioscience and Biotechnology, Banstali Vidyapeeth, Rajasthan. He's completed his MSc PhD in University of Lucknow, and he is now working as he's guided 15 PhD students, and he's having a huge teaching and research experience about 17-18 years, and he has published more than 65 books and 65 research articles and 12 books and book chapters. His area of research is biology, phytochemistry, and plant physiology. With this brief introduction, I would like to invite the Afroz Alam. Now over to you, please.
Thank you, sir. Thank you. Good afternoon to the respected chairperson, the reporter, and other dignitaries over there. Myself, Dr. Afroz Alam, is going to present my presentation for today on the perspective of bryophytes in the management of So is it visible to all, sir?
You can proceed it.
Yeah. So
Can
my
presentation mode, sir. Presentation mode, sir.
okay, okay. Now it's okay, ma'am?
Yes.
Yes,
Yeah.
yes, sir.
Okay, sir. So my topic for today is perspective of bryophytes in the management of post-harvest fungi. And the basic of this, because I am a bryologist and I have encountered some of the bryophytes which have very good antifungal activity in them. So that I have chosen this topic. So what are post-harvest fungal diseases? We all know that post-harvest fungal diseases is one of the noteworthy factor that limits the storage duration and selling life of the harvest product and even result in stern financial losses globally. So we all know the impact of post-harvest fungal diseases on the vegetables and fruits, and usually we use chemicals to cure them. But now is the chance to come that we should see some other things for the control of these fungal pathogens like bryophytes. This slide shows the importance of post-harvest management, and we know that we should require this post-harvest management for the food safety, quality assurance, better storage, better protection from pest, reduce losses for qualitatively and quantitatively both, better marketing opportunities, and the major drawback of all these that huge yield loss, which is very alarming in present scenario. The major causes of post-harvest management, why we need these management, because during the normal management of the our harvest, we have insufficient harvest, labor shortage, harvest immature and over mature produce, lack of proper storage, poor processing techniques, limited drying facility, increased rainfall, rough transportation, lack of new techniques, and farmer unfriendly. These are the major cause because of which the fungal strains affect the vegetables and fruits. Now the major point for in my talk for today is the drying and transportation method which we use for the deliver our vegetables and fruit to remote areas and other rural area and marketplace. So these are the two core aspects which need a look to increase the shelf life with agreeable quality of the product. And now the utility of phytochemicals has come. Apart from chemical control, which are very well known to us, now the biological control using microbial antagonistic have been explored as an alternative approach for the management of post-harvest disease, which are precious for the precious harvest. Many phytochemicals have been identified and applied for this purpose, and remarkable observation were made. And we all know that we have a good range of phytochemicals like steroids, quinone, phenols, terpenoids, etc. And these are the natural fungicide, and these plant extract which are basically from the angiospermic flora. Now various plant extract have been used as efficient fungicide inhibiting the growth of many fungal pathogen. Many results have been you can see on the web and other papers that there are huge huge availability of these phytochemicals in the angiospermic flora, and they are being utilized for by different labs for their phytoconstituents which have. Now the bryophytes have come. Bryophytes are small non-vascular plant thalli such as liverwort, hornwort, and mosses, and they are very well known ecological role in the forest ecosystem and any ecosystem where they are growing. But now the time has come that we should know the ecological aspect of these bryophytes, and along with the economic aspect. We are all aware about the name of sphagnum. Sphagnum is a very good moss which is used extensively in the horticulture practices. But other classes of bryophyte like Hepaticae, Ceratopsida, and Bryopsida, all these three classes have huge diversity in them, and you can see the habitat of these bryophytes where we can collect these bryophytes easily from the hilly regions of the country, and there is no limitation of these bryophytes to collect, and they can be collected in wet form as well as dry form in their habitat. So diversity, sorry. The main focus of bryophyte that they have the very good water absorption capability in them, and that is why we can use during the transportation and storage of the food product, especially the vegetables and fruit. We can use them in a dry form when we want to remove the extra water from the surface of the fruits and vegetables. They can absorb that water, and when they absorb the water, they start the metabolism in them, and that provide the phytochemicals which are antifungal in nature. And by doing this, we can also protect the unnecessary water from the surface of the vegetables and fruits, and also we can protect them the fungal attack, because a layer of bryophytes around them will be a very good protection for their shelf life. So common horticulture uses which are being used by in the different parts of the world, that is, it is used for the soil conditioning, culture, seed beds, hanging basket, terracia, mushroom culture, pot culture, air layering, etc. And in horticulture, when we want to transport something from here to there, and we use sphagnum frequently. But other bryophytes also have potential, although they are neglected till date. There are not many reports on the bryophytes regarding the phytochemical activity. So bryophytes are the ignored plant as antifungal agent. There is little information regarding the usefulness of bryophyte to control post-harvest plant diseases. And bryophytes, although they are lower plant, but they have huge capability in them in terms of their phytochemical content. And like other angiospermic flora along with the pteridophytes, they produce antifungal efficacy, and which can be used in future for the post-harvest management of our fruits and vegetables. So some compounds have been isolated by the different research group around the world, and one of the major compound is bis-benzyl, which is reported very good as an antifungal agent, and this phytochemical is effectively used against many post-harvest fungal pathogen, and the results are very good. So other compound beside this is plagiochilin, which is pungent in taste, and it is also isolated, and it is also tested against many fungal strain, and the results are very good. So there is a range of bryophytes which can produce these chemicals, which can be used for the protection of vegetables and fruit during the packing and transportation. These are this pic shows some of the colonial form of the bryophyte moss. You can see the patches of moss in the form of cushion and turf, and they can be easily collected from the field. They can be dry up very quickly, and they can absorb the water very quickly, or because they are the resurrection plant, and this utility is somewhat ignored in the management of the fungal diseases till date. So the common example of bryophyte is sphagnum. We all know about the use of sphagnum when it's come to the economical part of the bryophyte. We always say that sphagnum is the best plant. But apart from sphagnum, there are also a range of bryophyte which can be used. So extraordinary water uptake of sphagnum is the main point because of this this plant is used extensively in horticulture practice, and this is the pic of a dry form of this plant. And this plant in dry form can be used as a stuffing agent when we are doing the transportation and storage of the fruits. So beside the use of the other papers and other things which are used in the packing process, we can use these bryophytes in the dry form. So antifungal potential of bryophytes, many bryophytes exhibit antimicrobial effect, that is against the fungi and bacterial strains, and they are also not damaged by larvae, fungi, bacteria, snails and mammals. And so quite a good range of contaminant can be protected by the use of these bryophytes, because they have in them oligosaccharide, polysaccharide, sugar, alcohol, amino acid, fatty acid, aliphatic compounds, phenylquinol, aromatic and phenolic substance. So huge range of phytochemicals in them, but they are somewhat ignored. So the phytochemistry of bryophyte shows that they have the reservoir of biologically active compounds like lipids, protein, steroids, organic acid, alcohol, aliphatic and aromatic compound, polyphenols, terpenoids, acetogens, and phenylquinones. But apart from their horticulture uses, now they are being used as an anti-tumor, antipyretic, and insecticidal and antimicrobial agent. So the research is going on, and in India, this part of bryophytes is almost left by the bryologists and other scientists, and now there is a need to take up bryophytes as an antifungal agent in more and more study. So antifungal efficacy have been shown by the various group of scientists around the world, and in some cases the antifungal activity of bryophytes is very good. For example, in Saccharomyces cerevisiae, the results are very good, and Candida albicans, the results are also very good. So these have the potential, especially they are tortusa, which is a moss, and Pleurochaete, Ascoressa, and Syncretia ruralis. These all are moss genera which have the capability to fight against the fungal pathogens. So aqueous crude extract of Bryum argentum are also explored for this particular aspect of the fungal attack, and it was found that Curvularia lunata, Discleria medis, they can be protected. They can be combating by these compounds which are found in these bryophytes. And the plant Philonottis revoluta, which is a very good moss and easily available around the world. In India also, we can collect this moss everywhere, and this moss has a very good antifungal activity against the Helminthosporium tursicum. Other phytopathogenic fungi were found susceptible to crude extract of moss, like Aspergillus niger, Fusarium, Moniforme, Rhizoctonia, Betaticolia, and many of the phytochemicals obtained from the bryophytes show good result against these particular fungal pathogens. So the antifungal potential of bryophyte, as in case of association between the bacteria and tortula, is also observed, and it was found that in the combination of some bacterial strain, the action of the bryophyte is more than the sole bryophyte extract. So in the combination of the microbes, they can be used further to protect the fruits and vegetables from the fungal attack. This table show the fungal and bacterial pathogen and their host fruit and the disease, and all these fungal and bacterial pathogen were assessed against the phytochemicals obtained from the bryophytes, and good result have been obtained. So there is huge availability of phytochemicals in bryophytes. This pic show the some of the compounds which are isolated from the Japanese scientist, and this is hypogenol B1, which is a bioflavonoid, and parotitinin, which is Plagiochyla parotitana, is a plant from which its a particular chemical has been obtained, and the sphagnurubin, which is obtained from the sphagnum. So moreover, 3 bisbenzyl such as bajazin B, isoplazocin D, and other and sphagnurubin is obtained from the Bajania trilobata, which is a liverwort and easily available in the South Indian region of our country, especially the Nilgiri Biosphere Reserve. These are some more examples of phytochemicals obtained from the bryophyte and have good antifungal activity in them. This picture show the some of the bryophyte species, that is Radula, and other is Cephalozilla, bicuspidata, Markensia polymarpha, and Tortula ruralis. So these plants are also have good candidate for the assessment of antifungal biochemicals in them. Anthoceros, a well-known species of hornwort, is also there. Tarjunia species, which is other thalloid liverwort. Frulenia, which is a leafy liverwort and easily available around the world and also in India. Conocephalum conicum, which is easily found in the Western Himalayas region. So all these plants have good range of phytochemicals which can be used further against the fungal pathogen, and these plants can be used in dry.
Dr. Alam.
Yes, sir.
You finish within 2-3 minutes, please.
Yes, sir. I'm just finishing, sir.
Yeah. Okay.
Yeah. So the importance of botanical pesticide in the form of bryophytes. We can explore more and more these particular flora. The morphotaxonomic work is available to us, but the phytochemical content of the bryophyte has to be assessed in future, and more work is required in this particular aspect, and bryophyte should be used in the control of post-harvest fungal management. So the bryophyte, which are non-vascular plants that left the aquatic environment and colonized terrestrial land around the Ordovician period, and that is why they had to fight against the biotic and abiotic stress, and during that they contain many bioactive chemicals in them. So till date there are no such work is there, which can show the potential of bryophytes in the phytochemical as phytochemical reservoir. But we should use bryophytes because of the huge diversity in them, the effortless growth of these bryophytes, and easy to manage in limited space, and in dry form they can be managed in a very limited space, and excellent water holding and evaporation capability. They can be dry up very quickly, and they can be swell up very quickly by absorbing the water. And when they absorb water, they become the reservoir of antifungal compounds. So these are the features why we should use bryophytes for the antifungal antifungal agent. So these are some of the important reference from where I have taken some of the slides of this particular presentation. So thank you very much. And at last, I am very thankful to the organizing committee for inviting me to present this lecture. So thank you, sir. Any question?
Okay. Thank you, Alam.
Thank you, sir. Welcome.
Dr. Niranjana.
Niranjan, sir, you are muted.
Dr. Niranjana.
So you can continue, sir. KP Singh, sir. Most probably
yeah.
is busy with some phone.
Okay, so now continue for second person. Ifat Sanaz here.
Yes,
Hello.
sir. Yes. Yes, sir. I'm here.
Ifat Sanaz.
Yes, sir. I'm here.
So
should I start screen sharing?
Yeah. Ifat Sanaz, now assistant professor in division of plant pathology, Sukas Kashmir, Salimar. No, she did. No, she is working as an assistant professor in Sukas Kashmir, and now having the senior skills, scientist in selection grade, Sukas Kashmir. Now published 1 book, 9 book chapter, 30 full-length research paper, and guided 5 students as a major advisor and 9 as a member of advisory committee of MSc and PhD students. Now she worked on the biological control, mycology, bacteriology, remote sensing, and plant pathology. So please, Shanaz, you can start with.
Just a second, sir.
Yes.
Sir, is my screen visible?
Yes, visible.
Yes.
Thank you, sir. At the outset, I would like to thank the organizers and everyone present here for giving me an opportunity to present this short presentation on biological control of post-harvest diseases with special reference to Trichoderma species. Respected chairman, reporters, and other scientists present here, I would like to start with the global scenario. And the figure here depicts that the post-harvest losses are post-harvest and processing losses are more in the developing and the underdeveloped countries. And they are very less in the developed countries like Europe, North America, Oceania, and industrialized Asia. Whereas in the developing countries and underdeveloped countries like Africa, Southeast Asia, South and Southeast Asia, and Latin America, the post-harvest and processing losses are very so the stages at which the post-harvest losses occur in horticulture commodities are mainly 5. At the time of production and or harvest, after the harvest, when we are handling the produce and then storing it somewhere, then processing or some pre-processing stages where we use different containers we use different methods for pre-processing, then distribution when the material is taken from the field to the wholesale market, and then the consumption where the produce is taken from the wholesale market to the ultimate consumer or the retailer or the ultimate consumer where the food is consumed. These are the various stages at which the post-harvest losses occur. These they represent a waste of resources used in the production, such as land, water, energy, and inputs. It has been found that, am I audible, sir? Am I audible, sir?
Yes, yes.
Okay. It has been found that about 20 to 25% of the food is lost at the post-harvest stages. In the developed countries, these losses are minimized to a large extent, but in the developing and the underdeveloped countries, the losses may go as high as 20 to 50% or even as high as 80% in some cases. Then post-harvest losses, they result in the degradation in both the quantity as well as quality of the food production. The quality losses are those losses that affect the nutrient and calorie composition, the acceptability and the edibility of a given product. And these losses are generally more in the developed countries, and in developed countries, people are more conscious about these quality losses also. These quality losses, they can occur as a result of nutrient loss or undesirable change in taste and texture, or the presence of excreta and contamination by mycotoxins. As we know that the mycotoxins produced by the Aspergillus or Fusarium, those are more toxic, and they are the most dreaded toxins in the post-harvest cases. Then quantity losses, they are more in the developing countries, and they refer to those losses that occur as a result of the loss in the amount of the product. They occur due to the weight loss, spillage of crops, or microbial attack, or the pest attack. Here we are more concerned with the microbial attack, and I will just gloss over the, I'll just shift to the microbial attack. Microbial causes of post-harvest losses are many. I have enlisted here only a few of the fungi and only a few of the bacteria. Among the fungi, Penicillium, Botrytis, Fusarium, Sclerotinia, Alternaria, even Phytophthora, and some other pathogens, they cause a heavy loss in the post-harvest post-harvest stages. Among bacteria, mostly Erwinia, Pseudomonas, Bacillus, Lactobacillus, and Xanthomonas, they cause various types of rots that result in the post-harvest losses. Then these are some of the common post-harvest diseases in fruits and vegetables. In apple, Penicillium rot is most dreaded. That's caused by Penicillium expansum. In strawberry, it's the gray mold caused by Botrytis cinerea. This pathogen, Botrytis cinerea, it causes heavy losses in a number of crops, like in strawberry, apple, kiwi, quinoa. Many of the fruit plants are affected by these post-harvest loss by the pathogen, namely the Botrytis. It's a very dreaded pathogen and is among the top 10 dreaded pathogens. In banana, crown rot caused by Colitotrichum. You see tomato, Rhizopus rot, chili and anthracnose, that's Colitotrichum. In grape, gray mold, again caused by Botrytis cinerea. In pear, Rhizopus rot, and tomato, Alternaria rot. This list is by no means an extensive list. It's very short list and it's very comprehensive list. In reality, there are many crops, many fruits, and many vegetables which are attacked by many more numbers of pathogens. Then post-harvest losses of fruits and vegetables. Kenya, like in banana, the losses go from up to 50%. And this is the losses in different crops in different countries. However, I'll shift to the post-harvest losses of fruits and vegetables in India, where in mango, the losses are as high as 20 to 26%. In banana, it goes from 18 to 30%. In grapes, 14 to 20%. Pomegranate, around 35%. Potato, tomato, bell pepper, cabbage. In cucumbers, you can see that the losses are very high. They can be as high as 52%. Now the question is, when the infection occurs in the the post-harvest pathogens, when they occur in the field, the infection process can start anytime from pre-harvest to the post-harvest. In the pre-harvest infection, the pathogen can attack the crop before the harvest, from the time of flower opening to the fruit development stage. These infections are mostly in the arrested or latent infections. The pathogens remain quiescent in the fruits And when the and in the developing fruit, and when the fruit stops to develop and the senescence creeps in, at that time those pathogens become active and they can cause severe losses. However, the post-harvest infection, they occur mostly after the harvest by the penetration through the skin or by through wounds or lenticels or pedicels. These occur mostly by the bruising, and they occur after the post-harvest during the handling or storage or moving of these produce from one place to another. And the most common examples are the penicillium and rhizopus. Then the sources of infection. The sources of infection, they may be at the field or the orchard. When the produce is harvested from the trees and kept in the field for the removal of the field heat, they can be in the greenhouses. They can be for the harvesting tools or the equipments used for the in the greenhouses or in the field. They can be the buckets, carts, or boxes, or anything that we use to transfer the fruit or the produce from the trees to the storage bins or to the packaging facilities. Then storage facilities, it has been estimated that if the storage facilities itself are a source of contamination, that can cause a havoc with the produce. Then markets, of course, the markets are a very high source of they are the source of contamination, and it's very difficult to control the contamination in the markets. Then these post-harvest diseases, they cause considerable losses affecting the production and productivity of the crops. And usually these post-harvest losses were kept to a minimum by the use of fungicides, particularly benzimidazole, imazole. But these chemicals are due to the health consciousness and the environmental concerns and the attitude of humans and the recent chemicals that have been found to be associated with the use of these chemicals. Now the shift is there is a trending shift is towards the safer and alternative use of the fungicides. And among these shifting, among the major alternatives, there are the plant extracts are there, endophytes are there, or the use of oils are there. However, biological control may be said to be the best alternative. Then what is biological control? Biological control was defined by Garrett in 1965 as any practice or condition under which survival or activity of a pathogen is reduced through the agency of any other living organism. Now this definition has been expanded to include all the in the gene products or any other product of the biocontrol agent that can reduce the post-harvest, that can reduce the another organism, or that has an inhibitory effect on another organism. The basic approaches for using the microbial antagonists, that are two approaches. First is the use of microorganism which already exists on the produce inside. That is the use of the indigenous microorganism that can be used, that can be isolated and manipulated for the control of the pathogens. And the second is the artificially induced microorganisms that can be used against the post-harvest pathogens. Of course, we can say that the use of microorganisms or the phylloplane organisms, they can more efficiently be used against most of the pathogens. But the main problem is the isolation and the time required for the isolation of the most efficient biocontrol agents. Then natural biocontrol agents, these are present naturally on the surface of fruits and vegetables, and they are used on the control of post-harvest diseases. They can be used, they can be isolated from the fruit or from the phylloplane or from the indigenous soil. And we have found that these indigenous microorganisms, they are more efficient in the control of the pathogens at that site. Example is the concentrated washing from the surface from the citrus fruit. If they are plated on agar medium, only the bacteria and the yeast appear. But when these there is a dilution of these washings, then several rot fungi also appear, which indicate that the yeast and bacteria, they suppress the fungal growth and prevent the growth of the post-harvest pathogens. Then artificially introduced microbial antagonists, these are very easy to use. They can easily be obtained from various reputed institutes, and we can use them for the management at that particular place, but it has to be undergo the several tests before they can be used at some other place. These are some of the microbial antagonists that have been used for the successful control of the post-harvest diseases of fruits and vegetables. For example, Candida it has been efficiently used against Penicillium rot in apple. Bacillus subtilis has been used against gray mold in strawberry. Pichia has been used against, these are the yeast. They have been used against crown rot or rhizopus rot in banana or tomato or chilies. And Candida oleifera, it has been used against gray mold in tomato. This picture, I wanted to show that Bacillus was evaluated. This is the work of Corsten and co-workers in 1991. Here we can, I wanted to show that Bacillus was evaluated under the commercial packing house conditions, and they used tag wax at various concentrations. It was found that this Bacillus subtilis, it was very effective in managing the fruit rot complex and the stem rot. And one of the important points in this study was that although there was an initial dip of the viable cell count immediately after the inoculation with tag wax, but this cell numbers, they eventually increased to same level as that of the initial inoculum, and the antagonist could therefore survive and multiply in the tag wax, and that has an additional benefit for us. Here I wanted to show the difference when these are the first picture shows the lemon treated is only treated with Penicillium digitatum and it has been entirely covered with the fungus. The second is the picture together with the cell suspension of the antagonistic bacteria Bacillus subtilis and Penicillium digitatum and negative control. It's a visible difference in the results. Here I wanted to depict that when these microbial antagonists, they are applied before the inoculation with the fungi or the pathogenic fungi, then about 48 to 72 hours before the application of the fungi, then they give more significant control, and they can be, this shows that if we use the pre-harvest or post-harvest dip of the antagonist, we can better have a better control of the pathogens.
Dr. Sanaz, Dr.
Yes,
Sanaz, you should finish within 1 or 2 minutes.
Okay, sir. This is the, since my topic was on the trichoderma, it was the special reference to trichoderma. This table depicts the particular pathogens which have been controlled with the use of the trichoderma species. Then biocontrol for the trichoderma species for the crown rot of the banana, it was found that these banana, here they these scientists, they used a number of 3 trichoderma species. When they were used together, they could more efficiently control the crown rot disease as compared to when each of these was used separately. Then these are the characteristics of an ideal antagonist for post-harvest pathogen. Now I wanted to show in this slide that sometimes what happens that trichoderma does not control the is not used sufficiently used, for it is not effective against the post-harvest pathogens when used separately or alone. However, when it's used with the combination of other systems, then the control is more, and in some cases it's equivalent to that of the fungicide treatments. For example, we can use fungal and bacterial biocontrol agents together, or we can use substances like chitosan. In some cases, we can use the physical hot treatment like the hot air treatment. In some cases, application of some nutrient base like proline or asparagine, and in some cases, some salts may be added that help in the enhancing the efficacy of the trichoderma species. Trichoderma has an additional benefit that it can be used as a plant growth promoting, and thus besides the control of the pathogens, it also increases the growth of the plants. Then application methods, they can be used as a pre-harvest or the post-harvest application. And pre-harvest application, it has been found effective when the source of infection is the field. However, post-harvest application is found to be better. And when the infection is caused in the post-harvest infection, like in the bruising or in the transport. And the methods are mostly for the dip method or the spray methods, they are found to be very effective. Then the commercial application, they can be there are many reasons for decreasing efficacy and inconsistency. These are some of the reasons that have been enlisted by Robbie in 2015. Then these are the constraints in the public reaction to the living fungicides, because it has been some of the people, they are fear that these living organisms may harm them more as compared to give them the benefit. However, microorganisms have been used since ancient times, like in the pickles and fermentation. So we are already exposed to a number of these microbial antagonists. So we need not worry. And these antagonists, they do not leave any residue. So there are not any health benefits also. These are some of the references which I have used in compiling this presentation. And I thank the organizers for inviting me to give this lecture, and I thank you all.
Okay, thank you, Sanaz. Now very informative lectures. And I think now it is more knowledgeable, especially for the post-harvest diseases of fruit and vegetables.
Thank you.
Okay, thank you.
Thank you, sir.
Dr. Niranjana, please, Dr. Niranjana. Dr. Niranjana. Dr. Niranjana.
Sir, I think he may got disconnected, sir. Shall we continue with?
No, discussions will keep it at the end.
Dr. Niranjana, if
Sir,
you allow
sir,
me, Dr. Pratibha Sharma is here. If you are allow me, then now start her lecture.
You can introduce her and just ask her to start.
Okay, could not. Dr. Niranjana.
No.
Dr. Pratibha Sharma is here.
No,
If you
now she is ready to deliver.
You can.
Pratibha Sharma is ready to deliver a presentation now.
Dr. Pratibha Sharma is here. If you allow me, then now she will deliver the lecture.
Yes, you please introduce her.
Please, Dr. Pratibha Sharma.
Yeah.
Before
Yes.
Dear
KP
delegates,
Singh.
please,
Yes, sir,
dear
is-
delegates, Dr. Pratibha Sharma.
Yes, I'm here. I'm here. Actually, I came many times to this presentation, but every time I found that this thing is not starting. So, Dr. Niranjana, good afternoon. And
Okay, dear delegates, Dr. Pratibha Sharma, now ex-professor, Division of Plant Pathology, IRI, now joined Agriculture Research Services in 1976 after completion of his MSc Botany from the Rajasthan University. Completed her PhD from the Kanpur University as and the service candidate while serving as a scientist in Institute of Pulses Research Institute, Kanpur. Trained in host pathogen interaction from the Göttingen University, Germany in 1993 to 1994 through UNDP FAO fellowship.
Dr. KP Singh, Dr. KP Singh,
yes.
we can forget about the introduction. I will start with the presentation. Otherwise,
Okay, thank
it
you,
will
madam.
keep on. It's
okay.
okay.
Okay, thank you, madam.
Yeah.
Okay, thank you, madam. You please
Yeah,
start.
I'll speak.
Madam is well known. Everybody knows there is no introduction for madam.
No. It's not required. I'm here. It's all okay.
Please, madam.
Yeah. So, actually, very good afternoon. And I was attending the session since 2 o'clock and some other session was going on. So I was not able to understand what to do. So I left around 2:30. Sorry for that. Now I will start my presentation because as I came to know, the presentation time is 20 minutes, so I will try to finish up to my best. Of course, I welcome all. I welcome Dr. Niranjana on behalf of Indian Phytopathological Society and all our delegates, youngsters, international delegates, our national delegates, everybody. So welcome to this session. And now I will start with my presentation. Actually, I was listening to Dr. Shehnaz. She was speaking. I think half of the work has been done by her, and she could relate to the subject very nicely. Now, what I'm also going to speak is on all the how important are the biological control agents, and how we really increase the bioefficacy in the post-harvest disease management. Now, one way it is very clear that when we are talking about the food losses and food waste, as FAO has reported, that food losses that take place at production, post-harvest and processing stages in the food supply chain and food waste are that occur at the end of the food chain, that is retail and final consumption. In horticultural commodities, the stages at which post-harvest losses occur can be divided into 5 such parameters, that is production, harvest, post-harvest handling and storage, processing, distribution and consumption. So post-harvest losses, they represent a waste of resources used in production such as land, water, energy and inputs. Now, as we all know, we are facing the climate change and now it is really affecting also. So many changes are occurring in the biotic and abiotic stresses, and so therefore, as we all know that by 2050 we have to increase our production at least 70%. So at the same time, people now they are also becoming conscious that sustainable agriculture, it's very important. It is fundamental to gather the future world's agricultural staples. So one way to develop sustainable crop production processes is to enhance the beneficial plant-associated microbiome. So this association, known as holobiome, strongly influences the nature of the phytomicrobiome. So this is a very important study, and I'm sure the young scientists and young colleagues, they must be working on the different aspects of the microbiome, whether in the means phytoplane, or whether it is in the rhizoplane. How post-harvest diseases really make an impact on the losses. Actually, as we know, our country is suitable for the cultivation of almost all varieties of fruits and vegetables, more than 40 types of vegetables and 30 types of fruits. It is reported that more than 30 to 35% of total fruits, around 20 to 55% of vegetables, they are lost due to poor post-harvest practices. So post-harvest management technology, it's absolutely, organizers have really taken a very good subject, and really I congratulate the organizers who have really given this chance, and we are really thinking on this aspect. As our Director General also yesterday, he was saying that we have to not think in the terms of the production now. It is actually the harvesting of the commodities and the including the procurement, removal of the field heat, sorting, then grading, packaging, storage, transportation, primary and secondary processing, marketing. So it is really a combination where we have to really concentrate that how we have to do away with this, the post-harvest losses. The post-harvest losses is immense, huge amount of like strategies have to be developed, intensive strategy, and it really needs not only one aspect also, but multifarious aspects. And since we know all the physiological aspects, biochemical aspects, that since losses they occur due to senescence and microbial decay, pathogen effect, and which are also affecting the quantity and quality. So we have, I think, hurriedly, I will say that how many types of pests and diseases, they are the biological means, and chemicals also responsible for the post-harvest losses, mechanical, then physical, then physiological. So all these parameters are responsible for causing the post-harvest losses, and we have to be really very careful about all these aspects, because when it comes to the external contamination with pesticide and chemical products and toxic and unpleasant flavor which is produced by the pathogen, so then mechanical is also equally important when it comes to injuries, cuts, bruises, because they are all really means they allow the pests and pathogens to develop. So similarly is the temperature, physical heating, cooling, freezing, and all those parameters and physiological, as I said, sprouting, rooting, senescence, all these are actually joining together for the different post-harvest losses. So we know the primary causes microbial as well as environmental parameters. Of course, post-harvest losses are exceeding, or sometimes it looks like 50% of the harvested crop. Now, as my speaker earlier has already said that the main genera which are responsible are Alternaria, Aspergillus, Botrytis, Fusarium, Geotrichum, Cloisporium, Modilia, Polytrichum, Penicillium, Leucor, Rhizopus. They're the major post-harvest pathogens which are responsible for the fruits and the vegetables. So the symptoms, as we all know, they appear during the infected crop. Sometimes it is in the transportation and storage. And it is also that sometimes the pathogen remains incubated and they get really appear the latent infection. So the disease appears when the conducive temperature is there. So we have to be really very careful about this, about our disease management. So these are some examples. Of course, we can see that Polytrichum, Neophysicum, then Lecidopiridia, Plasmopsis, Alternaria, some of the photographs of the disease symptoms. Now, if we have to find out that how these pathogens they are really causing, so we all know it is through the wounds, natural openings, and they are coming to the stem ends and pedicels by direct branching and to the post-critical. Pathogens sometimes they remain inactive and invisible during the storage. But when the fruit ripens, they also begin to ripe, and fungal pathogens, they go aggressively and kill the host tissues necrotrophically and take nutrients from the host, leading to decomposition of the tissues and decay initiates. So pathogenic fungi may live dormant either endophytically or hemibiotrophically. So the intrinsic disease resistance mechanism, which is protecting the fruits from fungal attacks, it becomes weak or inefficient, and then the fruits become vulnerable to these fungal attacks. So fungal, bacterial attacks some viral diseases also. Since more I am concentrated on the fungal part. So post-harvest disease biocontrol then becomes vital. We have to be careful. So why do we use microbial antagonists? Since the session is meant for the biological control, and why we have to use it actually. So restricted by because microbial antagonists naturally they reside on fruit and vegetable surfaces. And it happens that many effective antagonists have been isolated and characterized as suitable biocontrol agents for the control of post-harvest pathogens from fruits and vegetables. In addition to the food surface, phyllosphere is the best source of microbes with antagonistic role. Many antagonistic microbes were isolated and characterized from roots and soil. For instance, the yeast Rhodotorula glutinus. It was obtained from the tomato phyllosphere, which inhibits the growth of Botrytis cinerea, which is a causal agent of the mold on tomatoes. So we found that it was found that Rhodotorula glutinus is a very important yeast. Similarly, Cloiquera epiculate is isolated from citrus fruits and which effectively controls the post-harvest pathogen. Penicillium italicum on citrus and grapes. And some effective micro or antagonists, they have also been investigated in unique natural habitats. Like for example, an isolate of Leucosporidium scoti was isolated from entire soil, which was identified as an efficient microbial antagonist for the penicillium expansum and Botrytis, which is responsible for blue and gray mold of marine yeast like Borosporidium, Calubiginum, and osmotolerant yeast isolate, which inhibits the penicillin expansum, which is growing on the pear fruits, while Alternaria alternata inhibits the penicillin expansum growth of the Chinese fruit. So marine yeast typically have greater osmotolerance ability as compared to yeast which are isolated from the fruit surface, and therefore be more suitable candidates for use under the conditions of high fruit. If we are asking the question like why do we use as I was referring that why we are using this biocontrol agent, microbial biological control agents, because we all know, and I think the whole house and my other speakers as well as the young scientists who are very nowadays biological control has become an alternative to other management practices. It's become a part of integrated pest management, and And I think our chairperson, Dr. Niranjan himself, has worked on various aspects of the biological control and microbiological technology, especially. So, and Dr. KP Singh from Pantnagar and all will agree that how biological agents have really been very useful. And since now we are very clear with the modes of action, and this mode of action, of course, everybody knows that it may be antibiosis, it may be microparasitism, it may be induced resistance, and inhibiting through enzyme activities and different mechanisms, multifarious mechanisms are there. So since the biological agents, they can really work through these different mechanisms, and a good amount of work has been done actually on these aspects. And it is continuing, people are really very interested in working, and so the studies is continuously going on the various aspects of the biological control. Now, when we are talking about just this to show like how a microbes biocontrol agent releases the root exudates and other rhizodeposits for stimulating the growth of microbes and microbial community in rhizosphere soil, and they are also responsible for the plant growth promotion also, and the pathogens which are being infected, I mean, they are being managed by the biological control because they can very well express the antibiosis and hyperparasitism and this thing. And also there is another under that how they can induce resistance in the phylloplane, and this further helps actually. So this whole mechanism of action where like salicylic acid synthesis and pH expression and different like synthesis because of the different pathways. So these microbial antagonists, they can be very well employed in like for post-harvest management. So since we are clear about this these mechanisms, we can go further ahead, as my earlier speaker also was talking that pre-harvest management and post-harvest management. So we have to be careful when before harvest, what should be our strategy, and post-harvest, what should be our strategy. Now, since we are working with the microbial agents, naturally we have to be very careful while application also, how to apply, and so therefore, pre-harvest management really solves a lot of problems, because once we are able to manage the disease properly there, and I think the post-harvest, we are able to reduce the incidences of the post-harvest management, post-harvest problems. So that, like for example, Aery-Bacillium pullulans reduce significantly the storage rots in strawberry, grapes, cherries, and apples. Similarly, there are examples of reducing the green mold on grapefruit by pre-harvest spray of Pichia bullier. Then in peer field application of Cryptococcus cholerica and Candida was reported to reduce storage rots, whereas pre-harvest application of Pentoia and Epicoccum, they were reported to be effective against citrus rots. So, and there are other examples also where they were found very effective against the storage rot of oranges. And basically, pre-harvest application is actually to pre-colonize the fruit surface with antagonistic microbes, so that fruits can be colonized by the antagonist before colonization by the pathogen. So your objective is that if we can reduce that that pathogen cannot colonize, then it becomes easy. So therefore, pre-harvest applications with yeasts have been found, like Tricho, Cryptococcus orangeale, Rhodotorula, Trichospora pullulans. There are many reports of Trichoderma hertzianum and Epicoccus nectarum. They have also proved to be very good. Trichoderma is definitely, since I have worked all my life on the Trichoderma, I'm still working on that. So we know that Trichoderma has got the multifaceted role, and already been explained by the other speaker also, that how it can be very effective for the post-harvest control of strawberries where synthetic fungicides have been ineffective. Now, coming to when we come from pre-harvest to come to post-harvest application, we know that in modern food conservation techniques, the product shelf life have to be prolonged. So in the post-harvest phase of food production, there are still significant product losses. So therefore, we have to be very careful how to really control this 20 to 25%, because it's not necessary, because if they have the prolonged shelf life, and then also we are getting some problems. So there are, of course, for that also we have numerous microbial antagonists, fungi, yeast, and bacteria, which can be used on fruits and vegetables in both the conditions. And These antagonists, they have reached advanced levels of development, marketing. Currently, there are several on the market. Although their application is mostly targeted to deteriorating microorganisms. Now, post-harvest application, it appears to be better for controlling when that application are directly onto the surfaces actually. And many examples are there for like Trichoderma hirzinum, viridi, Glycodium motif have been. There are various examples of Pseudomonas species, Trichoderma hirzinum again against Aspergillus and Fitherian rots and lemons, etc. So various examples are there. And just to show that how at the surface only see the microbial antagonists, post fruit and pathogen, they really have a good tug of war, and then the mechanism helps in the antagonism. So why Trichoderma species already explained, it has a multiple mode of action, and there are many other than Trichoderma like Bacillus pseudomonas and many mycorrhiza which are working as biofertilizer, biopesticide, plant growth promoters, and biostimulants. All are working. So all are helping in the post-harvest pre-harvest disease management as well as in the post-harvest assessment. So in the post-harvest assessment, we try to reduce the conducive environments also and minimize the amount of the pathogen so that we cannot contaminate the crop before harvest. So there are many examples like this example, blue mold and green mold of this thing, that how from the orchard harvest and this packing house this disease is getting, but we have the management practices and anthracnose of banana. There are examples of some species of Trichoderma which have been helping in managing this problem. Similarly, black rot of pineapple, it has been observed that Trichoderma aspergillum, it has been observed to be as an alternate eco-friendly method for this particular disease, that black rot of pineapple. Then papaya fruit anthracnose, again a very important problem, and this has been found to be that Trichoderma has helped in management of the disease. Then blue mold of apple, strawberry of anthracnose. There are various examples. Fusarium decay of cucumber, anthracnose of pomegranate, then neck rot of onion. There are various examples where we find that Trichoderma has been found to be very effective. So Trichoderma in combination with the yeast have also been found to be very useful in crops like banana, mango, grape, and faba beans and citrus, tomato. So all singly also as well as in the combination also. So they have been found. Of course, we all know that heat treatment, edible coating, irradiation, sulfur dioxide, ozone, then controlled atmosphere, and then modified atmosphere. This all helps in the management, but and different coating materials. Now, in hand as we can enhance the bioefficacy, and this enhancement can be very well comfortable when we can use salt additives, calcium chloride, calcium propionate, sodium carbonate, sodium bicarbonate, potassium metabisulfite, ethanol. All along with the microbial antagonists can be very well used. Of course, there are some nitrogenous compounds like L-aspargine, L-proline, DF3, B sugar, which have helped in some of the fruit and vegetable decay. So there are many examples we can quote here, and of course, all either in together or separately, when they are being used, they have been found to be very good. Whether even as Dr. Shahnaz was also saying that we can use hot water treatments or some cultural or some other practices, physical practices. So the hot water treatment has helped Debarium hence it could be stored for a longer time as compared. In apple also, hot water treatment or bruising has been applied to check host caused by penicillium, expansor, and perfectus. So when we are talking about the future prospects, we can very well say that a time has come when we have to understand the functional role and impact of the endophytic, epiphytic microbiome of food to provide essential information to develop effective and biofunctional biocontrol system. And we propose the natural and synthetic microbial concentration to be used to prolong shelf life for harvested horticulture by controlling pathogens and regulating the physiological orders. So the subject is full of scope, and I think our young scientists can go ahead with a lot of researches and come out with very commercial and applicable solutions for the post-harvest management of the problems. So I acknowledge our organizers and I'm thankful to the chairman and the reporter and all my colleagues who allowed me to speak, present my presentation and express my views. Thank you very much.
Very nice and illuminating lecture. You are covered well in time, and time is, I think, it is maintained. I don't think any, or madam, if she is ready, then any audience can for specific 1 or 2 questions if you have. Otherwise, we will move further. So
I
then
think
no
the
question.
people can ask me personally, and I will be happy. I think most of them I know them also. We can.
Nobody is coming forward. Any
Yeah,
question?
no. It's all okay. Thank you very much.
Thank you, madam. Thank you very
Good
much.
afternoon, ma'am.
Yeah, good afternoon.
Good afternoon, ma'am. Myself,
Yeah.
Dr. Neetu Singh.
Yes, Neetu. How are you?
I am fine, ma'am, and you already are inspiration for budding scientists or women scientists, and you are really nice and very good presentation. Okay, ma'am.
Thank you.
Thank you, ma'am. Thank you.
Okay, thank you, ma'am. Thank you.
Okay. Thank you very much. Thank you, Dr. K.P. Singh.
Yeah.
Thank you, all of you.
Okay.
Thank you very much.
Dr. Niranjana.
Yeah.
Dr. Niranjana.
Now we have to go for Sanjay K. Singh. Sanjay K. Singh there?
Yes, Dr. Niranjana.
Yes, sir, I am here.
Just 1 minute, Sanjay Singh, na?
Yeah, yeah.
Dr. Niranjana.
Yes.
Actually, I could not introduce before starting the session, so I want to introduce to audience, first of all, Dr. Niranjana.
Very brief.
Yeah.
Make it brief. Time
Yeah,
is
simply now brief, only
please.
1 minute. Yeah. Dr. Niranjana, presently working as a professor and chair at Mysore University. Now former Vice Chancellor, Gulbarga University, and now Chairman, Research Advisory Committee, Central Silk Board, Academic Council member, University of Mysore. Now he had published more than 204 papers. Now he guided 21 PhD students and 40 MPhil students. Now his achievements is established Asian Seed Health Center at the University of Mysore. Now working as molecular plant pathology, host pathogen interaction, and biological control. He also worked on the post-harvesting technology involving storage, mold, and microbes. Now he handled several projects like DST, DBT, UGC, Adventa, EU, UGC, MHRD project regarding the disease management. Now he had several awards: National Academy of Agriculture, NAS Award, KC Mehta Memorial Award, National Academy of Agriculture Science NAS Recognition Award, Raja Ramanna State Award of Scientist, Government of Karnataka, recipient of Sri C.V. Raman State Award for Young Scientist. Now he is a fellow of different societies, like one of the NAS reputed society, fellow of National Academy of Agriculture Science, fellow of National Academy of Biological Science, fellow of Indian Phytopathological Society. So now this is the contribution of Dr. Niranjana. So okay.
Thank you. Thank you very much. Thank you very much.
Okay, thank you, sir.
Yeah, thank you very much. Now I will invite Sanjay K. Singh.
Yeah.
Sanjay K. Singh is going to deliver his presentation as invited speaker on trichoderma, an unconventional fungus bioactive potential for minimizing the post-harvest losses. So I would like to introduce in 2 lines. Sanjay, you have the long biodata you have given to the organizers, but presently he is working as scientist F in charge on biodiversity and the paleobiology in Agarkar Research Institute. And then he is a PhD in botany, especially the mycology, and is also a council member of IPS and is a recipient of Dr. S.K. Some Memorial, and also is a award from Mycological Society of India, A.K. Sarbai Memorial Lecture Award, and he was awarded DBT Associate Professor Associateship Program for Young Scientists. So he is given the long biodata, and he has published 100 research papers and 14 book chapters, and he has contributed a lot in the area of plant pathology. So that society is very happy to invite you to deliver the invited lecture in this particular session. And now it is over to you, Sanjay.
Thank you, sir. Thank you, Professor Niranjana, sir, and Dr. KP Singh. At the outset, good afternoon to everyone and all dignitaries, and for providing me opportunity to share what we have done here in our laboratory. So, title of my talk today is the Trichomerium and unconventional fungus possess the bioactive potential for minimizing post-harvest losses. I'm sure my slide is visible.
Yeah.
Okay.
Yes.
Okay. So I'm just here. I'm giving a brief highlights of the fungal diversity, which is considered as a gold mine for the invention in agriculture biotechnology. Now the situation of the fungal diversity is totally changed globally, and it is very well established the fact that the fungi are ancient in origins, with evidence indicating that the first appeared around 1 billion years ago. And if you look at the scenario, that around 1,48,000 species are documented so far. That is at the rate of 2,000 per year. That is the latest, updates of 2020. So, but what is the latest estimate suggests that the total number of fungal species on Earth is between 2.2 to 3.8 million. So, what in nutshell, what I would like to emphasize that only 6 to 7% of fungi are known to science up till now, and these 6 to 7%. They are not fully specifically evaluated for their potential in various sectors. So this is the situation of our science. So I think some problem, this slide is not moving.
Yes. Slider, I think it is hanged there. They ask remove the hangover now.
Yeah.
It's moving.
So I'm coming to the conadial fungi. It's quite often we overlook that the potential of a particular group fungi. Now, conadial fungi are very much, considered as a cell factory. If you look at the major discovery, whether it is about the organic acid, protein, secondary metabolite, like citric acid, gallic acid, glomamic acid, penicillin, glycium, all sorts of the discovery have been done using the conadial fungi or filamentous fungi. So these conadial fungi has really a great potential, and it is our inability or our ability that whatever we work and whether kind of solution come out using the fungi, because these fungi are not always to be criticized whether they are bad or good, but it is very well established the fact that this nature has created the solution of every problem. So some fungi, they are in a bad sense, they create the problem. See, last 2 days deliberation, we heard that most of the post-harvest plant pathogen, post-harvest and pre-harvest diseases, if you look at this scenario of the fungi, they are topping the list. So, but at the same time, if you look at the biocontrol mechanism to control these, diseases in a eco-friendly manner, so again, these fungi play a very vital role. So I'm talking about the Trichomerium. This is a very interesting story. We isolated this fungus as an epiphyte from a bark collected from the Himachal region. And these spores are like a very triangle, 4 to 5 arms spores. You can see here that it is there. And when we did the morphology, it was matching with the known species. But when we did the multi-gene sequencing and phylogenetic analysis, it turned out to be an entirely novel species. We published this species in Indian Phytopathology, but again, our intention was that what is this fungus means, how this fungus can be utilized as far as their potential is concerned. So then we utilize this culture, and after doing the all sequencing work and establish the novelty using the multi-gene analysis like ITS and LSU sequencing. So then again we thought that okay, let us see the where we can utilize this, because in India we have a customary to establish a novelty and we publish the taxonomy, and then after we forget that, and there is no afterward that what is the utilization or potential of this fungi, how to check that and where it can be utilized. With this intention, we started working and we run the fermentation, and we extracted the crude following the standard procedure, and we checked the crude of this fungus for their antimicrobial testing against the certain fungi and bacteria. So it was a really very surprise result we got, that it is inhibiting and sometimes inhibiting and the growth of the very well-known plant pathogen. Even they are considered as a post-harvest pathogen. You look like, see here some data, it is there, the Aspergillus niger, it is 156 microgram per ml MIC we calculated, which is damn good considering this notorious fungus like Aspergillus niger. This fungus, crude of this fungus, it is inhibiting. So we thought that it can be used for the certain purposes in for application, either it is in the field or maybe in the storage conditions. So a panel of fungi and bacteria, we selected that, and we did the analysis, and we were really on the right path. Then we thought that it is a crude. What exactly there in the crude? What are the compounds are available? This is the antibacterial. We did that against the certain bacteria like Micrococcus, Pseudomonas, Escherichia, Bacillus, Routella, Candida albicans. So some panel we took that, and it was showing a fantastic activity. Then we did the GC analysis. When we did the GC analysis, it gave a fantastic result, and all sorts of the fatty acid it is producing. So especially the maximum production was the oleic acid. Here you can see the 8 number. The maximum production is a percentage area was 57%, followed by the other like octadecanoic acid. So all sorts of fatty acid it is producing, which is really volatile also. So we searched the literature that where these can be used, that whether on what type of study we can design further to recheck and revalidate, so that we can utilize in the as a application. So we thought that being a volatile, these maybe fatty acid can be used as a biofumigant. And because it is producing whatever compound oleic acid is producing, and it is inhibiting the many bacteria, plant pathogenic bacteria and fungi, which are even to our surprise, it is also fantastically inhibiting the Fusarium oxysporum cubans, that is your Panama disease of the banana pathogen. We have this pathogen, we tested that, and the MIC is very less. So like that, we thought that we will have a more number of screening against the fungi being used as a either post-harvest or pre-harvest diseases, as well as the bacteria. So just to summarize our result, I would say that here this unconventional fungus isolated as a bark epiphyte was identified as a Trichomerium bhatti based on the morphology, sequence analysis and phylogenetic analysis of the combined ITS and LSU sequence data. The crude of Trichomerium was extracted following the fermentation and solvent extraction. Bioactivity of the crude was checked against the panel of bacteria and fungal pathogen. The crude extract showed significant bioactivity against a wide range of post-harvest and plant pathogens, including Aspergillus, Pythium, Sclerotinia, Rhizoctonia, Fusarium, Botrytis, and Pseudomonas, Bacillus, Microscus. And again, the GC mass analysis confirmed that the crude extract showed produces a unique mixture of the oleic acid, that is a 57 to 40%, followed by the hexadecanoic acid, then octadecanoic acid, and palmitic acid. So like that, it has a mixture of compound, and that is maybe synergizing the activity to enhance the activity against the certain pathogen. So just to conclude, I would like to say that the several reports state that biological fumigation by volatile producing fungi can be used as an alternative strategy to control the several post-harvest field as well as storage pathogen. Here I have put it 3 important differences, which is a very success story in the United States. People have used this biofumigation of the using the fungus, and the terminology was introduced, say, instead of biofumigation, it is like a microfumigation, and it very much working against the Botrytis cinerea, that is gray mold post-harvest disease of the table grapes. So like that, we can also keep our eyes and open, and maybe sometimes we ignore that the potential of the fungi, we don't screen them or we don't use them, that many unconventional fungi can be very fruitful as far as the application is concerned. So positive result of this preliminary study confirm that the concerted efforts are required to explore the metabolic potential of many unconventional or conidial fungi for their application in controlling post-harvest losses in various cereals, fruits, and vegetables. The potential of mixture of oleic acid and other fatty acids produced by this fungus requires to be checked against for the post-harvest field as well as in its storage pathogen. Thank you so much. This is my brief presentation, and we thought that let us have a unconventional thinking also, where we can use these fungi and their potential. So we are still working on these some major other plant pathogen, panel of plant pathogen, pathogenic bacteria as well as fungi, and most probably will shout out where the major potential it is showing, the result it is showing, then we will narrow down to our study to develop a particular maybe technology towards a particular post-harvest pathogen. Thank you so much.
Thank you, Sanjay. Nice presentation, and you are briefed very well on the storage mold treatment with the biological fumigation. Of course, it is an advanced technology, definitely, to forgo the conventional technology of seed treatment with biologicals.
Yeah.
We are looking for, because we know that, as you also know, that in the coming days, we are going to ban the number of chemicals. There is no alternate to treat the seed.
Right, sir.
We have to go for biological strategies and the new technologies. So, audience, do you have any queries or suggestions to Sanjay?
Yes, sir. Sir, here I would like to just give that idea that the one fungus, it belongs to a Gylleriaceae. It is called as Muscadar albus. So heavily it is being used, and most of the major university in the United States and people are using as a microfumigant. And it is fantastically working in the storage condition as well as field condition, and also sometimes they are using as an alternative of the agrochemical like a methyl bromide. So it is in the field condition also it is working.
But now, see, my concern is that the storage modes, especially Sanjay,
the
area one should concentrate is that these toxin-producing organisms.
Yes.
Because all storage fungi will not produce toxins.
Correct.
So the very particular attempt should be a toxin-producing storage molds, or the storage organisms should be targeted.
Yeah.
Hello, Dr. S.K. Singh.
Yes, sir.
Yes, sir. Professor
Good
Chari.
afternoon, sir.
Sir, first of all, I would like to welcome for this session and good afternoon, sir.
Thank you. Good afternoon, Dr. Singh.
Yes, sir.
I'm very happy that you are presenting your paper under Dr. Singh and as well as under Professor Niranjana's chairmanship.
Yes, sir.
Now, this is the fungus,
Yeah.
which is a common saprophyte, is it not?
Yes, sir. It belongs to Catrothriaceae.
What is the perfect? Do you have any perfect stage?
No, only the imperfect state. That is the beauty, sir.
Second thing is, do you want to say that this can be used as a for a biofumigant production?
Yes, because sir, that is for the GC analysis when we did that. So it is producing all fatty acids, sir. There is not even a single compound where we can just raise our finger about the toxicity.
Is there any post-harvest laboratory which has seen or which has witnessed this as a biofumigant? Has anybody reported this as a biofumigant?
Fumigation, yes, sir. Biofumigant, it is reported from many other fungi, but not from this particular fungus.
And then, because of your profile, you are saying that it can be used as a biofumigant.
Yeah, but again, we are still working, sir. Some different panel of fungi and bacteria. We want to screen as many as fungi and bacteria, so that we'll have a holistic picture. That.
Okay, good. Okay, congrats. And thank you, Professor Niranjana, sir. Good luck to you and Dr. Singh. Okay, thank you.
Thank you very much, sir. Thanks for your login for our session and giving some suggestions. Thank you very much, sir.
Thank you, sir.
Thank you so much, sir.
Thank you.
So, if no other question, once again, say thanks, Sanjay.
Yes,
so
sir.
On behalf of the
Welcome, sir.
Organizers and on my behalf, on behalf of my KP Singh, good friend, and we are thanking for you for a nice lecture. Thank you very much.
Thank you, sir.
Okay, thank you, sir.
So next presentation is Oksana.
Yes, I'm here. Yes, I'm here.
Very good.
Yes, here.
I welcome Oksana Lastikina. So I welcome you for this particular seminar and this session.
Thank you very much.
How are you? Are you fine?
Yes, I'm fine. Can I show my...
Yeah, please. I will introduce you. Wait 1 minute. 1 minute. I will introduce you. Then you can start. Oksana.
Okay.
Oksana Lastikina is a Bashkir. She is working in Bashkir Research Institute of Agriculture, UPA Federal Research Center of Russian Academy of Science, UPA in Russia. And she is head of the Laboratory of Molecular Mechanism of Plant Stress Resistance of the Institute of Biochemistry and Genetics of the Russian Academy of Sciences, Russia. In 2011, she received her PhD degree in the same institute. Her research area includes plant stress physiology and biochemistry, natural growth regulators, and PGPB, Bacillus subtilis, salicylic acid, jasmonic acid, induced plant stress resistance. The current work is focused on the physiobiochemical and molecular mechanism of plant microbe interaction under biotic and abiotic stress. Oksana is going to deliver the invited lecture on the topic Endobacteria Bacillus subtilis as a biotic strategy to post-harvest disease of potato.
Okay.
Oksana, we are very happy to listen to your lecture. Now it is over to you, please.
Okay, is it my screen is visible?
Yeah.
Okay.
Good afternoon, dear organizers, all presenters and participants of the conference. My name is Oksana Lastikina. Currently, I work at the Institute of Biochemistry and Genetics of the Russian Academy of Sciences, UFA, Russia. Today, the title of my talk is Endobacteria Bacillus subtilis, Biotic strategy to cope with post-harvest diseases of potato.
Please, can you share slides?
Sorry, I don't understand.
Slides are not shared, madam.
No, she's telling your slides are not clear and not moving.
We are not able to see it, madam.
Yeah,
I
yeah.
think you have to go one step ahead.
Now it's okay.
Now it's okay?
Yeah.
No.
Okay, let's continue.
Potato is a valuable food crop with great importance in ensuring food security worldwide. Potatoes provide an excellent source of nutrients and vitamins. One of the acutest problems of agriculture and the food industry is the loss of potato tubers from post-harvest diseases, which determines the urgency of soil.
I think
your slide, you have to click your file first in the computer.
Oh, sorry, some problem. Yes.
Click your file. Yeah, please
your
click your file.
PowerPoint slide is not visible. You
No,
just
not visible. See, not clicked or PowerPoint. Your file is you click which file?
you open the PowerPoint slide.
Open the PowerPoint slide first.
It means that you can see my video presentation, yes?
No, only we can see your desktop.
Only you can see your desktop.
Not the presentation.
Okay.
Open your presentation in your desktop.
Okay, can I use another file? Probably this one.
Wait.
I should continue or start from the first page?
You open the file, PowerPoint file, and share the file. There is a share option.
Oh, I don't know how I can do this. Sorry.
But I cannot.
You please double click on that. Please. Double click on that presentation which you are going to open.
Yeah. He's right. You double click on the file on your desk. Double click.
On that file.
You made double click.
Yes, on that you can click, ma'am. Double click on that.
Here. Is it okay?
No.
Good afternoon.
No, not
Okay.
Potato is a valuable food crop with great importance in ensuring food security worldwide. Potatoes provide an excellent source of nutrients and vitamins.
But also you are seeing your slides in your system?
Oh, sorry. I think I have a problem. Can I send you my pre-recorded video presentation and probably you will open it?
I think you can send it to organizers. They can open.
Okay. Okay, let's do.
Because we cannot see your slides.
Okay.
You send the file to you can send the files.
Okay, can I send it on chat?
I think what you should do.
Can you see your PowerPoint presentation on your screen?
Yes, I see.
Okay, so below screen there is a sharing option. Share the presentation. You just click on that.
Oh.
No.
First of all, now open the folder or file. Then after you can share it. Yes.
Yeah.
Oh.
Again you try. Please.
Okay, try it again.
Wait. Click and wait.
It's okay?
Once again you click click on the PowerPoint. Click it once again.
It's PowerPoint.
Again you click on the PowerPoint.
Click on it, please.
Okay, I don't know how I can do this.
Yes, double click.
Double click, okay.
Yeah.
Wait. Don't do anything. Wait. Please, too many slides are there. It is taking time to open. Wait.
I don't know how. I'm sorry. Sorry, can I ask help from my friend? Probably he
can. To help you?
Yes, sorry.
You ask somebody, please. You ask somebody. Dr. K.P. Singh is this online seminar. This is a routine. Sometimes system will not help and it will not support, open. These are all things are common in online presentation.
Technical support.
Yeah. Please take it easy.
Okay.
Take it easy and ask somebody to help.
Yes.
Вот, это... Вот, я его открываю, мне не видит. Я то же самое делаю. Can you see?
No.
No?
No.
Поделиться, они говорят, надо. Я не умею этого делать. Может, вот тут это вот эта стрелка, нет?
Hello, sir. Hello, Niranjan, sir. Hello.
Вот она. Ой, я не знаю, как делать. Maybe next presentation.
Madam, can you just click on share button?
I don't know how I can do this.
Ma'am, at first you open your PPT.
Hello.
At first you open your PPT.
Just click on the share button and select your PPT.
At first you open your PPT on desktop, then you come on share button. After that you can present.
Oh, I'm so sorry. I have problem. Probably next speaker will continue and I will send to organizers my pre-recorded video presentation. Is it okay?
Yes.
Okay, thank you very much.
Okay.
I'm very sorry.
Dr. Niranjana, now next speaker is the Tolioli Yukia. Tolioli Yukia.
Yukia. Department of Botany is there?
I'm here.
They apply. I welcome Yukia for this particular session. He is from Department of Botany, Faculty of Science and Faculty of Science, Lagos State University, Ojo, Nigeria. So he is going to speak on the biocontrol, a panicky for management of diseases in horticulture crops. So very small introduction for Luki. He has been a university lecturer and researcher at the Department of Botany, Faculty of Science, Lagos State University, Nigeria since 2007. He is having a PhD from University of Ibadan, Nigeria. His research interest includes plant pathogen, host interactions, biological control of plant pathogens, and using botanicals, control management of pathogens and diseases using botanicals and antagonistic microorganisms. And also he is specialist in post-harvest pathology and environmental mycology. He belongs to various professional organizations of Nigeria, Nigerian Society for Plant Protection, Phytopathological Society of Nigeria, and Nigerian Conservation Foundation. He has published in reputable journals, both locally and internationally, and has supervised about 50 undergraduate research projects. He hails from Oyo State, Nigeria, and Tulu is happily married to Kiki, and union is blessed with the children. Tilopi, I welcome on behalf of the organizers and on my behalf to deliver lecture. And now it is over to you, please.
Thank you very much. Thank you very much, you and the organizers of the program.
Yeah.
I appreciate you for inviting me to speak at this all-important conference.
Yeah.
It's an opportunity for me as a young scientist and researcher from a developing country like Nigeria to interact with eminent scholars and scientists all over the world. Thank you very much. So a number of persons have spoken on biological control, and my own topic too is on biological control as a panacea for management of diseases of horticultural crops, which are the focus of this conference. So according to the International Society for Horticultural Science, horticultural crops could include tree, bush, and perennial vine crops, perennial bush and tree nuts, a vegetable which can be roots, tuber, shoots, stem, leaves, fruit and flowers of edible and mainly annual plants. And horticultural crop could also be aromatic and medicinal foliage, seeds and roots and all that. It could also include trees, shrubs, tubs and ornamental grasses that are used for different activities for landscaping and for beautifying the environment. Some crops of interest that we have worked on in our laboratory over the years include apple, that's Malus domestica. We have worked on banana, we have worked on carrots, we have worked on tomato, we have worked on garlic, we have worked on guava, we have worked on Irish potato, on onion, on pawpaw, and some other crops. We all know the role that fungi play in plant diseases, because actually over 80% of plant diseases are caused by fungi, and almost all crops are attacked or affected by several species of fungi. Fungi destroy a third of all food crops annually, causing economical losses and impacting globally, causing poverty to some persons in the world. And the damage that fungi cause include killing the cells of the plant and causing stress to the plant. And fungi do this by invading the host tissues through natural openings like stomata, lentil cells. And so fungi invade intact plant surfaces by means of structures like a presorium. And we have some fungi that produce cell wall degrading enzymes by which they penetrate the intact surfaces of plants, thereby gaining entrance and colonizing the organism, or I mean the host, the plant. So some fungi that are involved in plant diseases that we have worked with over the years include Alternaria alternata, several species of Aspergillus. We have Botrytiploda or Lacidiploda triobome. We have Convularia species. We have several species of Fusarium. Notable among them is Fusarium osesporum. We have Sonula torulea. We have Mucus species, species of Nigrospora, Penicillium species, and Phytophthora species. So biological control has to do with reduction of inoculum. I hope you can hear me, please. Can you hear me, please?
Huh?
Can you hear me, please?
Yeah.
Okay.
Continue.
Okay. Thank you very much. Thank you very much. So biological control involves the reduction of inoculum density in the surrounding of or the reduction of inoculum density or the disease-producing activities of a pathogen or a parasite through manipulation of the environment, manipulation of the host, or by introducing one or more antagonistic organisms that can attack the pathogen and thereby prevent the further growth and development of the pathogen. Biological control agents possess a number of advantages over the traditional chemical pesticides. which make them to be commercially attractive. We know the problem of bioaccumulation of chemicals in the ecosystem over the time that is injurious to humans, to plants, and to the ecosystem generally. So the biological control is more preferable because they are non-hazardous to humans, to plants, and to animals, because they are biodegradable and because they are environmentally friendly. Biological control agents also, they attack the specific target organisms while leaving other beneficial organisms unaffected. This is not so for chemical control, whereas some organisms in the environment that are beneficial can be affected by the activities of these chemical pesticides. Fungi have received the most attention as antagonists, possibly because they are easier to handle and to identify than bacteria and some other organisms. Fungi have been used, there are several fungi actually have been used for biological control of plant disease, and these include the Glaucodium virens, Cladosporum oxysporum, and Pelomyces viscoalis. Several species of Trichoderma have been used among other organisms. Also, the use of botanicals, the use of plants in the control of biological control has also been established, and we have also done some work in this regard in our lab. Also, coating of fruits and vegetable crops with plant extracts instead of using chemicals, synthetic preservative, has also been shown to prolong the shelf life of crops, and hereby enhancing their post-harvest life. And the crops that we have used for this purpose include are not limited to orange, tangerine, banana, tomato, and other crops. This figure is showing Ampelomyces viscoalis, that is an antagonistic organism, which is an hyperparasite of powdery mildew fungi. And it is the organism colonizes the hyphae, the conidiophore, and the Cleistothecia. It does this directly by penetrating the pathogen, and the whole cell could be killed after shortly after pycnidia formation, 2 to 4 days after infection. The following plate shows rather some work that we have done in vitro for the control of using some species of Trichoderma, including Trichoderma longibacatum, Trichoderma viride, and Trichoderma asianum, in the control of some pathogens in vitro. For this case, we use Trichoderma species against Fusarium species and against Botrytidiploida theobrome. And the culturing was done simultaneously, pairing the antagonistic organism, that is the Trichoderma species. We paired simultaneously. We paired the antagonist before the pathogen, and we also tried using the pathogen, putting the pathogens on the plate before the antagonist. Plate 1 to 4 is showing the simultaneous pairing of the pathogens against the different species of Trichoderma, where plate 5 to 8 is showing the inoculation of the Trichoderma species before. We could see that there is a clear zone of inhibition, or there are clear zones of inhibition between the pathogen and the antagonist, showing that the antagonist was able to limit the further growth of the pathogen. And of course, this can be translated to the field or in vivo experiments. So the mechanisms employed by fungi in biological control include mycoparasitism, whereby one fungi parasitizes the other, antibiosis by secretion of certain enzymes by the antagonist to curtail the growth of the pathogen. And also we could see competition for space. Competition for space, the antagonist was able to grow faster than the pathogen, thereby taking over from the pathogen, as it were. Then the fungi also induce the resistance of the host against the pathogen. And in the experiment that we conducted there, we concluded that the inoculation of the antagonistic organism before the pathogen is more effective and more desirable, because the pathogen, the antagonist rather, is able to grow faster and colonize the available nutrients available, so to speak. I want to thank you for your attention. I thank you for your attention. Thank you for listening. Thank you very much.
Very good. Good presentations. Anybody is having any clarifications? Any questions?
No questions, sir.
Okay. Now see, Oksana is requesting through his request, the slides are ready. She is requesting in the chart. See, any slides she has sent to organizers? No. Oksana?
Did you receive? I shared.
I don't know that where, to whom you have sent.
Plant patho organizer.
Organizers. Dr. Singh?
Yes. Yes.
Dr. Singh is there? Dinesh? Who is the organizers present there in the head office? Nobody from the head office?
Sir, here we have received it, sir. I will share, sir.
Please share.
Sir, Niranjan, sir. Sir, can you proceed with next speaker, sir?
Oral
Because
now we have to go for oral papers.
Yeah, oral presentation. You can. Yeah.
It's too big file, sir. We are converting it.
You can go for oral papers or have to wait.
Oral presentation, sir.
Oral. So Oksana presentation is not in order.
Invited.
Sir,
I think she is not ready.
So she has sent a video file which is of 300 MB. It's taking time to convert to the normal MP4
Let me
files.
finish this oral presentation and we will give the opportunity for her and you just rectify the problems and we will come back after 3 presentation of oral. Okay. KP Singh, can we start oral presentation?
Yes, yes, yes,
Okay.
sir.
So
Yes.
now I will invite that Shahid Ahmad is there. Shahid Ahmad.
Saeed Ahmed.
I think he's not there.
Not. Yes, sir.
Gajanan.
Gajanan.
Sir, I'm there on behalf of Gajanan. Good afternoon, sir.
No, 1 minute, 1 minute. You are Gajanan on behalf of Gajanan.
Sir, I'm Dr. Shalini Gaur Rudra.
No. Ah, yes. Okay, okay. Yeah. You are presenting.
Yes, sir, I'm presenting.
Okay, fine. So, Shalini Gaur Rudra is from HIRI.
Yes, sir.
Food Science and Postharvest Technology Laboratory, New Delhi. And also
Yes, sir.
the authors are there and we will give a 5 to 7 minutes time for your oral presentation. So she is going to speak on anthracnose control in Sapota through some nanofers. Please go ahead.
Many thanks to the organizers and honorable speakers. I've had a very wonderful and knowledgeable section, and I hope to add something new to this. So anthracnose is a major disease in Sapota, and yeah, I'll not. I think due to paucity of time, we'll skip on the introduction. Just to highlight the importance of Sapota. Sapota is the sixth most important fruit of India, and India is the largest producer of Sapota in the world. So any post-harvest disorder is pretty tremendously impacting the industry and the horticulture in the horticultural status of India. So it is a very, very quick ripening fruit. It is shelf stable only for 3 to 5 days. And there is a tremendous, almost 1/3 or 1/4 loss is there in Sapota because of its quick ripening, as well as anthracnose disease, which is a major post-harvest disease. And especially where it is grown in areas where high relative humidity is there, and there anthracnose is bound to happen. So how to tackle about that? So conventional control was the use of fungicides, which are definitely not preferred now. Hot water drip treatment, which has been suggested earlier in the conference, is unsuitable because of its thin peel. So we cannot apply hot water drip treatment to it. So we need some alternative strategies. So one of the alternatives can be the use of essential oils. And the essential oils which are sourced from plants which are grown in the same agroclimatic zone as the fruits. That is going to lead to better and more economic adaptation of the technology on the ground. So that with this, in hindsight, this study was designed. So how to apply the essential oils? It can be applied by dipping, spraying, or nano emulsion coatings nowadays. And then there is another way in which we can do is we incorporate them in nanofibers, make nano mats, and then we put it in the packaging cartons or cardboards, and then that is when the essential oil vapors are going to be released in the package, they are going to control the pathogens which are going to grow. And however, essential oils are also pretty expensive, so we need to nano size its application, and so that it is much more effective. We know that nano sizing improves the effectiveness, and also it lowers the doses. So how can we form the nanofibers? These are the various ways, of which we chose the electrospinning technique. So electrospinning technique involves we are drawing the nanofibers in the form of solution or molten liquids, and then applying high voltage, and that forms sort of a mat which is deposited on an aluminium receptor. So the objectives of our studies was to, first of all, develop a tropical region origin essential oil based nanofibers. Then we characterize the physical and antimicrobial attributes of these nanofibers. And finally, we validated the developed nanofibers against the anthracnose causing pathogen in Sapota fruits when we kept them in the package. So the nanofibers application for Sapota are rare. In fact, in package nanofiber application, particularly for Sapota, it's been an ignored crop so far. And also the blends of essential oils. There are very, very few studies on use of blends of essential oil. So we used two crops, that is thyme and betel oil. Thyme essential oil and betel leaf essential oil, and we checked for the we found the effective dose 50, that is LD50 values in ppms for inactivation of Colletotrichum diosporoides. Here are the various inhibition graphs. That is at when these were blended at these thyme and betel, they were blended at 1:1. 1:3 and 3:1. So thereafter, the 1:1 level of blending was found to be most promising, and thereafter the nanofibers were spun, and these were made of polyvinyl alcohol with beta-cyclodextrin as a binder or as an encapsulating agent for essential oils. And these are the various nanofibers which were formed with various concentrations of thyme and betel leaf oil. So ENF3 is the one in which we have used 1:1 blend, and we are going to see at 200 ppm levels. So this is how the composite nanofiber looked like actually. So this is the same image of the nanofiber, nanomat, and this is the size distribution. That is, it was found to be ranging in between 200 to 300 nanometers, and therefore it was it was nano. So these essential oils, they were encapsulated in nanofibers, and we checked for the encapsulation capacity in terms of how much ppm was actually there in the polymer solution and how much actually got into the nanofibers finally. So this is a table showing that. And we did this work with the help of Agricultural Chemicals Division. So the oil loading capacity that was determined by this method. So now we come to the antimicrobial activity of the composite nanofiber films against anthracnose causing organism. And we then found whether it is having some interaction effect. For that, an Abbott index was applied to see whether the interaction is actually synergistic or antagonistic. And the interaction was found to be actually additive in nature. So this is the way Abbott index was calculated. So this is in this slide we are showing the inhibition zone diameter of the essential nano electrospun nanofiber 3 against the carbendazine 1000 ppm. And next comes the final testing of the composite nanofiber film. That is when the supporter fruits were packed in corrugated fiberboard boxes along with the patch of nanofibers. Then what happened? So this is the in vivo, these are the in vivo results. That is on the third day of inoculation. This was poison fruit technique was applied. That is, the spores were inoculated in the supporter. And the disease severity and incidence are indicating very clearly that compared to control in which there was a 100% disease incidence and disease severity was 86%, our ENF3 with 200 ppm of thyme and betel leaf oils, that was found to actually decrease the disease severity very, very effectively, and disease incidence also by reduce the disease incidence by 60% because of the presence of the vapors in the package. So this is how the supporter fruits look like. All these are inoculated with Coleotrichum, and then this is the effect of these the composite nanofiber films in the package. So with this, I would like to end my talk. Thank you very much.
Thank you. So, any questions? No. Now the last oral paper presentation by Eluru Mohan Babu is here. Thank you. Thank you, Shalini Gaur. Thank you very much.
Sir, excuse me, sir. I also having the oral presentation, sir. Sir, I'm Dr. Nagaraj. I also having the oral presentation, sir.
Nagaraj, but you have not printed paper here.
Yes, sir.
In oral paper presentation, your name is not printed.
Yes, sir. It is there, sir, in the program sheet, sir. It is there, sir, in the program sheet.
Where is that, sir? In the program, we have inherited paper. Oral papers, only 3 are printed in the program.
No, sir. Mine is there, sir, in the program. Total technical program sheet, it is there, sir.
It is there, sir, on number 5.
Number 5, sir, in the oral presentation.
Some post-harvest diseases of grapes and their control in Telangana.
Yes.
Okay, Nagaraju, no?
Is not there KP Singh do it to you?
Yes, Doctor.
Then you just ask him to present. How many are there then? In my print, I think only 3 is there. How many are there still?
Hello, sir. Hello.
Hello.
Sir, my name is also there. I will also present on microgreen.
KP Singh, do you have a list with you now?
Sanmay Kumar Kole. You see, it is there in 7 number. Oral
7 number. Yeah.
Sir, myself, Dr. Kumari Sunita, sir, 8th number.
7, 8.
Yes, ma'am. Kumari Sunita. Yes.
Yes, sir. Kumari Sunita, DDU Gorakhpur University.
Gorakhpur.
Yes, sir.
KP Singh, please go on announcing names and ask them to present. Because I don't have list, I have to print now again.
Okay, sir.
Please go ahead.
Yeah, okay. So, Mohan Babu, Eluru Mohan Babu is here.
No, he's not there.
Nagraju?
Yes, sir. I'm here, sir.
Ask
him. Okay, you can deliver, na? Please.
Yes.
Shall I, sir?
Yes, you can start it.
Yes, just a second.
Namaskar, sir.
Sir, I'm sharing my screen. Sir, I couldn't share the screen, sir. Please give me the. Sir, please do the.
Shalini madam, Shalini Gaur.
Ma'am, please permit us.
Yes, ma'am.
To share. Please permit me
Please
to share the screen.
you go out of that sharing these slides, madam.
Ma'am, how to do that?
Stop sharing in your this one Zoom meeting. Stop sharing option you give, madam.
Okay, let me just resume share.
Now you out of this one, but still you were.
I'll just leave once. Yeah, let me leave.
Please make me co-host, ma'am, so that I can.
Stop sharing option. It is there and.
Yeah, now it is done. Sorry, really sorry.
Nagraj sir.
Ma'am.
Nagraj.
Ma'am, okay.
Nagraj.
Sir, I'm opening my presentation, please, sir. Sir, it is opening, sir, please.
Nagraju? Nagraju?
Vishna sir?
Yes.
If
Sir,
you
I'm
permit,
here.
then can I present? Okay.
Sir.
Just 1 minute.
Sir, I'm Dr. Nagaraju, sir. Sir,
you can present it.
Yeah, sir, I can present, sir. Now, sir. Screen. Yes. Yes, sir. Is it okay, sir, now?
Yes.
Yes, sir. In my system, it is not open. So I open in my mobile, sir. Okay, sir. No problem at all. I can.
Okay. You can present it here.
Yes, sir. Respected Chairman, sir, Sir Niranjan, sir, and presenter, respected delegates and presenters and lead speakers of this international e-conference of post-harvest diseases. Thank you for giving this opportunity to me. I am Dr. D. Nagaraju, Assistant Professor of Botany, Government City College, Hyderabad, Telangana State. I am the student of Professor C. Manoharachari, sir, Usmania University. This is my abstract. I presented some post-harvest disease of the grapes and their control from Telangana. Majorly, we all know grapes belong to family Vitaceae, are the most remunerable horticultural crop it is. Commercially very important. The major problem is post-harvest losses due to the fungal diseases or some of the bacterial diseases of prime importance, which reduce the quality and quantity of marketable fruits, leading the heavy losses as well as the consumers. In the present investigation, we carried out the survey isolation, pathogen responsible, and the pathogenicity, symptoms, and fungi, and whatever the organic compounds which are suggestible for the control measures as a bioagents. We all know, majorly Telangana, Andhra Pradesh, Maharashtra, Karnataka, majorly Thompson variety. Most in our India, 20 varieties of the grapes are cultivating, and majorly Thompson variety, Anayasabi, Bangalore blue varieties, and Thompson seedless. We are growing, occupying the 55% of the crop, and Bangalore blue is 15%. Anayasabi 15%. We all know very well about this. I think especially Anayasabi and Thompson seedless varieties. These are the seeds varieties of the grapes which are growing in these 4 states, about southern states. Thompson seedless, Dilkush, and Bangalore blue, Anayasabi, and berries like the Gulabi. And in our Telangana, sorry. Telangana is the 7th most state in the production of the grapes. In the productivity, it is the top first state. In the Telangana government, Horticulture University is providing the incentives, and we all know having the nutrient packs, having the more the nutrients, minerals and nutrients, it all are there. And the shelf life of the grapes are very less, we all know, and barely because of the growth of the fungi, because of the cleanliness. If it is not then cleanliness, if it is any decay and desiccations, that is due to the fungi or either bacteria. Harvesting the overripe grapes may, due to hot hours, may cause, and the careless handling, that all. You all know these all are under the optimum conditions. Anab Asabi variety is in 40 days, Muscat 45 days, and Thompson seedless 30 to 60 days in ideal storage. These are the post-harvest diseases of grapes we observed in these areas: anthracnose and botrytis bunch top, and blue mold rots, and rhizopus rots, and black mold rots, and green mold. Botrytis bunch rots, black mold rots, and bacterial Granaria bitter rot, and black rots. These are the major post-harvest diseases that are the main problem in the grape cultivation. These all are very simple. In our storage conditions, majorly these gray molds, we observe bitter rot in the Graminia, and botrytis rots by the botrytis cinerea, and black rot by Aspergillus. With these all fungus we isolated, identified, and the rhizopus rot, and the gray molds, and ripe rots by the Coltotrichum, and black lesion, and some of the bunch rot diseases caused by so many fungus, Aspergillus, Saltaneria, botrytis, Cladosporium, and the black rot by the bacteria Gangliaria. And isolation, we have done the isolation of the pathogens, and samples, rodent samples are collected from the markets and vineyards, local markets, and pathogens are isolated, and we apply the essential oils, especially highly medicinal values plants on her herbal doctor, neem plants, Azadirachta indica, extract and castor oil, castor extract and cloves were sterilized and applied on that grapes. And also neem extracts, neem leaf and castor leaf extracts also we prepared and applied on it. We have done the pathogenicity test with the following the coast postulates. We studied the pathogenicity with the fresh and inoculated and natural diseased varieties of the grape. We while applying that the oils, the majorly neem oil, by applying there is a less pathogenicity, less loss occur. The very highly valued, highly suggested the neem oil having the highly control capacity, especially we have done on the aspergillus pathogenicity and aspergillus, and we have done, the plant products studied in this context, neem, castor oil, and marigold. Various extract of leak neem oil and the grapefruit reported high. This extract has best retaining the biochemical context, and they are being used the manufacture natural associates. So in this my study, neem extract and castor extract, oil dipping on oil also, spraying oil also, is controlling the post-harvest diseases, the biochemical and whatever the agrochemicals and natural ingredients that are very useful to prevent the post-harvest diseases, to increase the amount, increase the productivity, increase the value, increase the net value of this grapes. Thank you very much. Thank you for giving this opportunity.
Okay, thank you, Nagaraju. Now it is open for discussion.
I think, sir. Or
ఓకే అంటారా? ఏమండి?
Hello, sir. Hello, sir.
Okay. Now next one is the
Sir, please unmute yourself. KP Singh sir, unmute कीजिए अपने आप.
Okay.
Sir, please unmute yourself.
Hello. So shall I start? Good afternoon, respected chairman and the session, Dr. KP Singh sir, and all other dignitaries. Today I am going to present oral presentation on prevention of spoilage and maintenance of food safety of microgreen. Basically, first it is one new kind of food product, that is microgreen. What is this? It's a young seedling made from vegetables, herbs, some cereals like that wheat green. So they are harvested at very young stage, like 7 to 14 days, and they are why they are have demand, because they are high nutrition, intense flavor, color, and tender texture. So if we look here, we can understand what is the microgreen. Microgreen is this kind of crops which have one stem, 2 cotyledon leaves, and if it is monocot, so 1 leaves, and 2 leaves, two leaves is 1 or 2. So this is the main concept of microgreen, and mostly this concept comes in our foreign culture because of their high nutrition. So if we look first briefly, we can tell what is the importance of microgreen, because many of the studies they found that these microgreens are very richer source of vitamin K, vitamin E, particularly women who are looking for synthetic vitamin E. For them, microgreens, particularly from cruciferous microgreens, are very healthy. They can use their daily diet, so they can take vitamin E from these crops. And similarly, they have found that microgreen are some minerals is very more, and like that calcium, and sometimes they are less amount of contaminant like nitrate and other things. So this is the reason many of the microgreens, they are very rich in antioxidant like here betalains, anthocyanins, carotenoids, and they prevent from various health related disease. So nowadays this is a very growing industry. Microgreen now are coming to Delhi also, Mumbai. There are many microgreens are going in the market, but the producer are now facing some of the problem related to post-harvest pathogen. So one is that mold growth is very much common in microgreen. So people sometimes very confused with whether it is a root hair or molds, but this picture gives clear definition, discussion that how it looks, so you can understand. Now what is the why it is important, because during my practical experiment I have seen that because it is a only 7 to 18 days crops, very short period crops, and because of that you can't go for chemical treatment. For this reason, the media should be very good. Otherwise, if you use contaminated media, so damping off will be very much common in microgreen. And if you not take care of damping off during the production time, when you go from harvested produce go to consumer, in the hand of consumer, rotting is very common. Particularly it happen in damping off, not for other. We have observed this in alfalfa microgreen, and that's why we found that trichoderma as a bioagent for seed treatment is very good for spoilage prevention, particularly in all crops. Very limited research is have done. We have also studied, reviewed many literature, but only one literature we found that that Bacillus subtilis, Bacillus, and some Trichoderma hergianum, these they are used this as prevention of damping off, and they found that this biofungicide reduce this problem. But problem is that here they reduce the biomass concentration. So this probably will be a new emerging area of research, that whether we can use this biofungicide for prevention of spoilage. But most important is the risk in this crop is that occurrence of various hazardous disease, which can be, although it is a directly not linked to this session, this conference, but it is very important for microgreen post-harvest physiology, because microgreen, when we harvest, it causes tissue damage. Then hand harvest is very common. As a result, there may be contamination, and because of very high dense nutrition in microgreens, it causes very easily suffer from spoilage. So food safety is a major issue, and nowadays many foreign countries, they recall their product, because unlike our system, foreign they have recall system, and if they found that some microgreen have contained some specific pathogen, they recall the entire product, and it happened for radish microgreen and alfalfa microgreen. This is very much common in some advanced countries. Now this is Canada. This happened in Canada, even mostly Canada and USA. And one thing is that because they are very cool climate, Listeria monocytogenes occurrence is very much common there. So during this type of product, we have to very careful, and many factors like media, seed, irrigation, water, they affect. And in general, our research team, we generally assure that media should be very much sterile, and post-harvest factor, mostly in foreign country, it is very important for post-harvest person that they are use the person hygiene who directly involved in harvesting and post-harvest operation. But in our country, we don't bother these things. So we must take care of these things. So the people who involved in harvesting, they should be very healthy, and otherwise they can contaminate the produce, and it contamination goes to next food chain. So one thing important, that irrigation water, whether water is very good or not, there are many water where there are reports that norovirus, salmonella, E. coli easily contaminated with municipal water, and they can go directly to the problem of these microbes. Similarly, seed contamination is important. Chemical versus physical means sometimes chlorinated water is used, but some people believe that post-harvest sanitation also important about that chlorine wash, but chlorine wash didn't give the good result. Some water quality, sanitation of the harvest tool, and worker hygiene, all these things we should take care of that. Here it is very interesting to see one of the research paper, they told that the rough seed surface is the harbor of many pathogen, where the smooth seed like sunflower, that they are very good for easily, they are not susceptible for carrying the various pathogens. So this seed surface is also important. So here I want to convey that microgreen, one of the new emerging crop in our metropolitan city. Already Mumbai, they have started their this kind of product are coming, but there is a two problems. Sometimes because of very high dense nutrition, they faces the spoilage, but sometimes they are main threat to that safety aspect. Although our Indian stomach is very strong, we can digest, but remember microgreen generally they consumed as fresh. So if we use this fresh, we may suffer from some of the problem. So we must take care of. Very limited research have been done because very new subject, very limited. I got very limited information. We are working here in Patna. We are not. We are still working various issues. So this is the totally of this my presentation. Future lot of things are waiting for us. So we can present in next any other seminar. Thank you.
Okay, thank you, Tanmay.
Thank you, sir.
Now it is open for discussion. Any questions from the delegate sides? Tanmay?
Yes, sir.
You have described in detail about the microgreen.
Yes, sir.
Now potential contamination. Now you have mentioned the several things like mustard, radish, kala, for use as a microgreen. So it is more effective. But now you comparison with the fungicides?
Sir, actually,
as a protectant or standard check you have taken as a fungicides?
Sir, we have not generally recommend because one thing, because it is very short shelf life, production life, only 7 to 14 days. So if we give some any fungicide or anything, so yeah, we cannot avoid this safe period. So for this reason, we generally can't take any chemicals as a safety aspect. So that's why we generally prefer for trichoderma and others that biocontrol agent.
Yes, yes. Okay, thank you, Tanmay.
Thank you,
Next
sir.
one is the Sunita Kumari.
Yes, sir. Kumari Sunita, sir.
Yeah.
Thank you, sir. Sir, shall I share my screen, sir?
Okay.
क्यों नहीं हो रहा? शेयर क्यों नहीं हो रहा है ये स्क्रीन? किया तो है, क्यों नहीं शेयर हो रहा? आ रहा है? Sir, my screen is visible, sir.
No.
My screen is visible, sir.
Madam, you are sharing your Zoom screen. Kindly share your PPT screen, madam.
Yes, my screen is visible now.
Yes.
Okay.
Now it's visible, madam.
Good evening, each and
Kindly go to
everyone
the
present in this.
presentation mode.
Excuse me.
Slideshow mode, madam.
Okay. Presentation mode नहीं जा रहे हो? अच्छा आ गया.
Thank you.
Okay. Good evening, each and everyone present in this literacy evening. Chairperson Dr. U.S. Singh sir, Dr. S.R. Niranjana sir, Dr. K.P. Singh sir, and reporter Dr. Sanjeev Kumar and Dr. Shrikant sir. Myself, Dr. Kumari Sunita, Faculty of Botany, DDU Gorakhpur University. I am going to present my topic post-harvest management of tomato. Last but not the least, I am very thankful to organizer for giving me this opportunity to present my work. Tomato is the most popular garden and the world's second most consumed vegetable after potato. And it is believed that tomato is originated from South Africa and South America. In India, it is an introduced crop and is being grown on an area of 0.458 million hectares with an annual production of 7.277 million tons. And in Uttar Pradesh, average area under tomato for last 5 years in 10.6 thousand hectare with average annual production of 540.67 thousand metric tons. Tomato is one of the most widely cultivated and extensively consumed horticultural crop globally. Although the crop is believed to have been originated from the wild in Peru, and then the tomato contain higher amount of lycopene and type of carotenoids with antioxidant property, which is beneficial in reducing the incidence of some chronic disease like cancer. Fresh fruit and vegetables, including tomatoes, are projected to have post-harvest losses of 5 to 25% in developed countries and 20 to 50% in developing countries. Fruits and vegetables losses in developed countries vary from 20 to 50% during post-harvest cycle. Acceleration of deterioration can be due to high temperature, low humidity, incorrect atmosphere, and physical damage in transportation processes as well as in storage. After production management, collection, storage, packaging, transport, and marketing are part of the post-harvest activities, and tomato has limited marketability because of its high moisture content and a high degree of perishability that leads to extensive post-harvest losses. In this slide, we can see that the world largest tomato producing country is China, and India is the second most largest country. And despite of the high nutritional value, tomato is susceptible to many diseases and post-harvest disease destroy 10 to 30% of the total yield of crop during handling, transportation, storage, and marketing. Some of the diseases are gray mold disease, which is caused by botrytis cinerea, and gray mold cause post-harvest rot at harvest and in storage and can cause a variety of other diseases, include damping off and blight. Symptoms: watery lessons area with a light brown central region which contain dark brown spot. Fruit rot takes place with disease area being whitish. The production of halos known as ghost spot, also occurs on green tomato fruit. Optimum relative humidity for spore production of that fungus is 90%, and spore are produced during the night when the temperature is lower and the relative humidity is higher than during the day. The temperature is 17 to 23% degree is required, and the botrytis produces sclerosia which survive in soil, dead plant material or a different host plant. In greenhouse, we should maintain RH of less than 80% during the night, and the pre-harvest spray 0.25% captain at monthly interval can control this disease. Now, second one is early blight of tomato. It is caused by Alternaria solanae. Initial symptoms on leaves appear as a small 1 to 2 mm black or brown lessons, and under conducive environmental conditions, the lessons will enlarge and are often surrounded by a yellow halo. Lessons greater than 10 mm in diameter often have dark pigmented concentric ring. This is called blushy type lessons, is highly characteristic of early blight. As lessons expand and new lessons develop, entire leaves may turn chlorotic. Defoliation and lessons occur on stems are often sunken and lancet and light center and have a typical concentric ring. On young stem seedling, lessons may completely girdle the stem, and the phase of disease known as collar rot, which may lead to reduced plant vigor or death. Maximum dispersal of the conidia between 9 am to 12 noon, and the plant suffering from water stress also susceptible for this disease. And the control of the disease can be done by seed treatment by the Thyram 3 spray with defoliation 0.2% at 4 nightly interval. Crop rotation with non-solanaceous crop is one of the most important measures for the control of the that disease. Next one is anthracnose, which is caused by Coleotrichum gliosporioides, one of the most common fruit rot of tomato, which is caused by Coleotrichum. And the infected tip tomato has a small water-soaked sunken and circular lesion, and the small water-soaked circular and depressed spot enlarged to greater than 12 mm in diameter, which is found on the zonal margin. Lesson surface may appear salmon colored due to spore production and be dotted with black specks, which is called as microsclerotia, and which occur mostly in open field and pack houses. And the favorable condition for that the occurrence of the disease is 28 to 32 degrees centigrade, and relative humidity is 85 to 100%. And we can control this disease with the help of the crop rotation, hot water treatment, and hot water treatment at 50 degrees centigrade for 25 minutes. And next one is Foma rot disease. It is caused by Foma destructiva. Leaf spot start at dark brown to black areas that are slightly sunken and irregular in shape that develop concentric ring over time, and a small black pycnidia is produced. Both green and ripe fruit can develop sunken black leathery lessons with numerous black pycnidia in the center, and the moderate temperature and high humidity most rapid decay on the ripe fruit around 21 degrees centigrade. And we can control this disease with the help of the seed certified to Foma free and seed treatment with the Seracin dust, 5% ethyl mercury phosphate, and we should avoid injury fruit during harvest. Also control contamination in packing process. 5% borax solution containing 0.5% liquid tar soaps as washing medium. Seed-borne disease, it is a seed-borne disease, and progress of pathogen is more in ripe than in green fruits. Next one is Rhizopus rot, which is caused by Rhizopus stoloni fur, and the symptom is water-soaked lessons which exude liquid. Lesson surface may be covered with within cotton-like fungal structure. Tissue within the lessons are usually held together by relatively coarse strand of fungal hyphae, and dark sporulation may crown the white tuft of Rhizopus. Now, post-harvest loss is a major challenges hampering tomatoes production in most developing countries. So we should have to use appropriate post-handling practices and treatment method like harvesting, pre-cooling, cleaning and disinfecting, sorting and grading, packaging, transportation and storage. In harvesting process, the physiological maturity of any fruit at harvest has an important effect on post-harvest quality of tomato. Therefore, care must be taken as to when to harvest the fruit in order to attain the best quality. And the harvesting of tomato in matured green state will only give producers ample time to prepare the fruit for the market, but also prevent mechanical injury during harvesting. Pre-cooling after harvesting. High temperature field is usually high and undesirable at harvesting stage of many fruits and vegetables and should move as quickly as possible before any post-harvest handling activities. Pre-cooling minimizes the effect of microbial activity, metabolic activity, respiration rate, and ethylene production. A cheap but effective way of pre-cooling harvested tomato for producers of developing country can be by dipping fruit in cold water mixed with disinfectants such as thiabendazole and sodium hypochlorite if availability of clean water is not a challenge. Now, sorting and grading. Sorting is the removal of rotten, damaged, diseased fruit from the healthy and clean one. The damaged or diseased fruit can produce ethylene in substantial amount, which can affect the adjacent fruit. Grading is also the process of categorizing fruits and vegetables on the basis of color, size, stage of maturity, or degree of ripening. Grading on the basis of color or maturity stage will help eliminate ripe fruits which will easily produce ethylene to hasten the ripening process in the whole batch. Now, packaging as a post-harvest handling practices in tomato production is essential in putting the produce into sizable portion for each handling. However, using unsuitable packaging can cause fruit damage resulting in losses. Some packaging material used in most developing countries include wooden crates and cardboard boxes, baskets, and plastic crates. Now, refrigeration storage is one of the most effective method of preserving the quality of many fruits and vegetables for several days, and low temperature storage can protect non-appearance quality attributes like texture, nutrition, aroma, and flavor in many harvested fruits. Tomato handlers have also used refrigeration storage for tomatoes in attempt to extend shelf life. Now, modified atmosphere packaging. Modified atmosphere packaging refer to a packaging technique of using a specialized material in packaging product in a predetermined composition of gases, which are mainly oxygen and carbon dioxide, after which there is no active effort of modifying the storage space. A simple and cost-effective way of using calcium chloride is by adding the required dosage of the salt in water used for pre-cooling or cleaning of the fruits after harvest of them. Chloride, calcium chloride is a very cheap and soluble salt which can dissolve into any concentration for use by producers. Conclusion. This study highlights the consequences of the selected post-harvest fungal disease on tomato fruit production. A higher incidence of most of disease occurred when tomatoes are improperly handled and in addition being exposed at optimum temperature that will further initiate. Post-harvest handling practices like harvesting, pre-cooling, cleaning, or disinfecting, sorting, and grading, packaging, storage, and transporting played an important role in maintaining quality and extending shelf life of the tomato fruits after harvest. The use of appropriate post-harvest treatment method like refrigeration post-harvest heat treatment and modified atmosphere packaging was also vital, and it is concluded by the study that the quality of the harvested fruit can be maintained shelf-life using appropriate treatment method until this simple post-harvest procedure challenge. Okay, thank you so much. Okay. I have completed my slide. I have
Okay, thank you, Sunita. Thank you, Sunita.
तो फिर क्यों नहीं बोल? Niranjana sir, I have presented. Thank.
Okay, thank
Thank
you,
you, sir.
Sunita. Now, wonderful lectures. Any questions from the audience? Any questions from the audience?
Thank you, sir. Sir, it's really too late. I was waiting from 1:30, sir. Really, it's too late. But thank you so much, sir, for completing the session on time, sir. Thank you.
Wonderful lectures. Now it's now next one. Hello. Next is the Grish Chandra. Grish Chandra. Grish Chandra is here. Grish Chandra. Grish Chandra. Yeah, Grish Chandra. Hello. Grish Chandra. Grish Chandra.
A little voice is coming actually.
No voice. Hello.
He's speaking, but his voice is too low.
Hello, sir.
Hello, sir. I'm admin, sir.
Hello.
I'm admin, sir. I'm admin.
Hello, sir.
It's pretty low.
Sir.
Yes.
I can see a slide.
Hello.
Grish Chandra.
Yes, you can.
Hello.
Sir, he's speaking, sir.
But not.
Hello.
Hello. Yes.
Sir, myself, Dr. Shumaila Shahid. Sir, I just
Yes.
want to know when will be my presentation. Actually, I'm in traveling, so I just want to know.
So are you interested to
Yes.
deliver lecture?
Yes, sir. I can. Mine is oral presentation. I can give right now, if you
Your
allow.
name, I think your name was not included in this session.
No, it is included in 3B. Actually, today only it has come to my mail. Mine is on 9th number.
9th.
This is a not a 3D. Nah, this is not a 3D. This is 3B.
3B. Yes, I am talking about 3B only.
No.
This is 3B. B for banana.
Yes, I know 3B. That is what I am saying. 3B. B for banana. Actually, mine is on 9th number. It is included yesterday only. That is why maybe you are not having any information about it.
Okay.
So
If
can
you
I
are
present right
interested,
now?
okay. If you are interested, then you can deliver the lecture.
Oh, okay, sir. I'll just present my oral presentation. Just a second. Can you see my slides?
Yes.
Okay.
Shumalia.
So my good evening, everybody. Myself, Dr. Shumaila Shahid, Scientist, Division of Plant Pathology, IRI, New Delhi, and I'm going to deliver my oral presentation on the topic biomanagement of Fusarium wilt of cucurbits caused by Fusarium oxysporum. So, first of all, introduction. Cucurbits are important global vegetable crops whose production can be severely hindered by the wilt pathogen, that is Fusarium oxysporum. And the symptoms include necrotic lesions and vascular and root wilt that ultimately led to death of the plant. So this Fusarium oxysporum is basically host specific, and it has forma specialis. And it has reported to be one of the most destructive diseases in cucurbit production in India and worldwide, especially in muskmelon, cucumber, and bitter gourd. So, in order to prevent and just the damages caused by this Fusarium wilt pathogen, there are several practices which are being followed. Chemical as well as non-chemical, both practices are being followed. But since non-chemical practices are encouraged over the large use of pesticides and chemicals, in this respect, biological control using antagonistic microorganisms offers eco-friendly, economic, and ecologically viable approach towards disease control. So the trichoderma species, especially these are trichoderma species as biocontrol agents have been investigated against several plant pathogens and Fusarium wilt pathogen also. So my objectives are the objective which I have done here includes the survey, isolation, and characterization of isolates of Fusarium species infecting the cucurbits, that is muskmelon, cucumber, and bitter gourd from different locations. Virulence analysis of isolates of Fusarium species on muskmelon, cucumber, and bitter gourd. and the antifungal assays of the biocontrol isolates against the virulent fusarium isolates for developing the biocontrol consortium. So 30 isolates I have isolated from the muskmelon wilted plants from MM1 to MM30 from different districts of Haryana, Rajasthan, Uttar Pradesh, Uttarakhand, etc. And the species which I have found here includes so many species, not only Oxysporum, but I found Solani also, Palidorosium, and verticillites also. So the isolates, the isolates of fusarium which I have isolated from the cucumber plants were 10, that is CC1 to CC10, and similarly from bitter gourd I have isolated 12 isolates, that is from BG1 and to BG12. So these all total isolates I have isolated from different districts of India. I have done the characterization of these isolates. I have done the morphological characterization based on the these cultural characteristics, these morphological variability. I have characterized them accordingly into the different species, that is on the basis of the color, growth, shape, margin, as well as texture. Some were fast growing and some were slow growing. Similarly, the cucumber isolates, the 10 isolates which I have isolated from cucumber, that I have also done the morphological variability, and the 12 isolates of bitter gourd. In this also, I have done the morphological variability from the bitter gourd. So I have done the macroscopy of the fusarium species which I have isolated, showing the this picture shows the macro as well as microconidia as well as the phylites of the fusarium oxysporum as well as fusarium solani. We can differentiate it. So I have done the morphological the macroconidia as well as macroconidia I have studied, the length, breadth, as well as the separation I have studied, and the variation I have observed among the different isolates of muskmelon, cucumber, as well as the bitter gourd. So after the isolation
Somalia, your voice is not clear. Somalia. So, Somalia. Okay, now this is the last presentations of this session, chemical and non-chemical means of the plant disease control. Now actual meaning of this session is to reduce the yield loss caused by plant disease and attain the goal of sustainable agriculture development. I think you know about the approximately 20% of the crop production is lost to the disease at the pre-harvest stage alone, and those at the post-harvest stage are still higher. So as a plant pathologist, we can be proud that we have developed a number of the plant disease management strategy that has helped us to reduce the plant disease. But we have a lot more to achieve. Now, in this session, number of the papers now grouped into the chemical, non-chemical measures, and the non-chemical means include all use of the cultural practices, botanical biocontrol agent to reduce the disease of below the ETL. So in present scenario, the farmer mostly resort to the chemical means of the plant disease management as they are easier to adopt and give quick result as compared to the non-chemical means. So nowadays, now new generation fungicides are comparatively safe to non-target organism and environment. They still face many drawbacks like the predecessors, but challenges to the present day plant pathologist is to be develop equally efficient non-chemical means of the plant disease management and to popularize it among the farmers. Now, in this sessions, number of the papers now presented near about 15 papers now presented in this sessions. Out of these, now one of the Dr. Pratibha Sharma, renowned pathologist, now presented the lead lectures, and now 5 persons or scientists now presented the invited papers, and 9 papers now presented in oral sessions. So that in my sessions now only one problem now receive one of the Uksana now face some of the problems, otherwise now 1 or 2 member is not here, so that now it is good presentations, and overall thanks for all. Now end of the session. Okay, thank you very much.
Thank you, sir.
Okay, thank you.
I would like to thank.
Yes, you can. Yeah.
Viewers. I would like to thank chairperson of this session, Dr. S.R. Niranjan, for nice leading of the session, and convener of the session, KP Singh sir. Actually, very nicely he reviewed all the presentation. Thank you, sir, for nice review and nice carryover of this session. And I thank all the presenter who has presented very nicely of your research, and participants for your patient hearing until this late evening. Thank you, sir. Thank you, one and all.
I'm thankful to Dr. Niranjana. Now he spared times for this session. Okay, thank you very much.
Thank you.
Okay, thanks.
For tomorrow sessions, link is being shared at the chat box. Please kindly follow it. Thank you.
Jayashree. Hello, Jayashree.
Yes, sir. Yes, sir.
Sir.
Any report here in this session?
Sir, I can find, sir. Actually, a rapporteur who has been nominated is Sanjeev Kumar and Shrikant Baramkar. But I didn't find in this list, sir, participant list.
Okay, no matter. I will prepare the reports. Okay.
Sir?
Yes.
Sir, poster paper was not in this session.
No, madam. It's
next session now going to start.
Huh?
Next session now going to start it.
In this passport.
Yes, sir.
Same meeting ID and same passport?
Yes. I think you have to continue with this ID only, madam, poster session.
Okay.
Madam, Dr. U.S. Singh is there?
Yes, sir.
Is Dr. U.S. Singh is there?
No, U.S. Singh is not here, sir.
Okay.
No, U.S. Singh is not there, sir. He has not joined.
This is Professor Manohar Acharya.
Yeah. Namaskar, sir.
Namaskar. How are you? How do you do?
Fine, sir. Fine. Now I'm fine here.
Okay, good. Good. I'm very happy to listen to you. Okay, good.
Okay, thank you, sir.
Left, Professor Niranjana?
Yes, now Niranjana is here. Dr. Niranjana is here.
Okay, good. So the session is over, sir?
Yes, sir.
Okay,
Jayashree,
good.
What about the next session?
So all the best and God bless you all. Thank you.
Okay, thank you very much, sir.
Is closed, it seems, sir. It was running separately, sir.
Over.
Doctor.
Hello, sir.
Dr. Niranjana?
Yes, I think we are finished our presentations, isn't it?
Yeah, completed all these things.
Yes.
And now close the sessions. if you interested to say any words,
session,
if you interested to say any words, you can say.
Yes, I will. Let me conclude.
Okay, sir.
Let me conclude. The session is chemical and non-chemical methods for disease management was justified with the speakers, starting from Pratibha Sharma and other speakers. Probably we are not able to give the opportunity for one candidate. She is from Russia, Oksana, and because of communication and this gadget problem, she could not make the presentation. So Pratibha Sharma has given very nice lecture on the lead lecture on the importance of biocontrol agent and increasing efficacy in post-harvest disease management. It was informative, and all other three invited speakers, so that they have given the international the scenario on the chemical and non-chemical treatment for the control of disease management, and all the youngsters. So youngster speakers, they are working very well on the aspect which is now it's a challenging part. So we have to go for, as I mentioned, that in future there is no chemicals. So we have to go for alternative strategy is the eco-friendly approach. Starting from seed-borne pathogens or surface-borne pathogens or embryo-borne pathogens, it's a challenging part as to control these problems through the biological means. So that this part, all the group of scientists who are working in the disease management is to take very seriously and think on this way and how to combat all these problems. So definitely this conference and this seminar has given a very good orientation for the people who are working in the area of disease management. Once again, I thank all the speakers, including lead speaker, invited speaker, and oral paper presentation, the scientists, on behalf of the organizers and on behalf of my own, and especially the people who are working with me, the senior professor Dr. K.P. Singh, a plant pathologist, well known, and from Pantnagar, and also reporters, Sanjeev Kumar and Srikant Varnkar. So we have done our best, and this session went on well. We are maintained the time, and I also thank Professor Manavachari and others who are logged in for this particular session and interacted and given their input for the betterment of science. So I once again thank one and you all, and thank you very much.
Okay, thank you very much, sir. Now you spare time.
Sir, when will poster session for 3B?
Poster session?
Poster session for 3B.
Madam, poster presentation was in another link, which it was completed already.
That link, but that was another.
Hello.
Sir, there was actually poster session third is written in.
Madam, this is technical session, madam.
You can contact to Jayasree. Manisha, you can contact to Jayasree.
Okay, ma'am. Sir, I have not her phone number. Please, sir, you can give me.
Madam, actually, poster presentation was on another link, madam. This is only for the technical session 3B.
But which one link, sir? Passport 8824176457.
1 minute, madam.
Pardon, sir.
ID number.
Sir,
poster presentation was in the link ending with the capital Z, small z09.
Capital Z.
Z09.
Sir, this is not.
Link 3. Link 3 was for the poster presentation.
Yes, sir. Yes, sir, I got it. Okay,
this is
sir.
for technical session, madam.
Okay, sir. Sorry, sir.
Okay, thank you very much for all. Okay, thank you, sir. Thank you very much, sir.
Thank you, sir.
Okay, thank you very much, sir.
What happened? Poster KP Singh?
Yes.
No, poster presentation. What happened now? How they are presenting?
I don't know about the Jayasree now mentioned that the now is one of the another session for poster.
Okay.
The poster presentation was running parallel to the technical session, sir. On another link.
Oh, it's going on.
So it was ended half an hour back only, sir.
But our job is over now.
Yes, sir.
Thank you very much.
Thank you very much, sir. Thank you very much.
Thank you.
Thank you, sir.
KPC.
Thank you very
Yes, sir.
much.
Thank you. See you later.
Thank you, sir.
Thank you, Niranjan sir and KP sir. Thank you, one and all.
Thank you, one and all. Thank you very much.